Hey everyone, I welcome you all to the live session on Artificial Intelligence tutorial by Intellipaat. This session is conducted by multiple experts who are having more than 15 plus years of industry experience. Artificial intelligence is one of the most happening technologies in the 21st century. Artificial intelligence is the ability of the machines to perform tasks such as learning and reasoning like a human mind. AI enables machines to analyze large data sets to answer complex problems. There are several applications of AI, like artificial intelligence in agriculture. The AI technologies are helping the farmers in decision making. For example, AI helps to decide which seed and in which condition it will give a better result. AI also gives the information about weather condition to get more yield. By using AI, one can overcome traditional farming problems. On saying that, now let's see the agenda of the day.
Now let's discuss about the particular what is AI basically. Okay, what is AI? And so artificial intelligence into very layman language is AI is a collection of algorithm. AI is a collection of algorithm. Algorithm is a mathematical function based on the logic, based on the theory, okay, based on the logics or theory, some statistic or probability approach. And industries, we use this AI algorithm to design intelligent software or applications which can perform some task similar way any experienced or intelligence person can perform, right? And then this approach can be used to automate lots of operations or to make lots of decisions in the industry. You see, as a experienced persons, we can easily, let's suppose that you're working from the last 10 years in any industries, manufacturing, service industries, and day to day, your job, you're making a lot of decisions. And for that, you're using your experience, you're using your brain, and you're making a lot of decisions in order to, to complete job or in order to complete a particular job or to perform some actions, right? Now we can use AI algorithms and we can design intelligent software applications which can perform same task in a similar way as any experienced person is performing. And in this way, we can automate lots of the operations. Okay. So artificial intelligence, you can also take a very, straightforward definitions. AI is technical science that study and develop theories, methods, technology, and applications for simulating and extending human intelligence. Okay, so basically, as we discussed, it is a collection of algorithms based, and these algorithms are based on the statistic, probability, or linear algebra, calculus, some theory, and the concepts based on that. And we can use this approach to, or we can use these algorithms to design intelligent software or application which can perform some tasks similar way any experience or intelligence human perform. So AI itself is very, very vast field. Different field nowadays we use artificial intelligence to design different applications and solutions. In the field of data science, we use it AI algorithms or these algorithms to design end-to-end data-driven solution.
And as we know, AI is one of the most transforming technology nowadays, and almost all industry, if you see manufacturing, retail, healthcare, or almost or agriculture, almost all industry nowadays, they are using it, they are adopting it and designing different solutions and application. So in very layman language, if I define the AI, so I'll say the AI is a collection of algorithm. Artificial intelligence is a collection of algorithm, and algorithm is a mathematical function based on some logics, rule, or theorem. Okay, and in industries, we use this algorithm to design intelligent software or application which can perform some task similar way any intelligence human can perform. Or we can use these algorithms to build intelligence into some software or applications which can perform some task normally require human intelligence, like to recognize family members or to detect suspicious activities. We use our intelligence. right? And then we can be perform such kind of the task to, we can understand the languages, we can give some recommendation, we can make some prediction. Now using AI we can design intelligence software which can perform these kind of the task. We can build intelligence using AI algorithms, okay, and then we can use this particular software, intelligence software, to perform such kind of task normally require human intelligence, or normally require human intelligence to perform it. So almost all industry, if you see, almost all industry nowadays, they are using it, they are adopting these technologies and designing different software and applications, okay. And if you see the most of industry nowadays, the most of industry, they are using AI to enhance current product. Let's say like a Netflix or Amazon, Flipkart, these industries are using, so most of industries are using it to enhance their current product. And most of the banking, finance, insurance industries are using artificial intelligence to automate operations or actions. Some industries, they are using AI to create some new product or to pursue new business market. So most of industry, they're also using AI algorithm to increase the productivity or to increase the customer satisfaction or enhance customer satisfaction. Like mostly the service industries, or if you see, service industry, they're using chatbot applications and using it to enhance the customer experience. Or Amazon, they're using it AI algorithm, so within a second we can analyze the thousands of the reviews. So some industries are using AI to enhance customer experience, okay, or to automate operations, actions, or to make a better decisions, or to make a fast decisions. Or some industry, they're using it to enhance the current product also. So different industry nowadays, they're using AI algorithms or artificial intelligence in different way, okay, and designing different applications and the product, okay. So AI itself is very vast field, I'll say, okay. And in very simple language, you can just define that artificial intelligence, AI, it is a collection of algorithms, and industries are using these algorithms to design intelligent software or application which can perform some task similar way any experienced or intelligence person perform. So there are the various way to build intelligence into any software using AI techniques like genetic algorithm, fuzzy logic base. Then one of the approach that nowadays it is widely used and most of industry they're using it is machine learning, ML. One of the particular approaches to implement AI is machine learning algorithms, okay. So machine learning is one of the very famous techniques to build intelligence into any software or application. And machine learning is subset of AI. So even if you are working on the machine learning, you can say on we are working on the AI only, AI field only, okay. And you can define that machine learning is collection of powerful AI algorithms, is a collection of powerful AI algorithms which uses data to build intelligence into any software or applications. So in the field of machine learning, we discuss or we learn various different algorithms like linear regression, logistic regression, support vector machine, clustering algorithm, recommendation system, and all these algorithms, is uses data to build intelligence into any software or applications. Machine learning algorithms are very powerful and capable to learn any kind of patterns present into the data sets. These algorithms are very powerful and capable to learn any kind of patterns present into the data set, linear, non-linear, any kind of pattern. But these algorithms uses data to build intelligence into any software or application. But due to digitalization nowadays, data is not big deal. Almost all industries has a huge amount of data. Service, manufacturing, they're collecting a data using IoT, or service industries or banking, finance, insurance. All these industries has huge amount of data of their customers, their product, their services, and they're using machine learning techniques to build intelligence into any software or to design intelligence software or application, because these algorithms are very powerful and capable to learn any kind of patterns. But there are also some other way, to build intelligence into any rule-based approach to build intelligence into any software or applications. Machine learning, these algorithms learns patterns, and based on that we design intelligent software or applications. So there are the different algorithms: linear regression, logistic regression, support vector machine, k nearest neighbor, naive bayes classifier, clustering algorithms, recommendation system, dimensionality reduction, different techniques. There's also one more field here, and it is deep learning, DL. So deep learning is again subset of ML. Okay, deep learning is subset of ML, and deep learning algorithm also uses data to build intelligence into any software or applications. And during the training, it's learned the patterns from data. Okay, but these deep learning algorithms are inspired from human brain function. If you see the machine learning, we mainly discuss different algorithms like a linear regression, logistic regression, support vector machine, naive classifier, or clustering techniques. So all these algorithms are nothing but mathematical function based on the different theory or the logic. But deep learning algorithms are very popular and powerful because these algorithms inspire from human brain function or the architecture based on human brain function. So in human brain, we have a network of natural neurons, and all the neurons responsible to process different signal or information in the real time, and so that we perform a different actions. Like we can easily recognize our family members, objects, understand language, make some prediction. So the network of natural neuron in the human brain responsible to process different signals and data or the information, and so that we perform various action. So deep learning architecture, so some of the AI engineer, they design some algorithms or the which is inspired from human brain function, or the architecture is based on or inspired from human brain function. And here we design the network of artificial node, and every node consists some mathematical function, and in the real time whenever we map our data, it learns patterns from data, performs some mathematical operations, and then learn the pattern, and based on that we use this approach to build intelligence into any software applications or make some prediction. So deep learning algorithms are very popular and very powerful. Okay, even if you see this website, so there are the different deep learning algorithm, and like convolutional neural network, recurrent neural network, LSTM, GAN, autoencoder, deep belief network. This person does not exist.com. So as you can see, human with this face does not exist in the real world. It is designed by deep learning algorithm GAN. And even you can also download the white paper. Okay, from here, from this right bottom, you see there's a link. So all this particular human with this face does not exist in the real world. It is designed by deep learning algorithm. So whenever you refresh this website, it's the algorithms behind the trained model behind this website or the server is making some prediction, and we have a different artificial face is written the different artificial face, as you can see. So we widely use, so machine learning algorithm is mostly it is used whenever we have structured data. Okay, whenever we have structured data or tabular format of data, we mostly use machine learning algorithm to design different solution. Okay, like predictive model, recommendation system, forecasting model. Okay, we mostly use a machine learning technique if we have structured data. Deep learning algorithm mostly we use it for unstructured data to learn pattern from unstructured data, because these algorithms are very powerful. And unstructured data means if you have information or data in the form of images, text, audio, video, so for that we use a deep learning algorithm. And there are different tools using that you can implement it. Okay, you can implement or design different software or applications. Okay, that we'll discuss in detail. So as you can see, the AI is just a collection of algorithm, and in different field we use these algorithms and design different applications and the solution. So there's also one more field here. It is mainly a particular data analysis. So in the field of data analysis, we deal with structured data. Okay, and we use a statistic and data visualization approach and analyze it and extract hidden informations or the pattern and design some analytic report. And then we share this analytic report with the managers or the policy maker of any company, and they use this analytic report to get the answers of all the business question. Okay, So here we don't use any machine learning or AI algorithms. It's purely based on statistic and data visualization approach. We can design different analytic report or analyze any data. Okay, so there's also one more field here, data science, which mainly consume the machine learning algorithms or uses machine learning algorithm to design data driven solutions or the predictive model. Okay, so in the field of this, we use this particular algorithms. Now let's understand through some one example here. So in almost all industry, if you see in almost all industry, banking, finance, manufacturing, retail, all industry, policymaker or managers or the director, they use a different dashboard to monitor performance of their industry. Dashboard as a data reporting tool, they use a different dashboard. In the dashboard, there's a different KPIs. KPIs stand for key performance indicator, which indicate overall performance of their industry. For any industry, the KPI, it could be total sales, total production, and if the graph is moving into the upward direction, so it means that everything is good. Okay, so for one of the banking industry, for them KPI is total number of the customer, and from the last couple of months the graph is moving into downward direction. Okay, so all the top managers, policymaker, they are not happy to see such kind of a trend. They want to know exactly what has happened in the past, why the customers are closing their account, which factor influencing such kind of a trend. They want to know exactly. So they can use a data analysis approach and ask the client or the bank, okay, give us the information of the customers who left the bank, and also give the information of the customer who did not left the bank, and then we can use a data visualization approach or statistical approach to perform analysis using a Python, R programming, or any other no code based tool or the code based tool. We can use it to perform analysis or Tableau or the Power BI and design some analytic report and share with the analytic report with the managers, and then they can use this particular analytic report to get the answers of all the business question. Right, so there's also one more field here, the data science, which mainly consume the machine learning algorithm. So we can design the analytic report, and using the analytic report, the managers, they can check it, what has happened in the past, why the customers are closing their account, which type of the customers are closing their account. They can easily get answers of all this business question. And accordingly, the policy maker can can design some new policy or modify existing policy. But to design the new policy is not possible within the 1 or 2 days, or to get the result on the ground level within the couple of the days. So meanwhile, the bank do not want to lose more and more customer. So we can use a machine learning algorithm and design the predictive model. And using a predictive model, the managers can check it, or bank can check it, which customer is more likely to left bank in the future. And we can also perform model interpretation, and with the help of it, they can check it why the customer will left bank in the future, so that the bank can provide some offer so that customer will not left bank or resolve their problem. But maybe the similar issue the bank will face in the future, so again we can use machine learning algorithm or deep learning algorithm and design some recommendation solution. And using a recommendation engine which take the input from the customer feedback, the bank existing policy, government policies, and based on that recommend or written different suggestion for the policy maker, and the policy maker can use it while designing a new policy. And in this way we can use this field to solve end-to-end data driven solution. So there's also one more field here, and which is mainly known as image processing. Okay, image processing. So whenever you have a data in the form of image, okay, whenever you have data in the form of image or the video without audio, so we use image processing technique to analyze data, or to resize or extract remove the noise, which is basically based on some linear algebra or calculus functions. We use it, okay, to perform image processing, to remove the noise or to resize, reshape, or filter. We use it to clean the image data, or to understand the image data. We use image processing technique. So there's also one more field, which is the combination of image processing and AI algorithm, and many deep learning algorithms we use it, and it is known as a computer vision, CV. And the goal of, so we can easily interpret the images, we can easily interpret videos. Okay, now the goal of computer vision is to build intelligence into our software or application, so that it can also interpret images and videos in the real time and make some predictions or perform some action like face recognition, object detection. Okay, these kind of applications we can be designed using computer vision technique, or to analyze the different medical images and written reports. So there's also one more field, like in the field of signal processing also. So signal processing, or in the field of NLP, we use a particular this deep learning technique, natural language processing. In that, we want to build intelligence into our software so that it can understand human language and perform some action, like a text to speech, speech to text, feedback analysis, or text classifications. So such kind of application we can design using a NLP, in which is the combination of the text pre-processing and deep learning algorithm. We can use it to build intelligence into any software. So depend on your application, we select the algorithm. Okay, so in the deep learning also, we are going to discuss a different algorithm, like a CNN, RNN, LSTM, autoencoder. Okay, or so depend on your applications, we select these algorithm, because accordingly they process, because all these algorithms process a data into different way. If you see, when we try to recognize our any family members or detect any objects, so human brain process those data or the images in different way. When we try to understand the language or translate one language to another language, or read textbook or watch movie, so human brains process those signal into different way, and so that we perform specific output. Similar way, there are also different deep learning algorithms, and depend on your, based on your applications, we can select those algorithms, and design some intelligence software or applications. So there are the different tools, using that we can implement or design AI based software or applications. So mainly you can just categorize as a particular code based tool, and second is a no code based tool. Yeah, no code or the less code. So code base means where we can use a Python programming, R programming, MATLAB, these programming language, and we can import data, even if you have a data into the image, audio, video, text. Okay, in all these format we can we can import it, and we can perform some pre-processing. We can define machine learning AI algorithms, and then we can map it and design some software or applications and deploy our product on the production environment using cloud services as well, using some code based platform like a Python programming or R programming or the MATLAB, right? So there are also some no code based platform, means in that you don't need to write any single line of the code. You can just, we have some pre-configured node, you can just drag and drop and connect it. Okay, and design some application and the software. Okay, so like Nime, Rapid Minnow, or ML Studio of Azure, or AWS SageMaker, or Nime, or you can even also use it Rapid Miner, ML Studio, Nime. Yeah, these are different tools, or AutoML. Okay, in that you can just load your data set, define the problem, or you can drag and drop and connect it, and you don't need to write all the 50 or the 60 line of the code, but obviously there will be some limitation. So mostly in industry we use some code based tool like a Python. We mostly we use it to design end-to-end solution. So we discuss more about the DL also. Don't worry about that. I'm just giving high level overview of these machine learning and deep learning algorithm and different tools. Then we also discuss more about it. So there are the different in the Python. If you see, the Python is widely it is used nowadays. Okay, to design end-to-end applications, computer vision, NLP, or data science based solutions we can design using a Python programming, because of it's open source multi-purpose programming language. We can use a Python in the field of data science, computer visions, or web development, automation, networking. In almost all different domains we can use a Python GUI as well. And and it also has a lot of libraries, and using that it's also support the different open source or third party libraries, and that we can use it to design end-to-end applications like NumPy. So if you're using a Python, okay, so if you're using a Python, so in the Python there's a lot of very popular libraries, and using that you can design different application. or you can import, export data, perform some operation, pre-processing, implement machine learning and deep learning algorithms. Like in Python, we have a NumPy, Pandas, Matplotlib, Seaborn, sklearn. Okay, and then again some more very popular library like NLTK, Spacy, Gensim, then OpenCV, Librosa, TensorFlow, Keras. So you see NumPy, it is stand for numeric Python. You can solve some numeric algebra statistic problem, or you can store your data into the form of array. Pandas for data analysis, to import, export data, to perform some data pre-processing, data analysis. You can be do the pandas. Matplotlib and the Seaborn for data visualization. Data visualization is a graphical representation of information using a scatter, box plot, or pie chart, different graphs. You can plot it and perform analysis. Scikit-learn is very powerful library of the Python. It is used for to implement the classical machine learning algorithm, data pre-processing, feature engineering, feature extraction, feature selection, matrix, everything you can be do using a scikit-learn. Okay, or you can export train model, you can load it, you can do almost all these machine learning operation using a scikit-learn machine learning Python library. Then again, in the field of NLP, we widely use NLTK, Spacy, Gensim, these library, NLTK, Spacy, Gensim, these library, we widely use it to perform text pre-processing or to perform vectorization of the text data, or to implement to perform the particular design the NLP based application. We use NLTK, Spacy, and Gensim, these library we widely use in the field of NLP. Whenever we have data in the form of images and the videos, to perform some pre-processing, we widely use OpenCV library. Similarly, if you have a data in the form of audio, so we use a Librosa library, or signals, so we use a Librosa. And to implement the deep learning or neural network algorithms, we use a TensorFlow and the Keras function. TensorFlow is designed by the Google team. Okay, and it's also we can also use the TensorFlow applications or their libraries or their functions, or you can say their APIs, to implement neural network and deep learning algorithm. Keras is also widely, it is open source, and we can be use it to implement neural network and deep learning algorithm. Similarly, a Microsoft MXNet, Facebook PyTorch, their framework also. So there are lots of different framework like a TensorFlow, Keras, MXNet, PyTorch. All these framework are designed by different the top industries like a Facebook or Microsoft, Face or Google, and we can use their framework to implement neural network or deep learning algorithm. Like we use a scikit-learn to implement a neural network classical machine learning algorithm. Similarly, we can also use a TensorFlow, Keras, PyTorch, or MXNet to implement neural network and deep learning algorithm, or implement deep learning algorithm. We can define it and design some applications. All right, so now we start with the introductions to ML. So as we discussed, machine learning is a subset of artificial intelligence, and it's one of the very popular approach to build intelligence into any software or applications, because these machine learning algorithms are very powerful and capable to learn any kind of patterns. And first thing is, it uses data to build intelligence into any software or applications. Okay. Um, and these algorithms are very powerful and capable to learn any kind of patterns built into the data sets. And this approach is widely we use it nowadays, because due to digitalization, data is not big deal for most of industry. Even they are collecting using IoT and different digital technologies, they are collecting and digital data. And now all these industries are using machine learning algorithms to design intelligent software or applications, and then later on they are using it to automate operations or to improve customer experience or to enhance the current product. So you see, if I talk about the approach or the strategies that we follow to design any applications, even in the field of data science, like as we discussed, we use a machine learning algorithm. Like in the field of data science, we use machine learning algorithm to design end-to-end data-driven solution. So what happened exactly? So whenever we start with any project, the first stage is understand the business problem.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Or that's something very, very important. And even as a consultant, like in the day to day my job, I also work with the different business teams and development team, and design strategy or the solutions, okay, for them using cloud services like Azure and their cognitive services or machine learning service. So in the starting, and very important first point is understand the business problem and their expectation from this particular solution. That something is very important to benchmark in the starting, okay. And very important step, I'll say. Let me even explain you one example here. So let's say there's a one service industry. Now the service industry want to automate their operation, the customer service, and for that they want to design the chatbot application. Okay, it is fine, we can design the chatbot application and we can automate operation, but at the same time they also want to reduce. So as of without the chatbot, as of now, to solve, average time is 5 minutes to solve a particular customer problem or query. They want to automate operation using a chatbot, but at the same time they also want to reduce the average time to solve the customer problem. They want to make it 2.5 minutes. So here it is your and objective and goal. Some industry want to use the AI so that they can increase the productivity by 20% or reduce the downtime in the manufacturing industry by 10%. So it's very important to send benchmark in the starting and understand the business problem, understand the business requirement. Entire thing is very, very important. The second thing is domain knowledge is very important, and that's why the nowadays AI has become very popular, because in all different domains, like finance guys or manufacturing person, finance guy, operations team, even they are learning the artificial intelligence, e-commerce persons or retail sector experience persons or the service side, management side, every all domains experts, they are learning artificial intelligence and designing, becoming a AI expert in their domain and designing different application and the solution. Domain knowledge is very, very important. Sometimes even if I work with some medical images, so sometimes we also schedule many meetings with the SMEs or the doctors to only to understand data, or medical guys only to understand the particular data. That's something very, very important, like data understanding and domain knowledge is very important. So once we are good with this particular part, then we basically collect data. So data collection is the more part of data engineers in the industry, and data engineers, they basically collect the data, perform ETL, and create data warehouse for data scientists. And as a data scientist, we collect data from, we interact with the data warehouse or data lake. Data warehouse means where we have huge amount of stored data coming from the various sources. It may be structure. If it is a data warehouse, so data will be the structure. If it is a data lake, so you have structure or unstructured all data. Then we perform data pre-processing also, because maybe sometimes your data is very missing value, maybe there is some unwanted value, unwanted columns, rows, okay, or duplicates value. So we can use a Python if you're using this tool, so we can use their functions to perform the data cleaning. And after that we perform feature selection, okay. We perform data feature extraction. Let's say if you have a data in the form of the text, so we cannot directly map this data on the algorithm. It's very important to convert the data into the numeric format, but without losing the context. Without losing the context, convert the data in text into the numeric. So we use our various approach format, perform data pre-processing, encoding, or word vectorizations, okay. So then based on that, once we have very perfect data, then what we do is we split it for the training and testing. And based on the business problem, based on the features that you want into the final model, based on the particular complexity present into the data set, based on the business problem, whether you have a regression, classification, forecasting, recommendation system, anomaly reductions, dimensionality reduction. Based on the business problem, we select algorithm. Then we map our training data on the algorithm and start the training process. During the training process, because machine learning algorithm are mathematical functions, so it's learn the patterns. Okay. And after completing a training, we say as a model. Before the training, we say as an algorithm, and after completing a training, we say as a model. And then we check the performance of this model using a different matrix, like a recall, F1 score, precision, accuracy, which R score. We check performance with the testing data. And if the performance is good on the testing data, on unseen data, so we export our model and save it. Then we can use a cloud services like AWS, Azure, their virtual machine, their Docker. We can create a Docker, also create a Docker image, Kubernetes service, or cloud services. We can deploy to the production environment and perform testing in the real time. Then again, we also monitor the performance of in the production. That is nowadays widely, it is famous, MLOps, machine learning in the operation. Because over period of the time, maybe the performance will be decreased. You cannot use one model for the lifetime. Maybe the during over period of the time, the performance of the machine learning will be decreased. Okay, so we use MLOps sections where we monitor the performance of model in the productions or during the operations, and we also use the concept of retraining or active learning, or we retrain our existing model in order to maintain our the objective, the benchmark.
So now let's discuss more about the machine learning part. So based on the particular learning approach, we can categorize all the machine learning or learning algorithms. You can categorize as a supervised, unsupervised, and reinforcement learning techniques. Okay, reinforcement learning. Supervised machine learning algorithms is basically uses or it's require label data to learn the patterns. Okay, it uses the particular label data to become intelligence or to learn patterns. Unsupervised machine learning technique is basically deal with unlabeled data. So supervised machine learning algorithms is require label data to learn patterns and become intelligence to make such kind of any kind of the prediction. Or label data means information with actual tag. It is known as a label data. And we can use a supervised machine learning algorithm to solve two kind of problem. I'll discuss about the reinforcement learning also, but here you see. Supervised machine learning techniques is algorithms is uses the label data to learn the pattern and to learn the patterns or to become intelligence. And using mainly we use a supervised machine learning algorithm to solve a regression and the classification problem. Regression and the classification problem. Regression is the task of predicting continuous value, and the classification is the task of predicting categorical outcome. Regression is the task of predicting continuous value, and the classification is the task of predicting categorical outcome. So you see, recently we use Google Teachable Machine Learning platform, and in that we design some AI-based software applications which able to classify, the particular input image is belong to the human or the mobile phone, or the label 1 or the label 2. So every times for any new input images is making a prediction whether it's belong to class 1 or the class 2, right? So it's a classification problem. So as we discussed, classification is the task of predicting categorical outcome. Okay, so we train on our algorithms on the two label. Okay, we use a particular two different labels of the data, and we train on the particular algorithms on it. And in the real times, when we are making a prediction, is predicting that what is the probability for any new input images to belong as a class, to belong into for the class 1 or the class 2, right? So we know that because we have some historical data and we are mapping on the algorithms and algorithms learning pattern, and then in the real time is just making a prediction that what is the probability that this will be belong to the class 1 or the class 2. So you can say we know the outcome. It will be either belong to class 1 or the class 2. But algorithm is just making a prediction. So it's the task of predicting categorical outcome or the the non-label, right? Either it will be belong to the class 1 or the class 2. It's not going to make a prediction as a class C, because if you train on the 2 label, so it will make a prediction for any new input images, from the both label only. So we know that whether it will be belong to label 1 or the label 2, but so you can say the task of just predicting categorical outcome. So let's suppose that you want to design some kind of applications you want to design some kind of application for any industry. So you see, if any particular industry, let's say after this particular the training, okay, maybe the Intellipaat team will share some Google, some feedback link, and all of you are going to give the feedback based on your experience. So for for a particular day, they are handed of the candidates, they submit the feedback for doing a different course, more than even the handed of candidate or the participants submit their feedback. And the Intellipaat teams, they basically use some AI-based software or applications which going to classify, they read the feedback and automatically classify that how many feedback belong to the positive class, how many feedback belong to the negative class, how many feedbacks are unique, how many feedbacks are similar. So there are the fixed categories, and there's some AI-based software which just classify that the top 5 positive feedback, top 10 negative feedback based on the context present into the data. It's not just based on some vocab or some word. It's just like as we interpret any text, similar way AI-based software or application, it's read the particular the text or meanings, and based on the meanings is categorized into different labels. Okay, it's make different labels and automate written the report, and with the help of the report, the Intellipaat team or operation teams can check it, how many feedbacks, how many positive feedback, how many negative feedback, how many unique feedback, how many similar feedback. Or let's suppose that you want to design some kind of a software application for any banking industry, so that they can they can use it to check that what is the probability that particular customer will left bank in the future. So here we are just using AI-based software applications to, it's just AI-based software application is just predicting that whether customer will left bank in the future or not, and what is their probability. So what is the probability for any new input images? What is the probability that two particular customers has a pneumonia or not based on the checks Excel images? What is the probability that particular persons has a malaria based on the particular cell images? So every time the model is going to predict that, either like yes or no, and as well as the probability for that particular class. So we say as a classification problem in all these particular, case, because here the AI-based model is just predicting some categorical outcome. Even the chatbot application is also belong to classification problem. Okay. Let's say lots of industries like a Swiggy or Zomato or the Red Bus or lots of airlines industry, they also use the AI-based software or applications, AI-based chatbot applications. So in the real time, whenever the customer asks any or post any particular query, AI-based software or application is basically predict that what is the intent of question, and based on that, AI-based algorithm is search some particular database and return answer to the customer. So in the real time, whenever you post any query or you ask any question, so AI-based software or application is predict that what is the intent. It is a belong to the particular pricing, or whether it is a belong to the particular some bad experience, or the any kind of the product related query, or whether is it belong to the particular any service related query, and accordingly it's just send the particular based on the particular intent, AI-based software application search the answer from the database and return to the customer, or pass to the any team to resolve it, or pass to the categorize, pass to the L1, L2 or L3 level, and accordingly the teams of any industry solve the particular questions. Then second is the regression. Regression is the task of predicting continuous value. Regression is the task of predicting continuous value. So lots of insurance company nowadays, they're using such kind of algorithms. So in that, the customer can direct, mostly like automobile industry or the insurance company basically provide insurance services for vehicles. So there are lots of applications that are available in nowadays. We can just upload or the damage or the photographs of the damage, And AI-based algorithms is basically process it and also classify that whether such kind of damage or such kind of the particular case is categorized into the different label, and as well as also predict the claim the amount that company can process it, such kind of the amount, right? Or you can say regression is the task of predicting continuous value. So designing some application or the software which can predict the price of the any house or risk of any particular the task based on based on the particular some set of the features. Yeah, the time series is something you can also categorize here only. Yeah, yes, cinema. So the time series is basically the prediction based on the particular the time. So like a forecasting model, we can be use it. So we can also use a deep learning algorithm to solve some forecasting model. To perform some forecasting, we can design some forecasting model, and we can make some kind of forecasting like weather forecasting, sales forecasting, production forecasting, GDP forecasting. Okay. Then again, we have another case is unsupervised machine learning technique, unsupervised machine learning algorithm. So supervised machine learning algorithms uses labeled data and to learn the patterns or to become intelligence, and then we can use it to make some kind of a prediction. And we can use a supervised machine learning algorithm to solve regression and the classification problem, where regression is the task of predicting continuous value and classification is the task of predicting categorical outcome.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now the next is unsupervised machine learning. Unsupervised machine learning algorithm basically deal with unlabeled data. So if you don't, so in that we don't require actual label. Okay, information without tag, it is known as a particular unlabeled data. So we don't require the actual tag whenever we, okay, so we can use unsupervised machine learning techniques to design some application and the solution. Or you can say unsupervised machine learning algorithms. So we are using the particular machine learning. So AI is just kind of the concepts, okay? As we discussed in AI, we study different theory, different research, we design different approach, different technique to build human intelligence, right? And machine learning is one of the way to implement AI. And this is a very popular approach to implement AI or to build human intelligence. Okay. If you see here on the first slide, we discuss definition of artificial intelligence. Artificial intelligence is a technical science that study and develop theories, methods, technologies, and applications to simulate and extending human intelligence. So in AI, we basically, we discuss or we learn different theory, different approach, different methods, different technologies, different, way to build human intelligence into any software or to design intelligent software application. And the machine learning is one of the way to do that. So you can say here, using deep learning techniques, we can improve the particular over the model. Let's suppose that you're using some classical machine learning algorithm and the performance is let's say 70 or 80%, and it is not up to level in order to get an objective. Okay, so we can use some deep learning algorithm because deep learning algorithms are very powerful compared to the classical machine learning algorithms. So we can use a deep learning algorithm to get the better performance. Okay, and we can improve the performance of any particular software applications. The next part is unsupervised machine learning algorithm. Unsupervised machine learning techniques is basically deal with unlabeled data. Unlabeled data means information without actual tag. It is known as unlabeled data. So let's assume that, and we can use this algorithm, we can use this approach, or we can use unsupervised machine learning algorithm to design different kind of application. One of the application is a clustering. So what is a clustering? So clustering is a grouping of data points based on the similarity. And we use this approach widely to analyze any data. So let's assume that you have one folder, and a folder you have lots of images. You have some images of your parents, family members, some colleagues. You have different images, right? And you can use some unsupervised machine learning algorithms, and what it will be do that it will create clusters of similar images. It will return, let's suppose it will be written the 5 different album, and each album contain images of the same person, similar face. Each album will contain the images of the particular same face. So what we are doing it, algorithm is doing that is just grouping the data based on the similarity. It may be based on the facial expression. It may be based on the particular face. It may be based on the particular place. Grouping we can be do. And we can use this particular approach to analyze any data, to solve many problems. We can document clusterings. We can do that. We can create the clusters of documents. Okay. So the clustering is all about, clustering is all about grouping of data points based on the similarity. Then next problem is we can also use unsupervised machine learning algorithm to design some applications which can predict different suspicious activity. Lots of the credit card company or they use unsupervised machine learning algorithm to detect or to predict different anomalous point or anomalous activity or suspicious activity. And lots of the banking and the credit card company, they use it to unsupervised machine learning algorithm to solve bank laundering cases or to predict different suspicious activity, or even the intelligence. There is some AI based intelligence CCTV camera also available, and it also can be used to detect different kind of suspicious activity. Okay, so we can use unsupervised machine learning algorithm to design some applications like anomaly detection, or clustering also we can be solid, which is just a grouping of data point based on the similarity. So now next part is reinforcement learning. So the reinforcement learning, and you see in when we are using supervised machine learning algorithms, so we have some historical data, and our algorithms learning patterns from the historical data, and we are assuming that all the patterns present into the historical data, all kind of the informations present into the historical data, and we are also limiting the intelligence. Let's say I'll say that you have 2 books, and you can just learn or you're supposed to learn everything from the 2 books only. So obviously there will be some limited informations, maybe related to any application, but is sufficient for your application, but they will be limited informations, right? So when we are using historical data for any supervised machine learning algorithms to learn it, we're also limiting the intelligence, right? Somewhere for a particular time, right? So in the reinforcement learning, where our learning agent means our computer program is directly interact with a particular environment, and it takes some input, and based on that, it makes some kind of a prediction. If the predictions or the action is good, okay, so it uses the same approach and make again a prediction in order to get the more and more rewards from the environment. If the actions are bad, so you just change the strategy and use another approach and perform action in order to get more and more reward. We program it in such a way it will perform actions in order to get more reward. Reinforcement learning is more, it is similar to any kid is when any particular kids try to learn the bicycle, right? So if the action is good, so obviously like bicycle will or the motorcycle will move into the forward directions, and everything is good, and the kids are getting a rewards from the environment. Okay, and the rewards is something is bicycle is moving into the forward direction or left or right directions. But if the action is good, so is get some punishments, right? So we use a similar approach to here. So there are various different approach to build intelligence into any software or application. Reinforcement learning is one of that, and self-driving, chess, gaming, we use a reinforcement learning techniques. But it is not, as of now, it's more on the research. Reason is it's very time consuming and expensive process. very time consuming, expensive and lengthy process, reinforcement learning, but still we use into some of the industries, they use this approach to build intelligence into any software or applications. You can also design the chatbot applications using supervised machine learning algorithm. You can also design the chatbot application using reinforcement learning approach. So, but they will be difference between learning approach. Okay, as an perspective, there will be difference between the learning approach that both techniques are using that will be used. So far we discussed the machine learning as based on the learning approach or based on the particular applications, we can categorize it into the supervised, unsupervised, and the reinforcement learning techniques. And supervised machine learning algorithms is you just label data and learn patterns from it. And we can use supervised machine learning algorithm to solve regression and the classification problem, where regression is the task of predicting continuous value and classification is the task of predicting categorical outcome. Okay, and unsupervised machine learning techniques is mainly deal with unlabeled data, and we can use it to solve different kind of business problems. Like we can use it to design anomaly detections to predict different anomalous point or suspicious activity. We can use it to solve the clustering problem. So in the real times, even if you're using a machine learning or deep learning, so you can see that we have the particular entire flow chart here. So machine learning algorithms, as we discussed, machine learning is a collection of the powerful AI algorithms which uses data to learn the patterns. Okay, and these algorithms are very powerful and capable to learn any kind of the patterns and present into the data set, any complicated, any linear, non-linear, and it uses this approach to build intelligence into any software application. And we can use it to solve the based on the learning approach, we can categorize into the supervised, unsupervised, and the reinforcement learning. And supervised machine learning algorithms uses label data. It's require label data, and we can use the supervised machine learning algorithms to solve regression and the classification problem, where we say the regression is the task of predicting continuous value, classification is the task of predicting categorical outcome. We also require label data for whenever you're designing some forecasting model, we also need a label data. And so the forecasting, we make the predictions based on some previous train or the previous patterns. Okay. So some of the applications like sales forecasting, weather forecasting, or demand forecasting, stock GDP forecasting. These are some applications of time series analysis or time series forecasting. And here we deal with the time series data. Time series data means a particular information or data that recorded or the stored on the specific time interval, and such kind of data set is known as a time series data, and we use different forecasting techniques. So we can use a classical machine learning algorithm or even deep learning algorithm to solve a regression, classification, and the forecasting problem. Okay, we can use a deep learning algorithm to solve the regression problem also, like a neural network we can be used it. We can also use a particular neural network or deep learning algorithms like a CNN, RNN, LSTM to solve classification problem. We can also use LSTM to solve the forecasting problem or to design the forecasting model. Then again, unsupervised machine learning algorithms is basically, deal with unlabeled data. And we can use unsupervised machine learning algorithms to solve a different kind of problem like clustering, anomaly, or dimensionality reduction, recommendation system. So in the clustering is grouping of data points based on the similarity. And anomaly detections to design some model or applications which can detect different suspicious activity or different anomalous point in the real time. Dimensionality reductions is all about to compressing informations or reducing a dimensions of data without losing much information. Okay. Recommendation system, we can use again unsupervised machine learning algorithm. So even you can use a machine learning algorithm, classical machine learning algorithms also, or deep learning algorithms as well to solve clustering, anomaly detections, dimensionality reduction, or design the recommendation engine. Recommendation engines is all about to designing some recommendations Recommendation system is all about designing some software applications which can suggest or recommend different product or the solutions to customers or the policymaker of any company. So mainly in the real times, whenever we work with any business problem, the first and very important step is also to categorize it, whether it is belong to the regression or the classification, time series forecasting, clustering, anomaly reduction, dimensionality reduction, or recommendation system. Specify the categorize the particular problem, or right. Then we follow some other steps or to design end-to-end applications like data understanding. We work with the business problems or data understanding, data pre-processing, selection of algorithms based on the requirement, and then we go with the modeling approach. Right, Gunjan? So the prerequisite for this course is the basic knowledge of Python.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
And that's it, I think, because and also some basic idea about some mathematics part, like basic mathematics, like what is I'll say linear algebra, basic knowledge of it. Yeah.
So as we discussed, these algorithms are very powerful and capable to learn any kind of patterns pertinent into the data set. Then again, based on the learning approach, we can categorize into the supervised as unsupervised and the reinforcement learning. Supervised machine learning algorithms is you just label data to build intelligence into any software or application, and using it we can solve regression and the classification problem. Or you can also say we use to solve the regression, classification, or forecasting, time series forecasting problem, or to design these solutions we use supervised machine learning algorithms, or we use a labeled data or supervised machine learning algorithm. Where regression is the task of predicting continuous value and classification is the task of predicting categorical outcome, and time series is the prediction based on the particular previous trained or pattern. Then again, we also discuss unsupervised machine learning algorithm, and we can use it to solve clustering, recommendation system, or clustering is all about the grouping of data point based on the similarity. We can also design solutions like anomaly detection. It's all about detecting the anomalous point or suspicious activity, and recommendation system to design some solution which will be recommend different suggestions or suggestions to policy maker of any company, or the product recommendations, sales recommendations, such kind of, or movie recommendation system. Dimensionality reduction is all about here we use some unsupervised machine learning techniques can be used to reduce dimensions of data. So it also helps to reduce the complexity. Okay. So we can design all this solution using classical machine learning algorithm, and we can also use a deep learning algorithm. The only difference is, so in the classical machine learning algorithm, we have a different algorithm, and all the algorithms based on the different logic theory or mathematical linear algebra probability theory, different approach. But deep learning algorithms are inspired from the human brain function, or here we design the network of artificial node, and every node consists some mathematical function. So if I talk about the regression algorithm, some classical machine learning algorithm, so like let's say like a linear regression, okay, decision tree regression, neural network regression, okay, you can just in the deep learning you can take it like a linear regression or polynomial regression, decision tree regression, okay. So you can be used some kind of a regression algorithm. Similarly, a support vector regression, SVM regression. Some classical machine learning algorithm, and it can be used to solve classification problem like a logistic regression.
or you can also use a decision tree, or you can also use assemble learning techniques or random forest boosting, XGBoost techniques, or knife based classifier, okay, k nearest neighbor. Such kind of algorithms you can use it, or support vector machine also to solve classification problem. To solve the time series forecasting, you can use a different statistical technique, like you can use AR, MA, ARIMA, okay, autoregressive integrated moving average, ARIMA, to solve the forecasting problem or to design the forecasting model. Similarly, you can also use some different classical machine learning algorithm to solve clustering problem, like a k-means clustering algorithm, hierarchical clusterings, or DB scan, a different kind of a particular clustering algorithm, classical machine learning algorithm. You can use it to solve clustering problem. To solve the particular anomaly reduction, you can use different algorithms like isolation forest, or one class SVM. You can be use such algorithm to solve anomaly reduction problem. For dimensionality reduction, you can use some algorithms like a PCA, SVD, LDA, or TSNE. You can use some algorithm to solve a dimensionality reduction, or to reduce the dimensions of data, or to compress information you can be using. For recommendation system, you can use a matrix factorization approach to design the recommendation solution. So these are a different classical machine learning algorithm, and all these algorithms based on some theory, some rule, some mathematical function, or different approach, linear algebra or the probability theory. Okay, so in that, the classical machine learning algorithms, we can be use it depend on the depend on the problem statement, whether you have a regression, classification, or depend on the complexity present in your data set, or depend on the features that you want to see into your final model. You want the training time should be very less, or prediction speed should be very fast. So depend on this scenario, you can select the algorithm and you can design some kind of a solution. Mainly we are going to use a deep learning algorithm. Okay, in this course, we'll be focused more on the deep learning algorithm. We can also use a deep learning algorithm to solve regression, classification, all this problem, right? So you can use a neural network or deep neural network to solve a particular, okay, you can use a deep neural network to solve a regression or the classification problem. If you have normal structured data, so you can use a deep neural network to solve a regression or the classification problem, right? If you have a particular the image data, so we can use a particular CNN based algorithm to solve a regression or the classification problem, convolution neural network. Okay, or you can also use the particular recurrent neural network depend on the data. If you have a text data or the time series data, so text data, so we can be use a RNN, okay, to solve the classification problem, recurrent neural network. Will be also discussed about LSTM, long short-term memory. This algorithm also can be used to solve a classification problem or to design the chatbot, or whenever you have a text data, we widely use LSTM or RNN such architecture, or CNN whenever we have images or the video form of data. Normal DNN can be used to solve a regression also in the classification also, but if we use a DNN if you have structured data like tabular format of data. But if you have an image or the video, so we can use a CNN, or even audio data also we can use a CNN, or RNN or LSTM is also can be used for the text data sets. It's not compulsory. If you have a text, you cannot use a CNN. Even you can use a CNN, but mostly we use a RNN and LSTM. It's also depend on your application. Selection of algorithm is also depend on your application. Okay, there's one question. In industry, do you use some algorithm, for instance, for the clustering problem, and then select one giving the best performance for it? So you see, there are multiple approach. I'll discuss this particular part. Now we are going to talk about also the machine learning pipeline. In that, Anirban, we discuss about this particular part. Okay, just let me complete the slide. If you have a time series data, let's say you want to design solutions like sales forecasting, demand forecasting, GDP forecasting, weather forecasting, or if you have a time series data, right? Time series data means a particular data is recorded on the specific time interval and you want to design some forecasting model. So we widely use deep learning algorithm, RNN, LSTM, or GRU, such type of architecture. Recurrent neural network, long short-term memory, gated recurrent unit. You can use these architectures to do that. For the clustering, we can also use the autoencoder. For anomaly reductions, we can even also use the autoencoder. There is a variation of autoencoder. Autoencoder with LSTM can be used. For dimensionality reduction, there is an autoencoder we can be used. For recommendation system, you can even also use the autoencoder because there's the variation of autoencoder, or you can also use the particular Boltzmann machine or rusticated Boltzmann machine, RBM, such kind of architecture. So there are the different architecture or different deep learning algorithm that's defined by the different AI engineer, and we can use those architecture to solve similar kind of a business problem. Okay, if the similar type of business problem we have, so we can use those architectures and solve it. So we are going to mainly discuss on these deep learning algorithms, like what is artificial neural network, what is deep neural network, their mathematical functions. Okay, then we'll also spend some time on CNN, convolutional neural network, recurrent neural network, long short-term memory. Okay, autoencoder, the variation of autoencoder, how can we use it to solve it. So we'll be focused more on the deep learning algorithm. Okay, how to use this deep learning algorithm to solve regression, classification, clustering, anomalies, or recommendation systems. Okay, there are the different classical machine learning algorithms, and you can also use it to solve similar kind of the problem, but we mainly focus on the deep learning architecture. The reason is, if you go with the machine learning, so in every machine learning algorithms, there will be the new concept, because every maybe some algorithm based on the probability theory, some algorithm based on some particular research, some algorithms based on the linear algebra. But here, all these algorithms are based on neural network only. So if you're good with a neural network, so you can easily understand all these particular architecture. Yes. So you can also say that deep learning algorithms are extension of neural network, not ML algorithm, is extension of neural network. So we have a neural network algorithms and the varieties extensions of neural network, where we talk about the different architecture of neural network, extension of neural network, not ML, you can see. So deep learning is just, is one concept, machine learning is another concept, but deep learning is also a subset of the part of it. How to use these algorithms and design solution, even if you are using machine learning or deep learning, any algorithm, but how to use it and design some solution. Now we are going to talk about this particular part. Okay, the entire step of approach. So whenever you have a particular, we start with a particular, any applications, step one. So whenever we start with any kind of application, the first and very important step is understand the business problem. Understand what is the business problem, what is your end objective, okay, and what is the customer client requirement is very important to understand it. Even in the real times, I personally, do the consulting also. I'm also working as a consultant for the multiple industries, and I'm also personally helping industry to use a digital technology to automate operations, or operations, or to bring the digitalizations in the defense service and the manufacturing industries. So every time, the first and very important step is what is the end requirement, what is their end objective. Whenever we use any software and the technology, what is your end requirement is very important to understand it. Let's assume that there's one industry, and now industry want to use this digital technology in order to increase the productivity by 20%, or increase the particular customer satisfaction by 10%. So it's very important to set the target. Okay, and accordingly we improve our solution. So is here also, whenever you're using deep learning algorithms or AI technology or AI algorithms to design any solution, the first and very important step is first understand the business problem and also set the particular the end goal or end objective of the client, okay, based on their requirement. Then step 2, that we go with we work on particular data, or we ask the particular data scientist, sorry, not a data engineers mainly. Okay, so data engineer. So in the step 2, we work on the particular data. Is very important to work on particular data or to understand data. Let's say you're working in any consulting company or service industry, and now you have a particular, you're going to work on one particular healthcare projects. Your particular project is related to the healthcare sector or the medical sector, and you're going to deal with the different medical images or different images, the medical images. Okay, but your background is not you don't have any domain knowledge. Okay, so the first and very important step that we do is we do research, we understand data. Okay, and sometimes we also schedule many meeting with the SMEs, okay, or the domain expert person only to understand data and the variables. And sometimes as our developers, we also sit with the particular subject matter expert or the domain expert persons, and we design the solution and interpret it with the help of the SMEs or with the help of the SMEs or subject matter expert or any domain expert persons. And so it's very important to understand data also, and the background knowledge is very, very important. And that's why nowadays everyone, even if you see the manufacturing or the service industry, banking, finance, so in all the industries, the senior managers or the top leaders, they're also learning, or developers, they're also learning the AI and data science, because they're working from the last 10 or the 5 year in that particular area, and they want to become the AI experts, so they can automate operations, they can design the different solution for the industry. So it's very important, it's very matter like data understanding and domain knowledge. And if you're very beginner, so we start with the data analysis part or data, we, if you don't have any idea about the data set or the variables, so we do the lots of research to only to understand data and or the variables present in it, or so that we can later on we can interpret it final result. So this is the step 2, we work on the particular data or data understanding. Then again, what we do is the step 3, after doing this particular part, then let's say if you're using a machine learning or deep learning algorithm, so let's say we also perform the data pre-processing. Actually, pre-processing. Okay, so let's suppose that in the pre-processing there are lots of things come. So let's suppose that you have a data in the form of a signal, okay, audio signal. So we cannot process such a data to machine learning algorithm, because machine learning or deep learning algorithm is a mathematical function, is internally a mathematical function. And when we map the particular data on these mathematical function, so it basically perform mathematical operation or calculation. And mathematical equation can only understand the numerical form of data, but you have a data in the form of signal. So we can use a different techniques to convert into the numeric, but without losing the information or the context. Okay. So if you have a signal data, so we use a Fourier transformation, different kind of the transformation to convert into the numeric format or to convert into the, the domain of it. And if you have a text data, so it's very important to convert or encode in such way so that context or the meaning of the information should not change. Let's say you have a text data, so we cannot map the text data on the any algorithm, because algorithm is a mathematical function. And so before that, what we do is we encode our text data in such way that information will not change, or the context or the meaning will not change, or it should not change. So whenever we have a text data, we use a different approach, like a particular vectorization approach, okay, to convert the text into the vector format. And there are very famous techniques that we use it to convert the text into a vector or the numeric format, like word to vec, Google algo model, or we can also use the particular word to vec or fast text is a particular Facebook, or we can latest one the BERT also we can be using the Google model that we can be normally the Google search engines it's used to convert the text into the numeric format, the BERT or the fast text or what to vec. Okay, so these are different pre-trained model that can be used to convert a text into the vector format or the numeric format. Okay, so even the loss of the pre-processing we do, even if you have a text data, if you have image also, so we perform image augmentation also, like we reshaping, resizing, removing the noise. So we do also perform the loss of image augmentations and make sure that you have a label data if you're designing some predictive model. If you don't have a label data, so we manually label it. If you want to design solutions like object detection, you want to design some solutions which can detect the different objects in the real time, whether object is a water bottle or the mobile phone. So in the real time, whenever we open my mobile camera, what happens is if there are the multiple objects, so in every object there should be the box should be appear, and it should be detect that this is the particular water bottle, this is the particular mobile phone, this is the something laptop, this is the human, such kind of object detection kind of application. So if you don't have a label data, we also manually label it, and for that we can do some loss of a different software also where we can label the particular data. So we work on data. We spend a lot of times to to create the particular label data. We perform some pre-processing also. If you're working with image source, image augmentation. If you're working with a signal, then signal pre-processing. If there's some noise, so we remove the noise. It's very important to have very clean and perfect data. Then we also use different encoding approach to encode it or to convert into the numeric format. Okay. Then based on the business problem, or based on the business problem, you can the features that you want. Okay, based on the particular business problem, step 4. So the based on the business problem, okay, you can based on the business problem you can define the particular machine learning or deep learning algorithm. So let's say you have a regression or the classification problem or recommendation system, or you want to design some kind of a clustering, you want to design some anomaly reduction. So based on the business problem, based on the particular features, because let's say there are the multiple algorithms that can be used to solve a same problem, right? So that the multiple algorithms can be used to solve a regression problem. So the based on the complexity present in your data set, based on the particular the features that you want to see in the final output. So let's suppose that you have a classification problem and that the multiple algorithms can be used to solve classification problem. But your algorithms are, but in the patterns present into the data set is a non-linear. Okay. And you have a different algorithms. Some algorithms are capable to learn linear pattern. Some algorithms are capable to learn non-linear pattern. Some algorithms require lots of times for the training. Some algorithms require very less time to complete training. Some algorithms are very powerful and their prediction speed is very, very fast. Some algorithms, their prediction speed is average. Some algorithms can give the output in the probability format. Some algorithms cannot give the output in the probability format. So depend on your features that you want to see in your final outcome. Okay, depend on your business problem and the complexity. You can basically based on that you can define some machine learning or deep learning algorithm. Okay, and once you're done with this particular part, so we have a particular data in the starting, right? So what we also do that is we split data. We can split the data for training and testing. So even we split the data for training, testing, and we have the particular one more the validations format. We we split the data, but again we can split the data for the training and testing, and okay, and we split the data into the training and testing. And training data, we then again what we do, training data we use it to our algorithm use a training data to learn the pattern, and we use a testing data set to check a performance of our trained model. Okay, so once we're done with this particular part, then in the next step what we do is, because you see it's very important to understand this entire step, because when you are going to do the coding, whenever you write a code, first we design the strategy, then we just follow those particular the strategy and use any programming language and their function to design the solution. Okay, any business problem, the first important step is to design the complete strategy or strategy, and then in the real time we just follow it, and you can use any tool, code or the no code based tool, and you can just follow it and design final solution. So we split the data for the training and testing, and after that we basically map training data on the algo, and we start the particular training process, start the training phase. We start the particular training phase. Okay, we start the particular the training phase. Okay, we start the training phase. So during the training phase, what happened exactly? So is learn the particular the pattern, and if it is something a classification problem, so is basically draw with some decision boundary. If such kind of patterns present, so it's belong to the class 1. If such kind of patterns present, so it's belong to the class 2 or the class 3 or the class 4. Is something a regression, so is draw the decision line, and it uses those decision line to predict the numerical value in the real time. Okay, so it's learn the patterns basically during the training. And once after the completing a training part, we, once we done with the particular the training part, we start with a particular, after completing a training, we use a particular the testing data. We also use a validation data here. Okay, that particular part we'll discuss during the, when we design the solution. Then we use a testing data and a train model. So after training, after completing a training, we say as a model, train model. And we also use a different matrix. And we check the performance of our train model. We check the performance of the train model. So matrix means if you have a classification problem, so we use a matrix like a precision, recall, or accuracy, classification error, F1 score, such matrix. If you have a regression problem, so root mean square error, root absolute error, mean absolute error, mean square error, R square score. Okay, if you have a clustering problem, so we again we can be use a particular different the matrix for it. Okay, so depend on your particular business problems, type of problem, we can define the different matrix for it, and we can define the particular the matrix for it and check performance of train model on the testing data set. So let's say the performance is good. Let's say we have a particular good performance on particular, there may be the two option here. Okay, so the performance is, here we have particular, the performance is a particular bad. Okay, on the training data, on the testing data, the performance is not good, and the performance is good on the particular testing data. We have the good performance, right? So if the performance is good, so what we do is we basically export our train model. If you remember that in the last lecture we discussed the teachable machine learning with Google, we collect label data, map on the algorithms, start the training phase, and once we have a complete training, we are performing the testing, and you can also export your train model. So here also, if you have the performance is good on the testing data set, so we can export our train model in the different format like a pickle, H5, different format. You can export your train model, and once we have particular, the final train model, okay, the final train model, then we basically what we do is, then we have a train model here, then you can use a different framework, or you can use a particular different particular, let's say you want to deploy to the any web services, you want to deploy as a web service or as a REST API, you want to create as an API, so you can interface with any software or application and perform that, you can use it, right? So we can use a different web framework, like a particular Flask, you can be use it if you're working with a Python, so you can use a Flask, you can use a Django. Okay, you can use a Django, you can use a Flask, different framework, and create the API, and then you can interface with any particular software or application. or mostly what we do in industry, instead of directly, so there's a two way to deploy anything. So let's suppose that I'm designing any software. Now I want to deploy it to in the production environment. So one of the way is, what I'll do that I'll just copy everything using a pen drive. Okay. And I'm designing such a particular software in the particular, I'm using one Python to design the software, or my particular software is using, I'm using a Python programming language to write the code and to design the software, and some specific library or specific version of it. Okay. So you can copy everything in the pen drive, then you can go to the virtual machine or any cloud platform like AWS, Azure, IBM, GCP, Oracle, any cloud platform. You can create the virtual machine and you can create similar the environment first. You need to install the Python, you need to install all this library with the same, same version. Okay. And make sure that your environment is very perfect. Okay. And then you can paste your code. Okay. And you can run the particular your model and perform the test. You can deploy as an endpoint and you can use their endpoint to perform the testing part. So this is the one part of it. But there are some drawback when we deploy as a code.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
There is some drawback also. Let's say even the same thing you also face in the real time. So let's suppose that I'm designing some software and the same code when you're running in your system, but in your system it's written the loss of error, because it's maybe in when I'm designing in my system, so there is some backend dependency, a specific version of the library. Okay. And in your system, you don't have such similar software, or you don't have a similar environment.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So what we do is we use a particular Docker also. So in the Docker, not with the machine learning, any kind of a software or application, whenever we deploy it or whenever we go with the productization of any software or application, we basically create the particular, we use a Docker. Is a kind of container. In the Docker, what we do is we basically create, lightweight OS. We create one particular container where we install the lightweight OS, Ubuntu, Windows, and we install all particular library or software. And then after we paste the particular code also and create the Docker image. And whenever, let's suppose that now you want to deploy into the 5 different systems, so you can just send the particular Docker image and you can run the code. You don't need to set up all the particular systems individually. So we create a Docker image, and then what we do is we can deploy it to the any VM. Okay, you can deploy it to the any VM, any cloud. You can use any cloud or any VM. You can deploy it, or any environment. Deploy to any VM. So mainly during the deployment is also again very different field. You can deploy. So let's suppose that you can use any cloud service like AWS, Azure, Microsoft Azure Cloud Platform, or IBM, Watson's, or GCP. Or you can also deploy to you can create the VM on any these cloud vendors or their cloud computing platform, and you can deploy your Docker image and perform the testing in the real time. Or you can also use the Kubernetes service and deploy it, and you'll get the endpoint, and then you can perform the testing part. So that's something we do that. Okay. But let's suppose that if the performance is not good, then what? If the performance is not good, so what we do is there's one concept is hyperparameter tuning. Hyperparameter tuning, that we perform it. Hyperparameter of the models or the algorithms, we tune it, and we again work on the particular data. We again check the particular what strategy. And if you're using any machine learning or deep learning algorithm, so there's some internal parameter also. Internal parameter, and their value in the starting we define based on our experience, right? So what we do is we change their value and we try to improve the performance of the model. We tune we tune it and we try to improve the performance of the model. So that's something a model hyperparameters, or we tune it and we try to improve the performance. And again, when we try to tune it and again retrain our model, and now again we check the matrix and the testing data and check the performance, and the performance is good. So then again we can export it, and then we can use a Docker cloud service, Flask, or Kubernetes service, and we can deploy it to the production environment, and you will get the particular the endpoint. Endpoint means the IP address of your particular or the API or the IP address of your particular the virtual machine where you are deploying it, or the public IP address or the private IP address, and you can interface with any software or application, and then you can use a REST API concept to perform the testing. Whenever you send just a request with a feature value, you'll get the response from the particular you'll get the response from the particular your server as an output, and you can see the particular output on the web pages or in your mobile applications, on software or any GUI. Okay, you can use it basically the train model. So these are something concept that we are going to follow it. Even if you're using a machine learning, you're working in the data science course, or even in the deep learning or any machine learning, classical machine learning algorithm or deep learning algorithm, we are going to follow the same strategy. So whenever we have any business problem, we start with we understand the business problem, and we understand the business problem. Then again, we work on the data, perform data pre-processing, feature engineering, lots of things we do that, and then we split the data into the training and testing, and we use our train data to we map the particular training data on the algorithm, and it's learn the pattern, start the learn the pattern, and after the learning pattern, we check the performance of the trained model on the testing data set or some unseen data which is not used during the training. Okay, and if the performance is good, so we can export it and we can use some different service, cloud service or macro service like Docker, Kubernetes, Clouds, Flask, Django, and we can deploy it to the production environment and perform testing in the real time. But if the performance is not good, so we can tune it and we can improve the performance. So once you train the model, right? So once we train the model, it's not a complete. This pipeline is again is not a complete. Let's suppose that tomorrow you have some more data, or quarterly you have some more data. Okay, you're also collecting a data, or now you're using this application, but over a period of the time, maybe the performance of the trained model will be decreased. You cannot use a same model for the lifetime. Maybe the over performance of the model, there are some new patterns, new cases are coming, and you want that your model should be learned from those patterns. So now over a period of the time, maybe the performance of the model will be poor, and you want to train the model, you're collecting you have some more data, and you want to train the model again. You want to retrain your model from the new data set so that it can learn those patterns also. So we use a concept of active learning, and we can collect the data. We can create such kind of architecture. So we can create a folder or kind of the gateway. And whenever we have the more data, whenever we have a more data, we can schedule it also. Whenever we have a new data will become in the folder. So it will automatic weekly or quarterly, it will be automatic start to train existing model. It's not going to train it from the very scratch. Okay. It will be just use the same pre-trained model and retrain on the new data set. Okay. And check the performance and use it for the environment. So in this way, we can also use the concept of active learning. And we also use nowadays, when there's one very, the hot topic in the AI and the machine learning, which is something MLOps, machine learning in operation. So let's suppose that over a period of the time, the performance may be decrease of your trained model. So during the operation, we also monitor their performance. So what is the performance now? What is the performance tomorrow? What is the performance is at 8 p.m. or the 9 p.m.? We monitor the performance. And accordingly, we can schedule it also, or the performance will be decreased. So it will be send the alert as well. Because this model is going to perform the loss of the task, automate operations. We are going to use it to perform the complete loss of the job. So it's very important to have very good, the models. So we also need to monitor it so we can use a particular MLOps, machine learning in operation. And there's also one more concept. So here what we are doing, we are defining the machine learning algorithm or deep learning algorithm. And we are basically, starting everything from the very scratch and training everything. And then we are checking the performance, deploying to the production environment and performing testing in the real time. There's also one more concept, is a transfer learning. Okay, there's also one concept here, transfer learning. there's a concept here like a transfer learning. So you see here what we are doing it. We are designing the everything from the scratch. For we have a data set and we require a huge amount of data. Okay, and what we are doing is we are collecting a particular data, or your data engineers is collecting a data and creating a data warehouse for you. And as a data scientist or AI engineer, we are just connecting with the data warehouse or data lake and collecting a data and defining the algorithm and starting a training. We are doing everything from the very scratch, right? So sometimes you have very less data. Okay, sometimes, because to designing the model is not task of 1 hour or the 2 hour. Here we are going to design some model within the 30 minutes or the 2 hours or the 3 hours. But in industry, it's not just a task of 1 or the 2 or 60 or 90 minutes, because we are not designing the model. When in the industry we design solution. So let's suppose that now I'm designing the model, the performance is 90%. You can say the performance is good, but maybe this performance is not enough to get the end objective. So we tune it and improve it, or we change our strategy, or we plan in such way so that we can improve our performance in order to get our end objective, right? So here we are going to design some model within the 30 or the 1 hour or the 60 minutes, but in the industry it may take a particular the 1 month also, or 1 year also, depend on the business problem, whether you have enough data or not. This is depend on the lots of things, right? So in the transfer learning concept, so here also nowadays we widely we use in industry. So instead of doing everything from the scratch, okay, what we do is we use some pre-trained model. We work on some pre-trained model. So there is some pre-trained model or state-of-arts model that's designed by top engineers, developers to solve specific problem. Okay, and we can use those pre-trained model, and if you have very less amount of data set, so you can retrain it. You can just tune some of the layers and you can retrain it with the new data, and you can design some solution. So you don't need to spend the time, or we can just, you don't need to spend the particular the time to design the architecture. You don't, so we can save the particular time, we can save the effort, we can save the particular the effort, time, money, everything we can save it. So by using a transfer learning concept, so what we do is instead of designing everything from the scratch, we use some pre-trained model that is designed by top developers or the AI engineers, and we just tune it based on the business problem and retrain the some of the layers using a new data set, our data set, and then we can design some solution. So there's some pre-trained model also. So this is the knowledge of particular transfer learning. You see, we have a concept. So human, we can reuse our knowledge. If you know the bicycle, so we also say that we can also, it will also help to learn the motorcycle. Normally we say the balancing part, we can easily help to, the balancing part. So if you know the bicycle, so we can easily learn the particular motorcycle. If you know that how to boil eggs, so that will also maybe help you. You can use the same knowledge to to uh, to to prepare the particular the Maggie also. So that's basically, we can reuse our knowledge that we learn to doing some other task, but we can use those knowledge to perform some other kind of the task, right? So similarly here also, we have some pre-trained model that we design. Let's suppose that you design some model to which can classify that whether animal is a tiger or the lion. So you can use same pre-trained model. You can also retrain it, and you can use it to design some solution which can be used to classify that whether animal is a cat or the dog. Okay, so that's something a transfer learning concept. So this is one of the project, the self-driving car. So here in this project, so what is the project is, so we basically, this is a self-driving car. So what we did is we just used a normal cardboard and use a particular black and white sheet, create a normal path. And then first we use remote control car using some controller like Arduino controller. We use a remote controller car and put my mobile camera on the top of the chassis, as you can see here, and using mobile stand. And first I just manually move my car into the forward, backward, left, and the right direction. And whenever the this car is moving into the forward, backward, left, and the right direction, so this camera is capturing the images of the path, and saving those images in my laptop with the name of forward, backward, left, and right. So let's suppose that if first I just manually move this particular car using remote into the forward direction. So the camera is capture this image of the path and save in my laptop with the name of forward. Similarly, when I'm moving into the particular, when we are moving into the particular the left and the right direction, it's just collecting a data and saving with this. So basically first we are collecting a label data. Then we use neural network algorithms and train the particular algo using those data. So we have a label data, we have a loss of the images, and the actual label is their name of image, like a forward, backward, left, and the right. That action that we took it. Okay. So we just map it, and then we start the training. So this time, because we are doing from everything from the very scratch, so it almost took the particular 6 hours to complete the training. Okay. And after the training, the performance is also not very good because we have very less data and we are also not working on data. It's just we are directly mapping on the algorithm and starting a training. So it took almost the 6 hours. Then after what we did is we just export our trained model, deploy to the local network, and connect it to this particular controller using a particular the Wi-Fi module. So in the real time, the camera is first capturing the images of the path, sending to the pre-trained model, and then model is predicting whether it should move into the forward, left, right, or the backward, and it's giving the instruction to the controller, and accordingly controller is moving into that direction. So it's fully autonomous car using AI and machine learning. So in the real time, first we collect the data, we train the particular algorithm, and then we deploy to the local environment and connected the trained model with the controller. So in the real times, this is camera just capturing the image, sending to the model. Model is predicting that whether it should move into the forward, backward, left, and the right direction, and giving the instruction to the controller, and the controller accordingly moving in that direction. So it's a fully autonomous car, like a self-driving car example. Okay. But here, if you use a particular transfer learning concept, so maybe the performance may be better, maybe, but not sure. So this is the kind of, you can be used one because we have very less data here. So we just directly use deep learning, but deep learning require huge amount of data. Okay. In order to get the good performance, right? So this is the one example of the self-driving car.
Now let's look at some limitations of machine learning. So when it comes to machine learning algorithms, they would require massive stores of training data. So again, as I've told you, machine learning is totally based on the data which it has. So if you have more amount of data, only then it will be able to give correct accuracy. So let's say you take in very small amount of data, and there's a good possibility that the results which you're getting are very biased or very incorrect. And also, error diagnosis is quite difficult when it comes to machine learning, because again the amount of data is very huge, and wherever there's a mistake, you'd have to go through the entire algorithm which you've written and then find out that particular mistake by yourself, which is very difficult. And also when it comes to machine learning algorithms, they're not really that creative. So these ML algorithms are built only for one specific purpose. So let's say I'll build a machine learning model which will predict whether it will rain or not today. Now, if I want to use the same model to predict the stock prices, that will not work, right? So basically one model is built only for one particular task. So this is the lack of creativity that I'm talking about when it comes to machine learning. And also there are a lot of time constraints as the model has to learn through a lot of historical data.
So now we finally come to scikit-learn. So what is scikit-learn? Scikit-learn is a free open source machine learning library that contains generic implementation of common machine learning algorithms. So as we've already discussed, there are a lot of algorithms that you can use in order to build a machine learning model, but writing those algorithms from scratch on yourself by yourself is going to be really difficult. So using instead of that, what we do is we use scikit-learn. Scikit-learn allows us to import the algorithms ourselves after understanding the data, and we can just use those algorithms that have already been pre-written for us to implement our model instead of us having to implement the algorithms ourselves. Since they are common algorithms, they have been implemented by people already. Okay, so now the thing that we have to understand is that it contains a lot of functions to perform commonly used operations. So it doesn't just contain the machine learning algorithms that we want to use. It also contains a few functions that we use a lot. So for instance, if we have some data set and we want to split it into a 70-30 ratio, it has a function for that. If you want to figure out if you want to validate our data set against different distributions of data, it has a function for that. If you want to generate a confusion matrix, it has a function for that as well. So there are a lot of things that it covers. It doesn't cover everything, but it has a lot of functionality out of the box that we can use. All right. So with that, I have another question for you guys. Hopefully, if I show it to you on the polls, you'll be able to see it. Okay. So now I think you can see the question. For those of you who are unaware, the question is, can you build a machine learning model by only using scikit-learn and no other library? So if you are not using any other library other than scikit-learn, can you build a machine learning model? When I say no other library, I mean you are not able to use Python as well you are not able to write, you are not using any other thing other than scikit-learn. So for all the tasks involving machine learning and everything, can you use scikit-learn only? So the answers are that options that we have is yes and no. So I'll wait for the answers, and once I've gotten all the answers, I will tell you the correct answer. So I encourage everyone who's participating in the all right, majority of you have answered, and the options that were available were yes and no. I'd like to tell you the correct answer, which is for the question that can you build a machine learning model with only using scikit-learn and no other library. The correct answer is yes, you can. The people who have answered no, I'm assuming that you guys were thinking that because we have to use NumPy or Pandas or other libraries like that, we could probably not be able to use build a model without using those libraries. The thing is, you can build a model without using those libraries, but you would have to do a lot of coding yourself. You would have to import the data, parse it, split it, and then use it inside the library of scikit-learn. But only using scikit-learn, you can build a machine learning model. It's just going to be really difficult, and without using scikit-learn on any library, it's going to be even more difficult. So the correct answer is yes. For those of you who have answered yes, you were correct. For those of you who answered no, you were incorrect. But depending on how your thought process went, you were really close. All right. So now let's move ahead. I've closed the poll, and now let's take a look at why should you use scikit-learn. First of all, it's very easy to use. Scikit-learn is extremely easy to learn and use, and it makes the task of implementing mathematical algorithms really easy because it contains all the implementation with it. We just have to understand how to use the classes and the functions available in the library. It's very well documented. It's got an extensive documentation that contains information about how to use every available feature in the scikit-learn library. And using that, we can take a look at that. Then it's been created by experts. So scikit-learn is a library that has been created by expert data scientists who have been inside the data science business for a long time. They have written these algorithms themselves, and these people have been writing algorithms that are relating to data science from their hand for a long time. So they know how to make a generic implementation that many people can use. And finally, it's very well tested. It's been used by several developers across the world who contribute patches and bug fixes. Scikit-learn is an open source library, so if you want to take a look at the code underneath the hood, you can just go to GitHub, search for scikit-learn or sklearn, and you can get the library code yourself. If you find some problem or want to help scikit-learn grow and add some features to it, you can use GitHub to add some features in the code that the scikit-learn has, and then suggest a revision to the developers and maintainers. Because it's open source, many people have already found a lot of bugs and submitted a lot of bugs. So that means it's battle tested as well, and it has seen a lot of issues already. Now let's take a look at steps in building a classifier. This is an important concept, right? So now let's take a look at steps in building a classifier. So there are 5 steps in building a classifier, but there are several steps in building a classifier. 5 to be exact, but depending on how you're training a model, it could be more and could be less. Usually, these are the 5 generic steps that are used. The first thing is we import the libraries. So if you're using sklearn, numpy, pandas, you import it. Many people import it throughout their code. So as soon as they need something, only then they'll import it. I like to import everything at the top of my file so that everyone who's using my application knows, or looking at the code that I've written, knows what are the libraries that my code depends on. So you can firstly import all the libraries needed to train and build the model that you need. And these libraries can perform tasks ranging from numerical manipulations, such as NumPy, and testing the accuracy that we'll be using scikit-learn for. All right, and then what we do is we import the data set. So data set is the data that we will be training our model on. It's important to understand what data set we'll be using and how we'll be using it. So that's how we firstly need to import the data set, or we can, after importing the data set, we view the data set, we load it, we manipulate it so that it's clean and it's in a state that we can use it to train our model and do the following steps. And after that, we can use it in machine learning models. After that, what we do is split the data. So when we get the data set, its X and Y variables are right with each other. So the thing that we are using to make the prediction and the prediction itself are right inside the data. First, we split that, and then we split our data into a training and testing set. Training set is used to train the model, testing set is used to test the model, and using that we understand what is the how the model has learned and what is the accuracy that it's giving us. Then comes training the model, in which is the task of the scikit-learn library. It creates an algorithm and allows us to feed it data so that it can learn from the data. And after learning from the data, it can do the classification or regression tasks that are needed. Finally, we test the model. We give it the data that we had set aside for testing. After giving it the data, we ask it to make the classifications, and depending on how many were correctly classified, we give it a percentage from 0 to 100. Higher percentage means our model is more accurate, lower percentages mean it's less accurate. What is the max percentage of a model accuracy? The max percentage is 100%, but no model can be expected to have 100% accuracy. If your model, when training or testing, it gives 100% accuracy, it could be that your training set is too small. That is, it either contains only 10, 20, 40, or 100 values, or it could be that your training set is overfitted, which is the variance issue that we have talked about recently. So splitting the data set is basically the task when we get the data and we want to set aside some data that our model can be trained on, and the remaining data is used to test whether or not our model is giving us correct accuracy. So as in supervised learning, we already have the data and the output that it should map to. Once we feed in the data and we take a look at the predicted output and the correct output, the percentage of outputs that match are the ones that are correctly classified, and the ones that are correctly classified are the outputs that lead to higher percentage of accuracy. So someone has asked to explain some example on training the model. Training the model basically means just taking the algorithm from the scikit-learn library, feeding in the data, which is the X and Y variables that we have splitted for training. Then that data, that algorithm learns from the data, and after that we can make predictions using it. We'll take a look at that in the demo. All right, hopefully you can see the question. The question, yeah. So the question is, which set is used to validate the performance of the trained model? So once the model has been trained, which set is used to check whether or not our model's accuracy is good? So I'll wait for a few moments and you guys can answer in the poll and submit your answers. Whether it's training set or testing set. Training set is the first option, testing set is the second option. All right, in the meantime, people have asked a few questions. I'd like to answer those. Someone has asked, what is the ratio to split the training and testing set? So for training and testing, you can split the data into, depending on how large your data set is. If it's really large, like you have millions or billions of rows, then you can just take 1% or 10% of your data. If it's a small data set, then 70-30 is a good ratio to split your data on. It's testing set, which is the correct answer. The training set is used to train the model. The testing set is used to figure out whether or not the answer is whether or not the model is performing well, which is why we use it. And let's have our hands-on. We'll have a demo here. So I already have prepared a Jupyter notebook for you guys. in which we perform all the 5 steps. So let me just first explain what we're doing. We're using the iris dataset that contains information about flowers. It contains information about the sepal length of a flower, sepal width of the flower, petal length of the flower, and petal width of the flower. Using these 4 features, we're trying to predict the kind of flower that it contains, or kind of the iris flower that it's containing. There are 4 kinds of flowers that our dataset has. 3 kinds of flowers that it has: Virginica, Setosa, and these are the different kinds. So what you do is, firstly, we import all the libraries. As you can see, the libraries were easily imported, so it works fine. And from sklearn, I'm importing the load iris function that will get us the dataset. It's a very common dataset, and so that you can follow along with me and you don't have to wait to load the data from some remote data source, you can just use this code that I'm showing you on my screen right now. And then we are using the train test split function, which we'll use to split our data set into the specified ratio. Someone has asked, can we try it on Google Colab? Yes, you can try it on Google Colab. That's a very good use case for Google Colab, actually.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So if you want to use Google Colabs, or if you want to use your local notebooks, you can use those as well. Okay. With that, we have train test split, which is the function that is used to split the data. We'll be using the logistic regression model, which we can import from sklearn.linear model. And finally, we will be taking a look at the accuracy score as well. And scikit-learn already gives us a function that does it for us. I'll be more than happy to answer you on the questions that you ask about the code that you're watching. If you want to follow along, you can type in the code in your Jupyter notebooks if you have it. If you don't have Jupyter notebook, then it's going to be difficult for you. You can use Google Colabs. That's a really good option for you to try if you want to follow along. So now let's take a look at it. So someone has asked that they need to import the data set. Should they need to import it with its name? So we are using the load iris function, and using that you can just import it. You don't need to specify any name. If you have a CSV file on your local system, importing that, you would need pandas library and need to know the file and the example. Okay. So now we load the data set. But now let's take a look at what the shape of the data set is. As you can see, it's a dictionary. Dictionary is a key value pair. It's a common Python data structure. It contains a key of data that contains all the data. And it's 5.1, 3.5, 1.4, 0.2. These are individual rows in our data set. Now, we don't know what these values mean. So taking a look at the data, we have targets as well. Targets ranging from 0, 1, and 2. Now let's take a look at the target name. These are the different types of flowers that we'll be predicting. These are the categories that we'll be predicting. Setosa, versicolor, and virginica. So 0 means Setosa, 1 means versicolor, 2 means virginica. The reason why we have encoded them into numbers is because machine learning algorithms only understand numbers. They don't understand words or strings or letters or sentences. So we need to first convert those numbers into letters and classes into numbers, and then we can make the prediction. And now for our columns, we want to be able to understand what are the different columns that we have. And what we get here is we get the sepal length, sepal width, petal length, and petal width. So it's given us the example of what we have. So feature names are: the first column has sepal length, second column has sepal width, third column has petal length, fourth column has petal width, and all of them are in centimeters. So that helps us understand the data. Now it's time to split the data. We'll split it in X and Y. We'll be using these features, and using those, we'll be predicting these targets 0, 1, or 2, which map to Setosa, versicolor, or virginica. So with that, after splitting the data, I try to split it into 70-30 ratio. So let me just explain what that means. Using the data set that we have, the data, the data key inside it contains all the data that we need. So let me just show you what the size of the data is. If I insert a row below and look at the length of X, we have 150 rows there. Now, if I split it into a 70-30 ratio, right? And now if I insert a row and I print the length of X train, we have 105. So 70% of 150 is 105, and remaining 45 are for testing. So we will use 70% of our data for training, 30% for testing. And with that, we create a logistic regression model. This is a class in sklearn. It just takes in the logistic regression model and creates an object of it. We use the fit method to fit our data. Fit basically means train our data. We pass in the training X variable and training Y variable. So the 105 rows that we have created for testing, we pass it inside our training and testing set. If you're following along, if you want me to scroll up to help you look at the code, this is what the first line, first things we import is. Then we load the data set. You only need to write this code. This is just for explanation. This is markdown format, so you don't need to copy that. After we have trained our data, since our data set is small, it trains in a few milliseconds. Now we make the predictions. And after the predictions are made, we take a look at the accuracy, and accuracy is 88%, which is quite good. Because machine learning models use statistics, these accuracies could change. So if I train it again and then I check it again, it's giving me 100% accuracy because our data set is too small. And now it's giving me 91% accuracy. So it's giving us high accuracy, but the accuracy is variable. The reason why is because depending on how data is split. When we split the data using train test split, it splits it randomly. So it takes a look at 45 values randomly and splits it into another 45 and 105 random values from the entire data set, and then we can train the model. So someone has asked, is face recognition classification or face recognition is a supervised learning problem. It's a classification problem, but it takes a look at very different technologies that are not just part of classification. It takes a look at computer vision, handling the data. There are many other different kinds of things. Face detection is a classification algorithm. Face recognition is a system that uses classification algorithms along with other algorithms as well. Is computer vision an area of ML? Yes, it is. Hyperparameter tuning, as the name sounds, is used to tune the hyperparameters of a model to make it increase its accuracy. So what are hyperparameters? So for instance, let's take the support vector machine model as an example. Now, when you're training a support vector machine, you need to set a lot of parameters. These parameters determine how your machine learning model will get trained, for how long it will get trained, and how it will begin with the training session, and how the training session will go on, and how long it will go on. So these are the kind of things that the hyperparameters are responsible for. To give you a quick look, let's take a look at the sklearn libraries documentation for support vector machine. This is the support vector classifier, also called SVC, and as you can see, there are these many parameters that you need to change. Now, as you can see that these are the default parameters, and you can take a look at all the options that you can take. So for instance, the parameter named C, parameter named kernel, you could say the default is RBF, but you could change it to poly or sigmoid or pre-computed or any other value. As you can see, there's also degree, there's also gamma, and there are a lot of other parameters that you can set. Now these parameters are responsible for you to understand how your model works, and these parameters also take care of how your model will take care of the data interaction and how it will train itself and figure out the classification problem. For instance, if you have a data set and you want to use it to classify your algorithm, to train it on a classification problem, this algorithm, if you don't set any of these parameters, these are the default parameters that will get set automatically, and all you would have to do is train your model and you will get some sort of an accuracy. it might not be the best accuracy you get, but it will be the accuracy you get by the default parameter. So if you're not satisfied with the accuracy that you have with any of the models that you have trained, one thing that you can do is called hyperparameter tuning. That is, you could change the parameters to different values and see how it affects the accuracy of your algorithm or the trained model. So for instance, if you have trained model with the default parameters and you change it and you get a better result in the accuracy score, that means that that model is better than the previous model and you need to pick that model. Now, all of that is good, but since you can see that there are so many parameters that you need to think about, and what's even more difficult to understand is that since there are so many parameters and all these parameters have so many options, which ones do you choose and how do you go about choosing one of those? Now, since machine learning is based on statistics, probability, and calculus, there's no fixed answer. There's no way to determine which one to choose right off the bat. So if you want to learn how to choose one, you need to try a lot of combinations. Now this is where the hyperparameter tuning part comes in. So in hyperparameter tuning, what we do is we take a list of all the possible or all the options for the hyperparameters that we are choosing, and we choose a lot of combinations in those hyperparameters, and then we pick the ones that lead us with the best result. So to give you an example, since in SVC, let's say these are the parameters that we're concerned with: C, kernel, and gamma. As you saw in the documentation, C, kernel, degree, gamma, all of these are parameters that you could set to the different values, and you might get better or worse results depending on how your data set. Now the thing is that there's no fixed answer that you choose these parameters together and you will get the best answer. A lot of it is based on experimentation, so you would have to pick a lot of parameters and do this. So the two options that we have to do this are called random search and grid search. So we have a grid search algorithm and we have a random search algorithm. So what do these mean? Well, let's say that these are the options that we want to test or tune our hyperparameter on. We want a combination out of these options and we want the one which gives us the best result. So let's say we have a data set and we train our model on default parameters. Now, if you take a look at the documentation, the default parameter for C is 1.0. Here it is, 1.0, which is this. The default parameter for kernel is RBF, which is this one, and the default parameter for gamma is scale. However, the options you could choose a numeric option as well, and this will give you different results. As you can see, it says here if gamma is scale, the default value is supposed to be this. If auto uses 1 by n features, when 1 by n underscore features, n underscore feature means that we have n underscore feature means the number of features or the number of columns. So if we set it to auto, then it will automatically determine the scale. However, we can pass in the scale as what we want as well. So if we want our model to be trained to its max accuracy considering all these parameters, one thing that we can do is we try all the combinations or all the different permutations and combinations of these options. So let's say we start with 1 linear and 0.1. We get the accuracy of, let's say, 68%. Then we go with 1 linear and 0.2 and we get the accuracy of 69%. Then we go with the accuracy of 1, we go with the parameters 1 linear and 0.3. So C will be set to 1, kernel will be set to linear, gamma will be set to 0.3, and we will again train the model and test the model and figure out its accuracy the normal way we do. Let's say we get the accuracy of 58% and we try it for all the possible combinations. So we, after getting through all of the gammas, we go from 1 RBF and we train on all of these. Then we go through with this process again with 10, with 100, 1000, and we try out all the combinations. Now, when we do that, we keep track of the combination that gave us the highest accuracy. So if the highest accuracy we got was 88% with the parameters as 1 linear and 0.6, then we'll choose that. So this is what grid search algorithm does. Now, as you can see that this could be an exhaustive search. We're trying all the possible combinations and permutations. And the real problem here is that since we're trying all of the permutations and combinations, and if the data set is large, then training it will take a lot of time. And to be fair, hyperparameter tuning does take a lot of time. So if you don't want to spend a lot of time, or you don't have the resources to train such all of the combinations, or to try out all the combinations on the size of the data set that you have, you could try random search. Now, random search, as the name sounds, is that
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Chooses values at random. So it might choose 1 linear 0.4, 1000 RBF 0.2, so on and so forth. And it randomly chooses these values and picks the best one that it gets after a number of iterations. Now, this number of iterations is unknown to us because it's implemented in the algorithm. We don't have any control over that. And that's how that works. Now, intuitively, you might think that since it's randomly selecting these things and there could be number of possibilities, we might not get the best answer. And you're right, we might not get the best absolute result when we're choosing random search CV or the random search hyperparameter tuning. But the thing is, even if we don't get the best, we'll get somewhere around the best. So let's say the best attainable score using these hyperparameters was 95%. We would get somewhere around 88 to 93%. Now, this is, by the way, mathematically proven. There's a research paper on this as well. I don't know the link of this, but you can search it online and it will show you that random search CV performs much better on large data sets, mainly because it's not exhaustively trying to find out all possible permutations and combinations and trying to figure out how to get things done. So if you don't have the luxury of having large computational resources, or you don't want to spend a lot of time on training your model, you could choose random search CV, but with the understanding that random search CV might not give you the best, most optimum result that you want, but it'll give you somewhere around that. So that's good enough. Now that's done, we can understand that these two techniques are quite different. One focuses on a lot of time. So grid search will take a lot of time, but will give you a great result, or the most optimum result attainable using the hyperparameter grid that you give it. And one is a little pragmatic. It might not search all the possible permutations and combinations, but it will do good enough and give you a good result. So you can try that as well. Now, this mainly depends on the size of your team, the resources that you have, the size of the data set that you have, and a combination of all of that will determine which algorithm you choose. Now, for instance, if you're training your model on a cloud computing platform, let's say the Azure ML Studio, that these studios have other algorithms as well. So I don't remember the name of those algorithms, but they are there as well, and you just have to change some settings and click a few buttons and you'll get good results. Also, they allow you to write code to do that as well, so you could read through the documentation of their SDK and then provide you with that as well. But for normal tasks, if you're doing it on your PC, or even if you're offloading these computations to a cloud computing cluster, these tasks are better performed, and grid search and random search will give you good results. So if you are using a service like the Amazon SageMaker, or the Azure, I think ML Studio is called, Machine Learning Studio. So you could use those technologies, and they depending on the data set and the technology you're using, it will give you some graphical tools as well to train or hyperparameter tune your model. So, and again, they give you options to save that model, deploy it, create a web service out of it, all of that using a graphical. So if you want to take advantage of that, you could use cloud computing for that as well. But if you just want to train a model on your local computer, grid search CV and random search CV are great examples for that. So you could use that as well. So as we have seen, grid search CV will try out all popular or all the possible permutations and combinations of all the options that you've given it. Do make sure that it will only try out the permutation and combination of all the options that you have given it. So for instance, for C, it won't try out 1, then 2, then 3, then 4, then 5 to 1000, because we are only allowing it to use a value out of these four for C. And similarly for kernel, it will only try out either linear or RBF. Similarly for gamma, it will only try out 0.1 to 0.9. So that's how it's supposed to work, and that's how it does work. Now that that's done, let's take a look at the code and understand how to get it done. So we'll be using a support vector classifier, and we'll be using a data set that we have. The data set is quite small, as I'll show you, but first let's import pandas. So pandas is used to load data and data sets from our local computers or any other format using CSV, XLS, and so on and so forth. And it's loaded. Now let me load it and read CSV. The name of the file that we'll be using is called dataset.csv or no data.csv. So I type data.csv and the file is loaded. Let's take a look at the file. So I think that's too much information. Let me just take a look at the head of the file. Head will determine the first 5. Okay, so this is the data set. Here's the user ID, here's the gender, here's the age, here's the estimated salary, and here's the purchased. So these are the, you can think of it as the records from a store, and this is a record for a particular product. So let's say it's the record for an iPhone. So these are the user IDs and the information stored about the person's name, person's gender, age, and estimated salary, and we check whether the person has bought this or not bought this. So zero tells you that okay, the person did not buy the iPhone, and 1 would determine that the person did buy iPhone. So this is what the dataset looks like, and we'll be training a support vector classifier using a SVC, and we'll be using the support vector classifier that is provided inside the sklearn library, and we'll take a look at how to tune it using the grid search and the random search algorithm. So let's start doing that. Let's first import. Okay, I will be using now, by the way, sklearn comes with all of these pre-installed, and if you don't know how to use them, we do provide courses on that as well, so you could take a look at that. But I won't be teaching you how SVC works internally, but I'll show you how to get it done in the Python Jupyter notebooks, and you can understand how to do hyperparameter tuning, since this is the goal of this this session. So let's take a look at that. So we'll go from sklearn.svm import SVC. SVC stands for support vector classifier, and since this is a classification problem, a classification problem mainly means that we're trying to figure out the output in categorical format. So we don't have a continuous format where we are trying to figure out whether we have only 2 labels. Let's say the customer will either buy the product or would buy the product. So if we have a limited number of outcomes, that's what's known as classification problem. Regression problem basically means that we're trying to predict something, and predictions could have an innumerable number of outcomes. So let's say that I'm trying to figure out the price of a house. That would depend on the house, and you can't keep it in a category that it will be this much. Let's say it's a continuous number. It could be 1,000, 10,000, millions, or possibly billions as well, or 1,000,000, 11,000, something like that. So it works like that as well. So since we are using machine learning, we'll use the train test split function in the sklearn model or the sklearn module. So from sklearn dot model selection, I think it's called. Oh, my sklearn app. So model selection, we import train test split, and we also import the grid search algorithm while we're at, and it gets imported. I usually like to import everything that I wish to use in a particular notebook at the top cell, so the cell which is at the top. Now that that's done, let's take a look at how we're going to do it. So for this classification problem, we'll be taking a look at the age and the estimated salary. We are discounting the gender and the user ID because these, in our opinion, does not have any effect on how the person whether the person buys something or not. So let's split the data into X and Y columns. X is the data that we will have, and Y will be the data that we will try to predict. So we will extract the age and the estimated salary from the data set that we just loaded from the data.csv file. And since we're using pandas, we could use the ilog. Now ilog, for those of you who don't know, ilog stands for integer location. Basically, we pass in an integer list which slices up the data and gives us only the sub parts or sub records of the entire data set that we want. So we want all the rows. However, we only want age and estimated salary. So 0, 1, 2, 3. In pandas, the columns start from the 0th index. So user ID is the 0th index, gender is the first index, age is the second index, estimated salary is the third index. And we want age and estimated salary, so we want 2. And y is the column that we're trying to predict. So we are trying to predict the purchased column. For that, we will be using, again, ilog will be used, but here we only have to pass the, I'll just copy it and I'll show you. I don't have to pass in a list since I'm not choosing multiple columns. All I have to do is press enter, and now the data set is split. Now I have age and estimated salary in one data field, and y would contain whether the customer has purchased or not purchased. As you can see, we have it here as well. So now that that's done, quick sanity check. Let's take a look at the size of the data set that we have. So data dot. So you can take a look at all the columns that we have. What are the data types of each of the columns? And finally, we have 400 entries. So the index ranges from 0 to 399. As I've already told you that in pandas, the indexes start from 0. So this is what it looks like. Let's change it back to head so we have an idea of what our data set looks like. I misspelled it. So this is what it looks like. And let's remove that. So now that that's done, the first part we'll do is we'll train a support vector classification model. To do that, we will just train, test, split our algorithm. And since we've already split the data set into X and Y columns, we'll be taking a look at that. So let's name our functions X train test, Y train, and we will use the train test split method to do that, and we will use the train test split method. So for train test split, all we have to do is use the X and Y methods. So we pass in the X and Y columns, and then finally all we have to do is specify the we have to specify what the name of the train test size. So if the testing size is 0.25, let's say test. So now the data set is split. Let's take a look at the size of the data set that we have. Train shape. So we have 300 records in the X train, and for X test we have 100. So as you can see, we have split the data set into 25 and 25 and 100% of the data set. So now let's take a look. So let's take a look at that. Now that that's done, we have split the data set, and now all we have to do is train our model. We'll be using the SVC algorithm as I've already discussed. So for that, all I have to do is use the SVC, and I will use the default method. So it's done, and all I have to do now is fit the data set. So to fit it, all I have to do is pass in the training parameters. So we are training it, the X value, the Y value, and these are, as I've already told you, the default parameters. Check it with the documentation. All of this is completely as it was supposed to be inside the documentation. Now that that's done, let's take a look at how our model is performing. We will make a prediction with dot predict, and we will use the X test. So the predictions are made. Now we have to take a look at whether those predictions are right or not. Now these predictions can be taken using the or the accuracy could be checked using the sklearn package. We'll use sklearn.metrics, and we will import accuracy score. If you've not worked with accuracy score before, it's So now we're taking a look at the accuracy score. We have the white training. Okay. Okay. White train, it's white test. And it's done. So right now, as you can see, the accuracy is only 0.58%, and it's very, very bad. So now let's take a look at how we can use the grid search algorithm and get better score. So we have already imported the grid search algorithm, so it won't take a lot of time for us to get started with it. All we have to do is first create a grid of all the possible values and all the possible parameters that we want to tune it to. So we will create a grid using a dictionary in Python. So I will call it a grid. I will create a dictionary, as you can see, and inside that dictionary I will create some so key would be the name of the parameter, and the values would be an array of list of all the possible values that we want it to work on. So for C, I want it to work on, I think, from 1, 10, 100 and 1000. So let's do that. So 1, 10, 100, 1000. Similarly, there are other parameters that I want it to be trained on as well. One of those parameters is the kernel. And you can take if you want to figure out how these parameters are being chosen, you can take a look at the documentation and it will tell you what are all the parameters that you could use. So we use kernel. Inside the kernel, I would use RBF. RBF is used by default used in the SVC, and I will use something called linear, LINEAR. So we are using RBF as well as the linear kernels. And now finally I will use gamma, GAMMA. And for that the list would go from 0.1 to 0.9. So I will So let's take, if I'm not make any mistakes, it will work, and yeah, it works. So now all I have to do is create a new instance of the grid search CV class that I imported above, passing a new support vector classifier that has not been trained on anything, and the grid search will take a look at the rest of it. So to do that, all I have to do is firstly create grid search CV. Grid search CV. Inside this, I will take a look. I will pass in the parameters. Now, the first parameter would be the classifier that I want to use, or an instance of the classifier. I can't use CLF mainly because it's already been trained and it won't be trained again. So to do, I have to pass in a fresh classifier.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Now I have done that. Now what I have to pass in is the grid that I created, and it's called, I believe, param grid, and I've called it grid, so I am passing it in. Next, I want to pass in the scoring method. So what is it that I want to score it on? So scoring would be, I want to score it using the accuracy. So there are different parameters for, let's say that you are using it to train a, not a classifier, but a regressor. So regressors usually use something called R2 score, or the R squared score, in which we are trying to reduce the error. So it's not concerned with the accuracy, but the error produced by the regressor. So we can choose that. And now that that's done, let's take a look at it. And it's created. Now it's created, but we have to fit it. Fit it basically means that the algorithm will be run on the data that we pass in. So grid search CV dot, and we pass in the same data that we pass to train our model, and we pass in the training data, and it will take some time, guys, because as I've already told you that there is a lot of options that, or a lot of combinations that it could take. So it will build up all of this and it will take some time. So let's wait for it to finish. So as you can see, it's taking a lot of time. Just wait for a few minutes. We'll see if it works. Most probably it will. If it doesn't, then we'll have to tweak some parameters as well. This is the problem with grid search, that it takes a lot of time, so you do have to wait for quite some while. Okay guys, so it is taking a lot of time. So what I'll do is I'll interrupt the kernel and I'll restart it. And since it's taking a lot of time, what I'll do is I will rescale the data and make some changes. And this will show you how this works. So let's take a look at that. Rescaling the data will make our data a little smaller, or the magnitude of our data a little smaller, and it will allow us to work perfectly with the configuration that we have. So it won't take a lot of time. So let's see how that works. So I will rescale the data. Hang on a minute. And if you ever come across a problem like this, you can rescore. You could use other functionalities as well. I'll be using the sklearn pre-processing standard scaler. You could use other methods as well. So sklearn dot pre-processing. Yeah. Import. Rerun it. Works. Rerun it again. This is done. I will remove it since it's taking a lot of time, and I will rerun it again because I've closed the kernel. So run again. Now, as you've already seen, I will firstly insert a new cell below, and I will try to rescale the data. And for that, we will use the same standard scaler that we have used right now. All I have to do is create a new method. Scalar is equals to standard scaler. This is the instance of the scaler that we'll be using, and we will be scaling the xtrain and the xtest variables. So xtrain is equals to, we will be using the scaler to fit and transform. Now it's going to take some time. So hang on a second. I think it's doing this because we have not run it here. So I'll just type it in and we will fit it. Let me create a new variable, scaled. And here I won't be using the fit and transform. I will just use the fit. Now the difference between fit, transform, and fit is there are a lot of internal variables that need to be set for the scaler to fit the data, because it depends on the mean and the standard deviation of the data. So it takes the xtrain method, xtrain variables, or the variables inside the xtrain data frame. It will fit itself, and it will transform the data based on the variables that it set on the xtrain data. So I would be using x test here, and now that's done, let me just use the xtrain scaled and the ytrain. Oh, I don't have to use the scaled versions because it doesn't matter. And it's done. And here x test scale and y test and y spread, and we get a score of 93%. So as you can see, scaling increases the algorithm's performance massively. But now let's take a look at how to get it done with the grid search algorithm. 93% is actually a pretty good score. So if you might not have to do this on the SVC algorithm, but let's say that you do. Let's say that you have an algorithm that's performing very low. It's giving you a score of, let's say, 60%. You could use the same performance tricks that I've used right now, and you could get a better result. But just make sure that when after you have trained the data on a scaled data set, the next time when you make predictions, you have to scale that data as well. So just make sure that you're doing that. And now that that's done, we have the parameter, and let's just change some few parameters so that it uses our maximum CPU capabilities. Now sklearn provides us with some of the functionalities that allows us to use the maximum CPU capabilities. If you want to take a look at that, just type shift space in any method. Inside any method, we will be using the CV and the njobs method. So what do they do? If you want to take a look at what any of these do, they have the doc string with them. Just take a look at CV. It means cross validation generator. So it will create 10 buckets of the data to create the validation data. So we could use that. We don't have to use it if you don't want to. The main one that I am interested in the end is the end jobs one. The end jobs method, end jobs would allow us to use the all the processing power that our computer has to offer. So if it's a multi-core processor, we will use all the cores. So for that, let's try n underscore jobs, set it to -1, so it will use all the processing power that's available on our PC. If you know how many cores that you have, or if you don't want to use all the cores, just the cores that you have, like you have 4 cores and you only want to use 3 or 2 of them, then you can use n jobs equals to and set it to the number of cores that you have. So now that that's done, let's just try it out. Grid.cv dot, and as we've already used before, we will be using the fit method. Let me just use fit method. I will pass in the scaled data, train. Training data is passed, and believe I have to pass in white line. And now it's run off again, and let's see if it works. And as you can see, it works in a couple of milliseconds actually. So you can see scaling of data actually increases the or decreases the computational complexity. So now that the data set is scaled and we have used all the possible combinations, let's take a look at the score that we are getting. Oh, I'm sorry, it's not a grid search. And we're getting 90.33. So it's actually a pretty good score. The reason why we're getting different scores is because the number of times there's a lot of randomness involved in our data set. So if you train it multiple times, you get different accuracies. But as you can see, we're getting a score around 90%. Now, if you want to take a look at what the parameters that they use, you could use the best params method. So not the method, but the property. So C was 10, gamma was 0.5, and kernel was RBF. So we're getting quite close to what we already had. And the C was 1, kernel was RBF. And yeah, so these are the methods that we used, and we're getting a score of 90.3%, which is quite good. Now let's take a look at what happens when we use the random search CV. So if you want to use the random search algorithm, firstly you will have to import it, and importing it is not that difficult. It's in the same package that we already have. Import grid search from, you just have to type in random search CV, run it again. Now using random search CV and grid search CV are quite similar because we'll be using the same almost the same things. So we have the same parameters that we'll be using. We'll be using the support vector classifier as well, and we'll be using the scaled data. So it would be quite similar. So in order to not make mistakes, I'll just copy it, paste it. I'll type in RDM or search CV. Now that that algorithm is done, let me take a look at randomized search. That's what I was wondering. So let's name it randomized search. Again, I'll be passing in a fresh instance of SVC. The parameter grid is the param grid. This is the grid that we created earlier with all the possible parameters that we'll be setting. And inside this one, we need to change it from param grid to param distribution. So because these are different methods and we won't be using a grid, we have to change it to param distribution, and we'll be passing in the grid that we created earlier. It will take a look at this and choose randomized random parameters and figure out the best one that you have to use. Now that that's done, we probably could get away with not passing in accuracy, so it will use accuracy by default. And this is done. Now let's random search CV and we fit it. We use the scaled data and we pass in, and as you can see, it ran actually quite faster than the grid search example that we had. And now that grid search is done, we will be using the same attributes, and we'll be checking a look, checking how much it improved our performance. So we'll be taking a look at random search best score and best params. So let's take a look at that. So random search CV, best score, and as I said that it will take somewhere around the best score even without trying all the possible combinations. The best score we got was around 90%, and we got around 89.66%. So as you can see, that works. Random search CV, and we take a look at the best and RBF and gamma and C. So just the gamma parameter was set a little differently. Otherwise, it shows RBF and C exactly the same as the grid search parameter. And there's not a lot of difference between the gamma that's chosen by the random search and the gamma that was chosen by the grid search. So as you can see, both of them are giving us the right answers, and we are getting the right answers, and we are getting an accuracy of around 90%. So in conclusion, you should use the scale the data to get better answers. Just make sure that when you scale the data, you understand that you are scaling it, and the data that you get from any other source for prediction in the future, you would have to scale the data again. So if you use unscaled data in your production environment, then that would give you incorrect results. So even with 90% accuracy, you will be giving it the wrong data and you'll be getting the wrong answers. So with that in mind, we had how much? 93% of accuracy. Now, I'm sure you're wondering why did we get 90% here and 93 there. So let's again just run it again. I'm running all the parameters again. Earlier we got 93% of accuracy. Now let's take a look at this. We got 92. Let's run it again. So I create a new support vector classifier, fit it again, split the data, train it, make predictions, and 92%. So we get around 90% of the accuracy. You can see again we get 93%. So there's a lot of randomness that's involved here, and when you get some accuracy score from the data set, it's not going to be set in stone. It's going to take some time, and when it does, it'll give you different results. So when you run the random search algorithm again, or the grid search algorithm again, you'll get different results. Let's take a look at that. So as you can see, now you're getting 91% of score, and the estimators are these. So if you wish to use the random search or grid search algorithm, do know that there's a lot of randomness involved, and as you can see, kernel, RBF, and gamma are 0.2, and we are getting a good result. So the accuracy that you'll be getting is going to be around 90%. Scale your data, pre-process it, make sure it's easy to digest by the computer, and make sure that you are using the correct tool for the correct job. If you have a lot of data, don't use grid search because it's going to take a lot of time, even with the scale data. And if you have you use the randomized search, you could probably get away with it using smaller data sets. For larger data sets, random search is quite good. You could get around the same accuracy score, and you would get it much faster.
So let's start this Kubeflow video by taking a quick look at some facts that you might or might not know. See, for example, did you know that Kubernetes has a huge community presence online? Just because it's open source, it's extremely powerful to use, and it's pretty easy to go about working with it as well, right? So one, it's open source. Two, it has a very supportive and a huge community to go with that as well. And then, when you think about the Kubernetes logo, right, it has always the ship, it's the anchor, and it consists of 7 spokes. Well, there is a meaning for that, and the 7 spokes in the logo actually refer to the project's original name. Before it was called Kubernetes, it was called as the Project 7 of 9, and that's how it's got the 7 spokes in the logo. And then when we think about anything open source, right, there's a lot of companies that come into collaboration to see if they can pitch out and come with a common solution. And here in this case, that was the same too, because Red Hat actually worked with Google to go on to develop Kubernetes even before it was actually officially announced or launched as well. So in that particular case, Kubeflow or Kubernetes in general being open source adds a lot of value to the community and of course to the people who are willing to use the technology as well. Now, coming to the introduction to Kubeflow. Well, what is Kubeflow, right? See, when you think about it, you have tools such as Adobe Photoshop for photographers out there, people who want to edit photos and all that. And then when we're talking about architecture and civil engineers, these guys have the AutoCAD tool, right? Now, what do machine learning engineers have when we're talking about using a machine learning pipeline which is hosted in a clustered architecture? Well, that tool itself, the entire platform is Kubeflow. So when we talk about what Kubeflow exactly is, you have to understand that it is one of these very popular open source platforms right now that will help us make use of setting up machine learning pipelines where we can run very complicated, very complex programs and have it run on Kubernetes clusters very easily as well. So by doing this, we can make use of the computation power, the resources, services, and a lot of other things, a lot of dependencies from multiple machines in a cluster at a time. And this can exponentially speed up a lot of complex things. And of course, whenever you talk about artificial intelligence, machine learning or deep learning, you already know that it takes a lot of memory, it takes a lot of processing power, and it's going to take more than this, it's going to take a lot of time to go on to provide a solution. Right now, think about, you're on a website, you have a chatbot that you're talking with, right? Or it's your favorite food delivery service, and there's a chatbot on the other side, and you're very hungry, you're asking where the order is and all of that, right? So in that case, if you send a message across to the chatbot, and if the chatbot takes 3 or 4 minutes to just put out one single reply with a basic reply, it doesn't make sense. So you need that kind of a speed. And it's not just you asking where your food order is, there's probably thousands of people who are doing that at that very second as well, right? So it has to cater to all of these people at once. Now when you consider of a situation like that, when you're thinking about the practical usability and the possibility of how overloaded a machine learning model's implementation can get, in that particular case, I believe Kubeflow is definitely something that helps a lot, especially we're talking about Kubernetes, right? So Kubernetes is one of those tools that is extremely easy to work with. It's very, very powerful, right? So do not be carried away by the fact that it's easy to use, just that it is extremely powerful and it can achieve a lot of things with you doing a lot less. Now, why do I say this, right? See, what is Kubernetes first of all? Kubernetes is one of these tools where we can create applications, deploy them, and operate them in a microservice architecture, right? So but then how do we go on to do this? Like, we know what it is, but how do we go on to do this? So what we try to do is we have a couple of hosts where we make use of the computation power of the hosts, but here we create an abstraction layer on the top, so we are in continuous touch and control with all of these hosts that we have. And you can work with it, you can deploy your applications very, very easily without you having to do many things, as I just mentioned, right? So when you think about Kubernetes, it's going to give you an ocean worth of control when it comes to deploying your applications and when it comes to continuous delivery as well. So in that particular case, it can get a little complex for beginners to get started with Kubernetes, but then worry not. With a good certification program, with good training, you guys can become experts in DevOps and of course in Kubernetes as well. So after understanding what Kubernetes is, how it works, and of course why we have to prefer Kubernetes, you really have to check out how Kubeflow came into the picture, right? See, so we're talking about machine learning and its orchestration on the Kubernetes platform, but then who are the people who brought this into existence? Well, to answer that question, you have really 4 big names you have to talk about. One is Google. Of course, Google is the key player in Kubernetes and everything that has to do with it. We have Cisco, we have people of IBM, and of course we have the experts at Red Hat as well. So these 4 guys, it's not just 4 people from this company, it's probably hundreds of people from each of these companies. They came together, they realized that they want to make use of the power of operations to make sure the machine learning pipeline is simplified, right? A developer should really not break his or her head about deploying the application. Their job is to make sure they solve the problem using code, and they write it and they're done. Now, to go on and take it into a production environment, you need the operating side, right? This is why we require DevOps. DevOps actually bridges the gap in between development and operations. So the people at development can worry about development, the people at operations can worry about actually going on and taking all of these code and scaling it to production pipeline. And of course, you have DevOps engineers and developers and architects who have the capability to bridge these gap in between as well. So with this, you might have a question that states, how will Kubeflow help in today's world, right? See, whenever we talk about Kubeflow, the main thing you have to talk about is its performance, is its ability to work with machine learning pipeline, to host it, and of course to give you that kind of a power of making use of machine learning and orchestrating it very easily at the end of the day. So what Kubeflow actually does is it'll help you build machine learning models. You're going to get all the tools, the frameworks, and everything, as we're going to check out in the components in the next couple of slides. So you're going to have everything foundational enough where you can get started working with the top machine learning frameworks out there, and you can in fact start working with machine learning and get it across ready to production as well. So you can do all of that just with the help of Kubeflow. And then it's not always about just building your model, right? See, building your model is one thing, but the second thing is to see how well the model actually performs. Now, to do all of that, you're going to require certain tools, you're going to require certain skills, and of course, you're going to have a platform that will support model testing too, right? So with Kubeflow, yes, you get features where you can help yourself and of course help the product development team in a way where you can actually analyze the model performance in depth to see where the model where the machine learning model is going wrong, what it's doing right, why it is doing the things it's in the way it's doing, and a lot of these things. So the primary aspects of using Kubeflow is to build machine learning models and of course to analyze to see whatever you have built is either working fine or not. And then talking in terms of in the depth of machine learning, there's so many things that are involved, right? See, with Kubeflow you can actually tune out hyperparameters, you can fine tune the model, you can make sure your model is extremely accurate and that it achieves the solution in the best way possible. In terms of time, in terms of efficiency, in terms of computing power, all of these come at a price whenever you're in a production environment, right? So you have to count for all of these. And if there is one problem, right, you can probably have 3 or 4 ways a machine learning model can solve that problem. Now it is your job to make use of the analysis and to make sure you find the top way to go on to actually solve the problem using that. That's where tuning comes into the picture, and with Kubeflow you can do just that. And then when we talk about version controlling, right, see, in a production environment especially, right, in an official environment where you're working with a team, where you're working on building a product, it's not like you wrote a piece of code and that was the end of it until you close out sales or close down your company, right? So you will have version 1, version 1.1, 1.2, version 2, version 3, version 4. So you're going to have a lot of versions that will be coming out, and it's not just literally these versions being pushed out to production, it's just that you will probably have 100 people behind you who's working on the same piece of code. They're trying to achieve something, a part of the code that you might be working on, a part of the entire project that you might be working on, and everyone is trying to achieve their own subtasks to achieve the goal. Now, to keep a track of all of the changes that gets made in the code, to keep a track of who did what and what changes it had on the production pipeline, be the development pipeline or the production pipeline, and to track all of this actively, to roll back if there's any mistake, to update it to the latest versions, whatever it is, right? Version controlling is important, and Kubeflow is going to help you guys in a way where the use of version control is actually very foundational to the use of the tool itself. And then, as I told you, right, the next set of points we really have to talk about is your ability to control the computing power that you require for your model. Now, sometimes there is a very good chance that you might be running a very simple classifier, right? It can be a binary classifier, or it can be, a very simple linear regression model, or whatever it is that might not require a lot of compute power. In that case, if you have, and in that case, if you have a cluster which really does not have the latest, or the fastest machines, well, yes, definitely you can get away with that. But what if you have extremely powerful machines and you're still using very simple programs out there, right? Of course, it doesn't hurt. But at the end of the day, if you have the ability to dial down the computing power or dial it up and throttle it out as and when you require, depending on the complexity of the machine learning model, well, that's going to save you a lot of time, money, and effort because there will be no bottlenecks that get created in case if the demand is more than the supply, right? For that particular case, Kubeflow is definitely helpful in controlling computing power. And then the next important thing we have to talk about is how we can take model prototypes into production. See, whenever you go on to develop and design a machine learning model, and if you guys are from a machine learning background, I'm sure you guys will relate to what I'm saying now. You will write a piece of code that will achieve almost, let's say, 80% of the task that needs to be done, and you call it a prototype. And now this prototype can go through multiple stages of being redone, being polished, and everything else to take it and make it production ready, right? So you have a piece of code that works, but then at the end goal, we want a product that works. So to take this piece of code into production and to make sure, it's being implemented actively, be it on a website, be it a chatbot, or wherever it's required, right? So to do that, to bridge the gap between taking it from prototyping to production, Kubeflow definitely helps here too. So the next thing that you guys might be curious about at this point of time in this Kubeflow tutorial is the name itself, right? See, Kubeflow comes from Kubernetes itself, but then what are we talking about? What is the connection to Kubernetes out here? And of course, And of course, whenever we're talking about Kubeflow, right, Kubernetes is the basic foundation on which it works. So you really have to know Kubernetes to work with Kubeflow. You really do not have to know Kubernetes in complete depth to be a machine learning programming person who's using Kubernetes. But at the end of the day, it'll always pay well if you are a Kubeflow developer that you know Kubernetes and machine learning well. Now, coming to the actual talk about how the name came about, what does the name mean, right? Let's consider two things here. On the left side, we have Cube. On the right side, we have Flow. Now, what we're trying to signify with the name Cube here is that it runs, these machine learning models run on Kubernetes clusters, right? It's this orchestration platform that we make use of. We have multiple clusters, we have multiple devices in each cluster that we can use to run our machine learning programs on. In that particular case, we're using Kubernetes, hence the name Cube.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So what we're trying to do here is we're trying to train multiple machine learning models across a lot of computers, as I told you, to leverage their speed, leverage their compute power, leverage their resources, and a lot more.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Now, why would you want to do this? It's pretty simple, and I'm sure you already know the answer to it right now, because we want to exponentially speed up the execution. Now, if you have one computer that can run a machine learning model and it's going to take maybe 5 hours to train, but now you have a very powerful Kubernetes cluster that can do very similar tasks probably in 1 hour, which would you pick? 1 hour or 5 hours? Well, 1 hour, right? Similarly, now this 4 hours that you saved probably for your pet project it's simple, it's okay. But then if you save 4 hours in a production environment, you're saving a ton loads of time in a way where it'll either make or break your business in many of these cases. So it's very, very important to speed up execution and keep it as fast as possible. So now coming to talk about the flow part of it. See, with the flow part, what we're trying to understand here is whenever we say flow, it's basically a short for workflow, because we're trying to signal how the model should work, its training lifecycle, testing lifecycle, and all of that from its start, right? So from the ingestion of data all the way till we have results and we verify that the results work correct. This workflow scheduling is very important, and the flow part of Kubeflow talks about that. As I just mentioned, it helps in the complete machine learning lifecycle completion and working. And of course, what this does is, at the end of the day, the developer only has to sit and work on the machine learning code and not break his or her head about how they have to scale it into production and all of that. So this means it's effective and efficient development that's going to save a lot of time and of course a lot of money for the organization as well. So to do all of this, right, so what are some of the components of Kubeflow that will help us do all this? There are many components in Kubeflow depending on your level of expertise, depending on your level of requirement. But then the four most common things that you will use in Kubeflow is pretty simple. You have the central dashboard, you have metadata, you have Jupyter notebooks, and you have the machine learning frameworks that you will actually use to train the model. So let's check out each of these for a second. Now, whenever you talk about a central dashboard, well, this is how a Kubeflow dashboard will look like. However, this is a very old screenshot from the build version 0.7. We're going to talk about the latest version in a couple of slides as well. But then as you can see, right, so you have a lot of notebooks here. You have a couple of documentation things that will help you get started with it. You have a lot of shortcuts where you can create a new notebook server. You can view the pipeline. You can see what's running. You can check out the activities. You can do a lot of things at the click of a mouse button. So having this kind kind of a user interface and a very easy and a nice to use user experience, right? This is what drives the success of Kubeflow in my opinion, because at the end of the day, if you have to look at code all the time to think about operations, leave development. Of course, for development you're going to need code. Now for operations, if you have to keep doing this, it's a major headache, right? So that headache is completely solved by making use of a very elegant, very concise, very pithy dashboard, in the case of Kubeflow with this. And the second thing is, whenever you're working with machine learning, there's going to be a lot of data that gets generated even before you run the model, and of course a lot of data that gets generated into information after you've run the model. So there is data that actually is used to help understand what the all the components mean and all the data mean, and that data is metadata. Metadata basically describes data. Now in a machine learning scenario, you will have a lot of data, such as how many executions were conducted, what was the epoch times in each of these runs, how many training sessions you had, and there's a lot of things whenever we just talk about execution as well. So considering the data just that gets generated out of execution is large, and then of course you'll have the model data, you'll have input output components where of course if you have a model, it means it has a data set. You have to describe the data set. The data set has to be understood by the machine learning model. So all of these individual files that we talk about will have sub dependencies among them, right? There are many files that's required to run a machine learning model. There's many objects that you'll have to consider in terms of input output components. You have data sets, you have the actual model training files, post training files, and there's so many files that you have to talk about. In the case of Kubeflow, right, so this is one important component that Kubeflow provides, where you can simply analyze all of this, manage all of this, and of course at the end of the day use it to see what your model is doing as well. So you have something to describe what your model is doing, and that is metadata. And the third thing that we'll have to talk about is the Jupyter notebooks. See, whenever you're writing a program in Python or in a notebook online, it's a good chance it's a Jupyter notebook, right? Now, in the case of Kubernetes, where you're running a Jupyter notebook across a server, where the server is orchestrated across a Kubernetes cluster, you're gonna need one common place. You're gonna need one notebook where you can work with all your data, right? And of course, with Kubeflow, you can make use of your regular Jupyter notebook, and I'm sure all the developers that we have out here have been comfortable with using Jupyter notebook. It's very simple to use, and it's one of the preferred ways of how a lot of us developers write code as well. So in that case, this actually helps in a way where you can completely concentrate on using Jupyter notebooks for writing code. And the next important component we'll have to talk about is the machine learning frameworks that we can use. See, there are four main machine learning frameworks that that act as a serving that we can kind of use to deploy all of our models through and work with it as well. You have the MXNet, you have PyTorch, you have Chainer, you have TensorFlow serving, and you have a lot of other machine learning frameworks that are supported by Kubeflow too. So this mostly is what you would require to go on to solve a problem with machine learning. And down the line, of course, whenever you're talking about machine learning, it's an ever growing field, so you can definitely expect to have more of frameworks come into the picture with Kubeflow, and with thousands of people actively contributing to the world of open source, it should come as no surprise to you that there'll be complete support of making use of all of these in the Kubernetes architecture as well. So that is something really important, and that you really should know about. So now, on the next section, we can actually talk about how machine learning works with Kubeflow. See, machine learning is done by whom, right? Who is the person who's responsible for achieving machine learning? Either data scientists, or they are either machine learning engineers, right? So these guys have the complete power to make use of powerful computers around them, and to use these computers to the best of their efficiency to make sure that that the computer is working in an optimum way, where it's providing the maximum performance possible. Now, if you're thinking about the same scenario in a cloud computing environment or on a Kubernetes environment, that's going to take some time and skill, right? So this is actually what happens when people go on to implement Kubeflow in their existing machine learning chain. You have data scientists that will create the machine learning models for you, or of course machine learning engineers as well. And once the models are actually created, right, there is an ops team that sits in the picture, where they're going to take all the machine learning models that get created by data scientists and machine learning engineers, and then they take it into production, as we discussed before. Prototype to production. On the left you have prototype, and of course you're going to get the final production code on the left side itself. But then to take it to production, to bridge the gap that exists between development and operations, we have people to do that, and these guys are experts, and they're called as ML ops experts, because machine learning operations is what ML ops stands for. And this is very much required in a production environment too. And to check out the next set on this tutorial, you might be wondering about what is so complex about machine learning that even with Kubeflow sometimes people find it difficult to use. See, there's three main things, right? See, when we talk about machine learning, first of all, you guys learning machine learning and providing a solution for a problem that's out there is going to take a bit of time. So it's not just time that it's going to take, it's going to take equal amounts of effort, because hey, let's face it honestly here, you're using a machine and you're trying to ask the machine to replicate human intelligence. Human intelligence, in a way is probably the most intelligent thing right now. But so if you're asking a machine to do it, so even though the machine has extremely powerful computation power, probably quicker than humans, it has a lot of things that but it doesn't have a lot of things that we do, right? That's what makes machine learning complex to achieve in the first place itself. So it's going to take a good amount of time, it's going to take a good amount of effort, and of course at the end of the day, the result that you will see is worth the time and the effort that you put into machine learning, is what I wanted to convey. Now, when you're talking about the complexity of what goes on in a machine learning pipeline, right? See, the first step involves data collection. This is probably the place where it's going to take the most amount of time, because you need a data set, you need to pre-process the data set, you need to clean the data set, and you need to find out the problem, you need to find out the data set that solves the problem. So collecting data is one of the most important steps when we talk about machine learning. And then of course we have feature extraction. Feature extraction is when you'll keep whatever is required and throw away what's not. This feature extraction is a place where you filter out things and you understand what's required for your model and what's not required. This is a very important step as well, and of course I just put it out in a very simple way, but actually implementing it will take some effort. And then we have model configuration. Model configuration is where you have to understand what type of machine learning should you use to solve the problem. Once you understand that, you must have a model which will make use of the types of algorithms that you think is right for the solution. Be it supervised algorithm, unsupervised, it can be reinforced. It can be reinforcement learning and a lot more as well, right? So you need to find what model to pick, and you need to configure it to at least have the bare bones of it working. And once you understand what you need, all the tools that you have, all the data that you have, and you're ready to actually put it all into code, well, yes, here is where you will require a machine learning engineer or a data scientist to put all of these into effect by converting and typing out the code in multiple programming languages, be it R, be it Python, be it Java, or any other language that supports machine learning as well. And after that, you have something called as workflow monitoring. With workflow monitoring and process management is a way where we're talking about the operations side of machine learning. Once the code is written, once the model is working, once it's verified that yes, this is a solution to the problem, you will have to keep on monitoring it to see how it moves around through the life cycle of the problem. Can it be made better? Version control, how many people are working on the project? Is the project actually complete? Have you met all the all the requirements from the client, and a lot of other things, right? So to monitor all of this easily, the operations part of it handle all of these too. And then process management, right? See, it's not just that you're done as soon as you write the machine learning code. It's all about getting this code ready as a product or an application to the people who are willing to use it, or the people who have paid you to build it. Now, this is another very important thing that follows workflow monitoring, because there's a lot of things in each of these steps, right? See, for data collection, I can probably tell you 10 steps, and for feature extraction, another 10 more steps. So we can talk about 100 steps before we come to the process of workflow monitoring. Now, to break, manage, and make effective use and keep a track of all of these 100 steps, you're going to require a person who's going to sit and manage the life cycle of a machine learning model, right? That is where process management always takes center stage. And then coming to the talk about how Kubeflow came to the picture, even though Kubeflow has been in testing for a while now, there's a lot of beta tests available. The official version 1.0 of Kubeflow actually launched in March of 2020, right? So it wasn't very long ago, but then now there is complete support for Kubeflow. And a lot of people, a lot of companies, in fact, thousands of companies have realized the power of Kubeflow, and everyone wants to use and jump on it to see how best they can use it. One, because it really doesn't cost any money because of its open source nature, and two, if it's open source, it means that there is just thousands and thousands of enthusiasts, people, developers, and a lot of other people with interest who will be developing the product as well. Now, if I was a person who was contributing to the open source community for Kubeflow, let's say I use Kubeflow, I find that something is wrong or something can be made better. What do? I basically, fix something or suggest changes, or actually go on to roll out the changes and tell people saying, hey, this is how I've done better. Now, do that 1,000 times over with 1,000 different people. You have a product which will be polished very nicely with, I'm just giving you a random number here saying 1,000, but there'll be, of course, a lot of other number of contributors out there as well, right? So each of these guys bring about their best to develop the software, and in an open source nature, that will help a lot. And one thing is that the entire Kubeflow project that's happening right now, right, be it from its launch to every single day, the progress these guys make in the community, it can all be tracked on the official Kubeflow GitHub as well. So if you head on to that GitHub, you can check out, right from the inception to where they are now. And I think that in your journey of learning Kubeflow, you really have to understand where these guys came from, what the product was when it officially came out, where it is now, and of course where it is headed as well. So when you're talking about making use of Kubeflow, right? See, Kubeflow is one of these platforms that you can use across a wide variety of cloud computing platforms that are out there. Be it Amazon Web Services, be it GCP or the Google Cloud Platform, be it Azure, be it the Red Hat OpenShift, be it IBM Cloud, and many other clouds as well. So if you are a person who's using any one of these cloud platforms, or if your company is using it, or if you plan to doing it, understand that you can actually go on to implement Kubeflow without you having to put much effort as well. So in that particular case, if we were to show you saying, hey, this is how it works on Azure, or this is how it works on the IBM Cloud, and if you're a person who's using Amazon Web Services, it really won't make sense to you, right? I mean, of course, at the end of the day, you will find out the basics of it, but to understand it in depth, you really have to first find out what cloud platform you want to use. And after that, once you know what cloud platform you want to use, understand that Kubeflow supports everything. So with that in mind, you just start to see the official documentations to see how you can get started with Kubeflow for that particular cloud platform, and then begin working on it as well. And then the second biggest advantage we have to talk about is the TensorBoard support, right? See, we already spoke about how you guys can use TensorFlow and how well you can implement it using the Jupyter Notebook in the cloud computing platforms too. With TensorFlow comes one of these beautiful visualization tools called as TensorBoard, and TensorBoard is completely integrated into use whenever you guys are going to use Kubeflow with all the single features that it brings. So with this kind of a support for TensorBoard, what you can do is you can tune out all the model parameters, and you can work with the performance checking and analysis of your models, and tweak it, tune it based on your requirement, right? At the end of the day, it's going to save a lot of time, it's going to save a lot of effort, and if you have saved time and effort, it means you're making more money in a production environment, and it is as simple as that. It's not just saving time and money. When we talk about TensorFlow, you have to understand that this kind of a data visualization that we get, it's extremely aesthetically pleasing to use. It's completely functional in a way where if you probably see a lot of data in charts, you might not pick up a fault in the data, but then as soon as you put it out and lay it on a graph, that will stand out to you like a sore thumb. So in that particular case, using TensorBoard is something which is very effective too. And then when we talk about model deployment, right? See, with model deployment, it is extremely important that you understand that, TensorFlow it's ready to use with TensorFlow. Of course, you can use PyTorch, you can use frameworks such as scikit-learn as well. And with this case, you have to understand that depending on your model complexity, you're going to require resources, right? So in this particular case with Kubernetes, you have something called as auto-scaling that happens, right? So it will go on to assign these resources automatically based on the level of computing power your machines need, and it's going to start scaling from maybe 1 machine in a cluster to 10 machines in a cluster, 100 machines in a cluster, to go on to actually have the best performance possible too. And then when we have to talk about the Kubeflow serving as well, right? So this is one of these tools that will run locally and on the cloud premise as well. So it is not that you have to have a compulsory cloud setup to make use of Kubeflow. If you have a local network architecture where you'd want to use this, of course, you can use that as well. So that kind of a flexibility is really one of the big advantages that comes whenever we talk about model deployment. And then with model deployment, with this kind of a ease of use, it means, of course, efficiency goes up again. When efficiency goes up again, you save time and money. You save time and money, you're making more money to the organization itself, right? So guys, now let's take a quick look at the GitHub, and of course take a look at the Kubeflow website as well. And now, coming to the GitHub, as I told you, you can track their entire project here, right from what's happening right now, all the pipelines that they have, the manifest, the websites, their entire community and everything. So they have a huge GitHub profile, where they have a huge GitHub profile where you can check out a lot of things here. So make sure at the end of the day, before you start working, or as and when you start working towards learning Kubeflow, right, understand what they're doing in a way how best you can use it, right? So you can there'll be all the top languages that they've put using. You can see JSON.NET, people are using Go, TypeScript, Python, and a lot of others as well. So if you just click on these repositories, you will see a lot of things. And of course, whenever you talk about all the dashboards that go on to use it, and all the tests that go on to see if these dashboards are functional, the updates are working or not, you can find a plethora of information on this particular website. So I would really suggest and urge that you guys check it out. And after that, coming to the actual Kubeflow website, to get a quick start, you can of course take a look at the documentation to get work with, right? It's one of the biggest machine learning toolkits out there right now. We have to work on Kubernetes. And one important thing, as I mentioned in our session, before you start working with Kubeflow, right, you need a basic understanding of Kubernetes. And of course, you're going to need something called as Kustomize as well. Kustomize is one of these configuration management tools that will give you a template free way on how you can work with the tools as well. So in that particular case, you really wouldn't require a lot of customize, but of course the knowledge on Kubernetes is definitely something that's needed. So you can see how you can go on to choose a Kubeflow deployment option as well. Do you want a single node deployment where you're going to run everything in one particular node on a cluster? You can do that. Do you want to have a cloud deployment based on all the types of clouds that we discussed? It is possible. So do you want on-premise installation? Do you not want on-premise installation? So based on all of that, right, it's going to give you a lot of flexibility to go on to get started as well. But then, as I just mentioned, to go on to use all of these on a cloud platform, guys, you really have to follow certain basic rules. And of course, it's not just rules, certain installation steps that are out there. See, for GCP, these guys have a deployment guide. For AWS, they have another one. If it's Microsoft Azure, what we call as AKS, then of course they have another one. IBM Cloud, there's another one. If we have more documentation for OpenShift as well. So to deploy all of these, what's the first step? You really have to go on to install it, right? So these guys will give you the complete steps that you need to basically get started with it. Of course, you're going to need a lot of training to use it. You're going to need a lot of head start, structured way of learning to understand first of all what this is, why it is used, all the things that we already checked out, and then actually using it, right? So in this particular scenario, depending on where you want to deploy Kubeflow, they're going to give you install instructions. They're going to tell you how you can uninstall it, how do you create a cluster, how do you use the ICRs, or what we call as the IBM Cloud Registries. There's so many different things, and of course they provide all the basic documentation to do this, and that's what makes me very happy about it. And then once you are ready to, let's say, go on to use it, now you want to make use of Kubeflow on the IBM Cloud, they're going to give you in depth about how you can first of all deploy it, and how you can install it, how you can secure it, and all of that, right? So with each of these tools, it's basically a very simple command line interface. You're going to need a command line interface where you log into the cloud, and once you log into your cloud, be it AWS, be it IBM, you just have to run a couple of commands there to make sure you can get all of your storage up, everything, and you can work with the deployment process. Well, you're going to have to build the code, you're going to have to allocate the resources, deallocate the resources whenever it's not required. You have to configure auto scaling, multi-user mode, version controlling, and all of that, right? So you have all the code, all the documentation basically that's needed to get you guys started. So if you just click on the documentation part on their website, you should have the basic understanding of how you can go on to use this on any cloud platform of your choice that these guys support as well.
Now let's start off with deep learning. So deep learning is a subset of machine learning where it learns through data representations as opposed to task specific algorithms. So we saw that the drawback in machine learning models was that the models are specific to only one particular task. But this is not the case with deep learning models, as these deep learning models are based on the data representations, and these deep learning models are mostly built with something known as deep neural networks. So this is how a deep neural network looks like. So these deep neural networks completely learn the data which is fed to it. So this is the data. So let's say if this image of woman is fed as the data to the deep learning model, then it will completely extract all the features of this data by itself. Again, the difference between ML and deep learning over here is that the feature extraction in machine learning is manual. But when it comes to deep learning, the feature extraction is automatic. So the deep learning model automatically extracts all of the features associated with that image. And when new images are fed to it, it automatically is able to tell whether the image is same to this or not. So this over here we have a graph which tells us how does performance vary with respect to the amount of data. So what happens in machine learning is that as we keep on increasing the data, the performance increases only up to a particular threshold. After that, if we increase any more data, there is no increase in performance. So this is another problem when it comes to machine learning. But on the other hand, when it comes to deep learning, the more amount of data you give it, the better will be its performance. And that again is because deep learning is based on learning data interpretation. So the more data you give it, it will automatically learn all those features of the data by itself, and it will be keep on increasing its performance gradually. Now let's look at some applications of deep learning. So speech recognition is one application of deep learning. Now you need to understand that you cannot build speech recognition applications with machine learning. So this is where machine learning fails and deep learning comes in and helps you to build speech recognition applications. Also, another application of deep learning is self-driving cars. So we see over here that the person is just sitting. He is not even touching the steering wheel and the car is driving by itself. So just an amazing application of deep learning. And then we have language translation over here. So this again is a part of deep learning. So over here we are typing something in Spanish and it is being automatically converted into English. So we also have visual translation over here. So over here this text or this board is in some random language, and this app over here which uses deep learning automatically converts this visual into English. So those were some applications of deep learning. Now let's actually understand how does deep learning work. So most deep learning methods use neural network architectures, and that is why deep learning models are often referred to as deep neural networks. So a deep neural network basically has these three models: an input layer, the hidden layers, and the output layer. And the term deep usually refers to the number of hidden layers in the neural network. So traditionally, neural networks only contain 2 to 3 hidden layers, while deep networks can have as many as 150 hidden layers. Now that's a very huge amount, isn't it? So deep learning models are trained by using large sets of labeled data and neural network architectures that learn features directly from the data without the need for manual feature extraction. So all of the input data is given to this input layer, and this input layer automatically extracts the features by itself. Now That data is sent to this hidden layer which performs all sorts of processing tasks, and then the final result is given out through the output layer. So now let's also understand what exactly is a neural network. So a neural network is a computing model whose layered structure resembles the network structure of neurons in the brain with layers of connected nodes. So it can learn from data which can be trained to recognize patterns, classify data, and forecast future events. So the neural network is based on the biological neural network of our brain. So that is why it is given the name neural network. So the layers are interconnected via nodes or neurons, with each layer using the output of the previous layer as its input. So its main function is to receive a set of inputs, perform calculations, and then use the output to solve the problem. Now, as I've already said, these artificial neural networks are based on something known as a biological neural network. So, our biological neural network has dendrites, cell body, and axon. So dendrites are where the input is taken, cell body is where the processing is done, and axon is where the message is transferred to other neurons. And the same thing happens in artificial neural network as well. So first we give in the data, that data is processed, and then the final processed result is given out as the output. So over here, let's say we train the data with images of cat, and the labels would be either cat or not cat. After that, we give in a new image of a cat, and then we basically try to predict whether the model correctly classifies this as cat or not cat. And since the model has learned the data properly, it correctly classifies this image as cat. Now, there are many ways of knitting the nodes of a neural network together, and each way results in a more or less complex behavior. Possibly the simplest of all topologies is the feed-forward network. So when feed-forward neural network, signals flow in one direction without any loop in the signal paths. And typically, artificial neural networks have a layered structure. The input layer picks up the input signals and passes them on to the next layer, known as the hidden layer. And there can be more than one hidden layer in a neural network. And at last comes the output layer that delivers the result. Now, the first question to pop into your head would be, what is the inspiration behind these artificial neural networks? Well, the answer to that is the biological neural network of our brain. So let us first understand the architecture of a biological neuron. So as you can see in the slide, our biological neuron has these three main components. So we have the dendrite, the cell body, and the axon. These dendrites receive the signals, and the cell body processes these signals, and the axon finally sends out these signals to other neurons. So just like the biological neuron, the artificial neuron has a number of input channels, a processing stage, and one output that can fan out to multiple other artificial neurons.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So now let's understand these artificial neurons in detail. These artificial neurons are the most fundamental units of deep neural network. It takes an input, processes it, passes it through an activation function, and returns the output if the condition is met. Or else it will process it again until you get the correct output. And such type of artificial neurons is called as a perceptron. So they are basically like a linear model which is used for binary classification. So as the figure shows, we have x1, x2, x3 and going on till xn as inputs in the input layer. Now, to which we add the weights and the bias that are randomly selected. So here we have W1, W2, W3 going on till Wn as weights. So we multiply these weights with the corresponding inputs and add all the values together, and finally we add bias to that sum. So this final sum is passed through an activation function which finally gives us the output. So let us see this in detail. So here we have 3 arrows which correspond to the 3 inputs coming into the network. Now for these 3 inputs, we have corresponding weights associated with them. So input 1 is associated with a weight of 0.7, input 2 is associated with a weight of 0.6, and input 3 is associated with a weight of 1.4. Now, these inputs are multiplied with their respective weights and their sum is taken. So if the 3 inputs are x1, x2 and x3, the sum would be x1 into 0.7 plus x2 into 0.6 plus x3 into 1.4. And to the sum, we add an offset which is called as bias. So this bias is just a constant which is used for scaling purpose. Now let us understand the concept behind these weights. So these weights basically determine the relative importance of the inputs. So let's say we have 2 inputs, humidity and wearing a blue shirt. So here we can see that wearing a blue shirt has almost no correlation with the possibility of rainfall. So that is why the weight assigned to input x2 would be low in order to bring down its importance. Now let us see why do we need activation functions. So consider this scenario where you have 2 different classes. One class is represented with triangles and the other class is represented with circles. Now let's say I ask you guys to draw a linear decision boundary which can separate these 2 classes. So is that really possible? Can we draw a linear line which can segregate these 2 classes? Well, the answer is obviously no, isn't it? So let me tell you guys how can we do this. So we'll have to add a third dimension to create a linearly separable model which is easy to deal with. So the logic is, when you're going from 2D to 3D, you're making your equation non-linear. So with the third dimension, I have introduced non-linearity in our data, which helps in creating a linearly separable model. And in real-world situations, you don't always get linear problems. So you should know how to deal with non-linear problems as well. And this is where activation functions help us to convert the linear equation to non-linear form. So these activation functions bring in non-linear functional mappings between the input and the response variable. Their main purpose is to convert an input signal of a node in an artificial neural network to an output signal. And if we do not apply an activation function, then the output signal would just be a simple linear function neural network. Then we have the leaky ReLU, which is just a modified version of ReLU. So the leaky ReLU, instead of just completely removing the negative part, it just lowers the magnitude. And finally, we have the softmax function, which is ideally used in the output layer for classification problems. So the softmax function basically gives a set of probability values for each class of the output. And that particular class, which would have the maximum probability, will be our output class. So that was all about activation functions. Now let us learn more about perceptrons. So like we were taught how to behave in certain conditions, perceptrons also require training. So they have a learning algorithm through which they produce the output. By training a perceptron, we try to find a line, plane or some hyperplane which can accurately separate these 2 classes by adjusting the weights and biases. So consider this image where we give the dogs and horses as input. So here after the first iteration, error value is 2 since the horse has been classified as dog and there is one dog which is placed in the horses class. And in the second iteration, the error value is reduced to 1 as it is just the dog which is classified as a horse. And finally, in the third iteration, we get the correct output as the perceptron has been trained well with no error. So all the dogs have been placed in one class and all the horses have been placed in one class. Now let's understand the perceptron training algorithm. So this perceptron over here receives multiple inputs and each input is initialized with a random weight. So after these, we multiply these weights with their corresponding inputs and then we get the sum. Now this input is passed through the activation function which would give us a non-linear output. So this process until here is known as feed forwarding. Now, if the output which we get is not optimum, we calculate the error in prediction and then go back and then update the weights and bias. So this process where we go from output to the input layer is known as backpropagation. And we keep on backpropagating until we get the desired output. So that was the perceptron training algorithm. Now let's have a look at the benefits of using artificial neural networks. So the artificial neural networks can learn organically. This means an artificial neural network's outputs aren't limited entirely by inputs and results given to them initially by an expert system. So artificial neural networks have the ability to generalize their inputs. This ability is valuable for robotics and pattern recognition systems. Artificial neural networks also help in nonlinear data processing. So nonlinear systems have the capability of finding shortcuts to reach computationally expensive solutions. These systems can also infer connections between data points rather than waiting for records in a data source to be explicitly linked. This nonlinear shortcut mechanism is fed into artificial neural networking, which makes it valuable in commercial big data analysis. Artificial neural networks also have high potential for fault tolerance. When these networks are scaled across multiple machines and multiple servers, they are able to route around missing data or servers and nodes that can't communicate. And these artificial neural networks can also self-repair themselves. So if they're asked to find out specific data that is no longer communicating, these artificial neural networks can regenerate large amounts of data by inference and help in determining the node that is not working. This trait is useful for networks that require informing their users about the current state of the network and effectively results in a self-debugging and diagnosing network. Now, to implement these artificial neural networks, we would need the help of a deep learning framework. So the first question to pop into your head would be, what are the different deep learning frameworks available? So today we'll cover just that. So let's start with TensorFlow. So TensorFlow is arguably one of the best deep learning frameworks that we have today. It is an open source software library developed by the researchers and engineers from the Google Brain team for high performance numerical computation. One well-known use case of TensorFlow is Google Translate. So Google Translate is coupled with capabilities such as natural language processing, text classification, forecasting, and tagging. So TensorFlow basically comes with two tools, TensorBoard and TensorFlow Serving. So building massive deep neural networks could be complex and confusing. This is where we can use TensorBoard to visualize our TensorFlow graph and plot quantitative metrics. And then we have TensorFlow Serving, which is a flexible, high-performance serving system and can be used for rapid deployment of new algorithms while retaining the same server architecture and APIs. So now let's look at the next deep learning framework, which is Keras. So Keras is actually a high-level API which can run on top of other deep learning libraries such as TensorFlow, Theano, or CNTK. And with the help of Keras, we can implement both convolutional neural networks as well as recurrent neural networks. And the best thing about Keras is, model building is extremely easy. It's like stacking layers on top of each other. So next, we have PyTorch, which is a scientific computing framework developed by Facebook. So we can get from the name itself that PyTorch is Pythonic in nature. That is, it can leverage all the services and functionalities offered by the Python environment and also smoothly integrates with the Python data science stack. Another great feature of PyTorch is that it offers dynamic computational graphs which can be changed during runtime. This is highly useful when we have no idea how much memory will be required for creating a neural network model. And the next deep learning framework is DL4J. So unlike deep learning frameworks which we saw till now, which were all based on Python, Deep Learning 4J is a deep learning programming library which is written for Java and the Java virtual machine. And the biggest advantage of DL4J is it includes inbuilt integration with Apache Hadoop and Spark. So it helps in getting state-of-the-art results on image recognition tasks. So it shows matchless potential for image recognition, fraud detection, text mining, parts of speech tagging, and also natural language processing. And finally, we have MXNet. So MXNet is a deep learning framework developed by Apache Software Foundation specifically for the purpose of high efficiency, productivity, and flexibility. And the beauty of MXNet is that it gives users the ability to code in a variety of programming languages, such as Python, R, Julia, and Scala. This means that you can train your deep learning models with whichever language you're comfortable in without having to learn something new from scratch. And this deep learning framework is known for its capabilities in imaging, speech recognition, forecasting, and NLP. So when you hear the term TensorFlow, the first question to pop into your head would be, what exactly is a tensor? So in TensorFlow, data is represented in the form of tensors. Simply put, a tensor is a multi-dimensional array in which data is stored. So you can consider these tensors to be the building blocks in TensorFlow. Now, these very tensors are given as the input to the neural network. So as I've said, a tensor is nothing but an n-dimensional array. So the number of dimensions used to represent the data is known as its rank. So if a tensor has just one element, in other words, if it has just magnitude and no direction, then its rank will be 0. If a tensor has magnitude and direction in one plane, then its rank will be 1. Similarly, if a tensor has magnitude and direction in two planes, then its rank will be 2. And this goes on higher up the order. Now, TensorFlow, as the name states, is a combination of two words, tensor and flow. Here, the data is stored in tensors, but the execution is done in the form of a graph. So this is not like your traditional programming where you just write a bunch of lines and everything gets executed in sequence. So first, you'd have to prepare this computational graph, and then this computational graph is executed inside something known as a session. Now, in this computational graph, all the mathematical operations are depicted inside the nodes, and all the tensors are represented on the edges. So the entire computation process is done in two stages. In the first step, the code is depicted onto the computational graph, and in the second step, a new session environment is started and the graph is executed inside this session. So that was all about the computational graph. Now let's look at the program elements in TensorFlow. So we have three program elements: constant, placeholder, and variable. So let's start with constants. So constants are program elements whose value does not change, or in other words, the value is fixed. So let's head on to Jupyter Notebook and work with these constants. Right, so my first task would be to import the TensorFlow framework. So I'll type import TensorFlow as TF. I'll click run. So let me just wait till the import is done. Right, so we have successfully imported the TensorFlow framework. Now, as I've said, let's go ahead and start working with the constants. So let me just type in constants over here. So I'll create the first constant and name this constant as con1. Now this is how we can create constants in TensorFlow. So I will use this TF and then put in a dot and then type in constant. Now inside this, I will give the value of the constant. So let's say the value is 10. So this is an integer type constant. Now similarly, I'll also create a floating type constant and I'll store this in con2. So I'll type TF dot constant and the floating value would be 3.14. Now after this, I'll create a string type constant. So again, this would be TF dot constant and the string which I'd be giving would be this is Sparta. And finally, we have a Boolean type constant and I'll store this in con4. So this will be TF dot constant and let's say the value is false. Now I'll run. Now let me print all of these values. So I'll use the print function and then I'll go ahead and print all of these values, con3, con4. Right. So we see that This first constant is a tensor of type integer. The second constant is a tensor of type float. This third constant is a tensor of type string, and this fourth constant is a tensor of type boolean. Now we see that we only have the data types of all of these tensors, but we don't have their values. This is because, as I've already told you guys, we have to create a computational graph and then execute that computational graph inside a session. But till now, we have not started our session. So let's go ahead and start a session first. So I'll type sys equals tf dot session and I'll hit run. Now I will run all of these inside this session. So I will type sys dot run.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
And let me go ahead and run all of these: con1, con2, con3 and con4. So this time we have the values of all of these tensors. So the value of constant 1 is 10, the value of constant 2 is 3.14, the value of constant 3 is this is Sparta, and finally the value of constant 4 is false, right? So first we'd have to create all of the constants, then we'd have to create a session, and inside this session we'd have to run all of these constants. Now let me go ahead and perform some simple operations on all of these constants. So let me just type in operations over here. So I'll do a simple addition operation. So I'll type addition over here. And let's say the value of the first constant is 20. I'll put a plus symbol. And then I'll take in the next constant, and the value of the second constant would be 30. So I am basically adding two TensorFlow constants. The value of the first constant is 20, the value of the second constant is 30, and I'm storing that result in addition. Similarly, I will multiply these two constants now. So multiplication tf dot constant. So I'll give the value of 20. Now I'll put the asterisk symbol, and then this would be tf dot constant of 30. So this time I'm multiplying these two values, right? So I'll hit on run. So now again, if I'd have to see the resultant addition and multiplication values, I'd have to run these two inside a session. So I'll type sys dot run and then put in these two values over here: addition and multiplication, right? So we see that 20 plus 30 gives us an addition value of 50. And similarly, when we multiply 20 with 30, we get a result of 600, right? Now, so this was basic operation with scalars. And we already know that tensors can have higher dimensions. So let's go ahead and perform addition and multiplication with these higher dimension tensors, right? So again, I'll just put in addition over here, and I will take in the first constant, and inside this I will give in a list of values. So let's say I will take in 1, 2, 3, 4 and 5, and I will add this list with the next constant. And this time the second constant has the values of 5, 4, 3, 2 and 1. Similarly, I'll also multiply. So multiplication equals tf dot constant, and this will have values, let's say the same values, 1, 2, 3, 4 and 5. Let me put a comma over here, right? Now I'll put the asterisk symbol. Again, I'll type tf dot constant, and I will give in the list of the values 5, 4, 3, 2 and 1. Now I'll hit run. Again, I need to run these two inside a session. So sys dot run. Let me put in addition over here. After that, I would also need the multiplication value. Right, so this is a result. So when we add 1 plus 5, we get 6. When we add 2 plus 4, we get 6. Similarly, when we add each of the corresponding elements with these elements inside the list, we get all of the 6s over here. Now let's take this multiplication result. So over here, when we multiply 1 with 5, we get 5. When we multiply 2 with 4, we get 8. 3 cross 3 gives us 9. 4 cross 2 gives us 8. And again, 5 cross 1 gives us a 5. So this was addition and multiplication with respect to lists. Now let me also do a simple operation on strings. So let me take in the first string and name it as str1. So this is a constant. So tf dot constant. And let's say I type over here, I love, and then I give a space. Now I will take in the second string, which would be str2. And inside this, and again, this would be a constant. So tf dot constant, and the value of this constant would be TensorFlow. Right. Now I will run this and let me execute this inside a session. So ses dot run of str1 plus str2. So the result which you get is I love TensorFlow, right? So the first string is I love, and then there's a space, and the second string is TensorFlow. So when I add these two strings, the resultant is I love TensorFlow. Right, so that was all about constants. And then we have placeholders. So when it comes to placeholders, we don't have to provide an initial value and can specify it during the runtime. So this allows us to build our computational graph without needing the data. And this is how we can create placeholders. So tf.placeholder is the syntax. And inside that, we just give the data type of the variable, which we will substitute later on during execution. So let's head back to Jupyter and work with these placeholders. So let me just type in placeholder over here. So let me create my first placeholder. So I'll name that as A and tf.placeholder. And this would be of integer type. So tf.int32. Now I will create another variable which would be b, and the value of b would be actually a cross 2. So let me run this. Now I will run these two inside a session. So ses dot run, and I want to see the result of b. So I'll put in b over here. Now since we know that a placeholder takes in a value during runtime, so this is when I'll feed the value to this placeholder A over here. Now to do that, I would have to create something known as a feed dictionary. So feed dict equals, let me create a dictionary over here. So it would be A, and the value which I'll be giving to A would be, let's say, 5. Now let me run this and let's see what do we get. Right. So during the execution time, I have assigned a value of 5 to A. And when we multiply this 5 with 2 over here, we get the value of B, which is 10. Right? So all of this is happening during runtime because with the help of a placeholder, we can assign it a value during execution. Now, similarly, let me go ahead and give a list of values over here. So instead of 5, let me give the list of values 1, 2, 3, 4, and 5. Now I'll run this. So over here, 1 cross 2 gives us 2, 2 cross 2 gives us 4, 3 cross 2 is 6, 4 cross 2 is 8, and 5 cross 2 is 10. So you get an array of values during runtime. Now similarly, let me also create a placeholder for strings. So I'll type string placeholder over here. So now let me create this variable and name this as string name, and this would be your placeholder. So tf dot placeholder, and I am taking in a string. So tf dot string. Right. Now let me create another string over here. So the name of this string would be my name, and let's say the value of the string is I am. All right. Now let me run this. And I'll execute this inside a session. Ses dot run, and I want the result of my name when I add it with respect to string name. Now let me also create a placeholder for strings. So I'll just type string placeholder, and let me create the first placeholder. So I'll name that as str1 name, and since this is a placeholder, tf dot placeholder, and I will be giving in a string during execution time. Now I'll also create another string value over here and name that to be my name, and the value of this string is I am, and then I'll give a space. Right, so now I'll hit run and let me execute this inside a session. Now let me also create a placeholder for strings. So this will be string placeholder. Right, so let me create this placeholder. I'll name this as str name, and since it's a placeholder, I need to use tf.placeholder, and I will be assigning a string to this during execution time. Now I will also create another string which would be my name, and this would be equal to I am, and there's a space, and I will be adding this with str name. So let me hit run. Right, now I'll execute this inside a session. So for that, I'll type sys dot run, and I want the result of my name. So I'll just put in my name over here, and then I'll provide the feed dictionary. Feed dict equal to, let me put in the dictionary over here, and I will assign the values of str name over here. Right. So the values of str name would be Sam, Bob, and Charlie. Now let me hit run and let's see what do we get. Right. So what we are basically doing is we are adding this with the placeholder value over here, and we are giving the values during the execution time. So I am Sam, I am Bob, and I am Charlie. Now these three values are coming from this feed dictionary during the runtime. Right. So this is all about placeholders. And finally, we have variables. So a variable is just a program element which allows us to add new trainable parameters to the graph. And this is the syntax to create a variable. tf.variable, and then we give the value, or we initialize the value, and then we specify the data type of that variable. Right, so let's head back to Jupyter now. I'll just type in variables over here. Right, so let me create my first variable, and the name of that variable would be var1, and we can create a variable like this, tf.variable. So guys, you need to keep in mind that this V over here is actually capital. Right. So now after this, I would have to assign a value to it. So let's say I assign this variable a value of 20, and this is of integer type. So tf.int32. I'll run this. Now another thing to be kept in mind is whenever we are declaring values in TensorFlow, they have to be initialized. So this is how we can initialize all of the variables. So we have something known as global variable initializer, and when we invoke this function, all of the variables which we have declared would be initialized. I'll hit run. So now let me execute this inside a session. So sys.run of init, and I have initialized this variable over here. Now let me also go ahead and run that variable, sys.run var1. Right, so we have the result of var1, which is 20. Now since this is a variable, the value of a variable can be actually updated. So let me go ahead and update the value of this. So I will name this as updated var1, and the function would be tf.assign. And inside this, the first parameter would be the variable which I'd want to update. And after that, I need to give the value to which I'd want to update this. So I want to make this value of 20 to 25. Right, now I will run this. So now this is actually a variable. We can actually update the values. So let me go ahead and do that. So the name of the updated variable would be, let's say, updated var1, and the function for that would be tf.assign, and this takes in two parameters. The first parameter would be the variable which we are supposed to update, and the second parameter would be the value to which we are updating it. So I want to make this 20 to 25. I'll hit run. Right now, let me run this inside a session. Sys.run, and I need to pass in the variable which would be updated var1. Let me make it small v over here. I'll run this. Right. So initially the value of var1 was 20, but we have updated it and made its value to be 25. Now let's also go ahead and create a small linear model. So let me just type in linear model over here, and this is how our linear model would look like. wx plus b, where w and b would be variables and x would be a placeholder. Right, so let me start off by creating w. So w is a variable, so w would be equal to tf dot variable, and I am initializing it with a value of, let's say, 10, and this is of integer type. So this would be tf dot int 32. Now,
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
similarly, I will also assign the value for b. So b is also a variable and its initial value would be 5, and this is also of integer type. And finally, we have x, which is a placeholder. So x is equal to tf dot placeholder. And since placeholder does not actually take an initial value, it just takes a data type. So the data type is again tf dot int 32. So I'll run this, and now what I'll do is I will multiply w with x and add b to it. So the equation would be w cross x plus b, and I will store it in a variable and name that variable to be linear model. Right, so this is w cross x plus b. I'll run this. Now again, if I have to execute this, I have to run this inside a session. And since also I have created two new variables, I'd have to initialize them first. So init1 equals tf dot global variables initializer. I'll hit run. So now I will create a session. So sys.run, and I will execute init1 first. So I have successfully initialized these two variables w and x. Now I can go ahead and run this linear model. Sys.run. Now I would want the result of linear model. So linear model, and then I will use the feed dictionary. Now inside this feed dictionary, I would have to assign a value to this placeholder x. So x equal to, let's say I give a list of values over here, and the list of values would be 1, 2, 3, 4, and 5. Now I'll run this and let's see what do we get. Right. So if the value of x is 1, we get 15. So this basically means that 10 into 1 plus 5, which is 15. Now after that, if the value of x is 2, so this would mean 10 into 2 plus 5, which is 25. Similarly, if x is 3, that would mean 10 into 3, which is 30, plus 5 is 35, right? And same is the case for 4 and 5.
Okay guys, a quick info. If you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below. Let's continue with this session.
So let's go back in 1980s. There was this crazy guy called Geoffrey Hilton. He proposed that we could mimic somehow the mind, how a human mind works, and we can mimic the way it works, so that we can also try to make a thing out of it, so that whatever our mind is doing artificially, we can also do that thing. So he proposed a paper, and everybody said that, Hilton, listen, you are doing something wrong. This is not what is right.
and everybody, didn't like uh, the way things were going on. But after 20 years, almost in like late 90s, around 1999, he again came up with this paper. He brought in his paper, but this time with a proof, and he won a contest that is called ImageNet in 2004. This time he came back and everybody had to listen. So we were at 2004 when he won the ImageNet. I have two people who I've already told that, ImageNet is ImageNet is actually in a competition. It is held by a uh, joint vision of Stanford plus Princeton University. These guys come up and they downloaded a corpus of images. Now they have a very large collection of images, around 1 million images, around covering 1,000 categories. They have. You can just click on explore and you can see this tree around here. So what you have to do is that you have to make a model out of it so that you can classify the images. So people used to make, hand coded classifiers, and they were working, but at some stage, they had to fail, because like now, let's say that fish, you are trying to detect a fish, but fish cannot every ways be in the same manner in which you are building the hard coded thing, right? Or let's say that you are trying to detect a cat, and then you say, okay, top right if it is a eye, top left it is a eye, and then it's a squishing mouth, then it's a cat, right? But now the cat face will not always be available to you in that particular fashion, right? It might be a top view, a side view, a bottom view, any view might come up, and at that time people used to fail. But in 2014, 2004, when Geoffrey Hilton came with his paper, the competition he won was with 94% accuracy, and that was never achieved, and it surpassed the human accuracy also. So that was where, when people started listening to him and he came out, then he proposed slowly that, okay, that this is what I think, that artificial neural network is nothing, but that we are trying to mimic what is happening in our own mind, right? So if I say that what is the theory, what Geoffrey said about neural network is that he said that artificial neural network is a computational model that is inspired by the way biological neural networks in our brain human information possesses, right? So I mean, most of you know this thing, that that our nervous system is made up of axons and okay, I'll show you the photo, that it is made up of axons and veins. A human nervous system is most basic diagram, and everybody of you might have seen this. So how this works is that there is a exact replicate copy of this. If I copy this, and you can attach it back here again. So these are the axon terminals that are connected to dendrites again, and this is how it flows. So let's imagine that your fingertips where you can have your dendrites, and these are like small particles again of your pure neuron connected to your brain. So this is how there are like millions of these connected, and they're connected. If I take this, okay, one more feature of Jupyter Notebook that you already know, that you can add a markdown language. So what I do is I do escape M, and then I'll write HTML inside it. So I write img src is equal to, this is how you can write your, in this you can add that this is, right? Let's now look at it one by one, slowly. Okay, so these are called dendrites. These dendrites are the one who are like septicles. These are the one who are responsible for catching all the information and sending it forward to the nucleus. Now nucleus processes this thing and it sends to this axons, and again throws it out to the axon terminals. Now imagine again that this is this copy, this is again replicated here, back here. So you can imagine that these dendrites are connected to these axons, right? And then they're flowing. Now imagine, let's say that you touched a very hot glass, right? The moment you touch the hot glass, the dendrites at your fingertips, they sense that something is very hot there. So they send this information to your brain, okay, that this is hot. Now imagine this dendrite is processing the information, sending it to terminal to dendrite, and dendrite to terminal. It goes on until it goes to your brain. Now the brain says that this is very hot. You should remove your hand. Okay. Now this process is again flowing back to the dendrite, the original dendrite here. Let's say that this is the original dendrite here. Okay, and your brain will say that this is really hot. You should remove your remove the fingertips from the glass. And now when I'm saying that this information is going on, believe me, from your fingertip to your brain, there are like millions of these dendrites who are connecting and flowing this information. Now again, a process of reversal information flow is going on, and this time your brain is sending a signal that remove your hand from the glass. And this is again going back to the fingertip, and then you release your hand from the glass. But in real life, when you touch the glass and when you remove it, how much time do you take to remove this? It's just some nanoseconds, right? I mean, less than. Your reflexes are very strong. You just remove the hand out. But imagine what is happening when you do this. Your brain is not, your hand is not taking the decision of removing that. You might think that, okay, my hand is taking the decision to remove that. No. The hand is like a slave of brain. So every body part of ours is like a slave of a brain, right? Whatever we are doing, it is sent by the brain. The information is sent by the brain, and then it's doing. This is how your body works, right? So it's a slave of your brain, and the brain sends the information, remove or attack, whatever it is, then it reacts. But it's really fast, right? Similarly to this way only, Joffrey said that, okay, this neural network, this is how even I will also build a neural net. Now I'll show you how a basic neuron looks like. Here it is. This is the image. You write it. Basic neural. It's not a network, it's just a neuron. But this is an artificial neuron. So Joffrey said that, okay, this is how I propose. Let's do the following. Let's say that your hand is not doing anything. Your dendrites or your nervous system is not, this basic neuron is not doing anything. Imagine that it's doing nothing. But it is reciprocating the information. But how it is reciprocating the information? By activating itself. So when you touch a hot glass or something, it activates itself, and then only it's transmitting the thing, right? Now imagine if this would have not activated, it would have sent nothing, right? So this is also playing a very crucial role. See, brain is sitting somewhere like a million neurons far, right? He doesn't know what is happening to your hand until and unless this neuron is sending the information. So what information will the brain process if it doesn't have the information? So these guys are very much responsible for sending the information, and they send the information only when they're activated. So this dendroid will become, this nucleus will become activated, then only it will send the further information. And see, there is also a basic kind of a information processing is going on. It doesn't mean that these dendrites are just sending blank signals. See, I'll tell you more depth inside. See, these dendrites, they collect the information. These dendrites, they collect the information and they send it to the nucleus. Now, nucleus thinks that should I process this and send it forward? Yes or no. Depending on that, nucleus sends it further. Right. Now, how is nucleus sending is? Nucleus has a particular threshold value. After processing it, it says, okay, if I am activated by that processed value, it will send it further. If not, it will keep it to itself. So this is also how a basic artificial neuron, when I say artificial, it means that the one that we are building right now in deep learning, right? This is also built. Now what is happening is that imagine this round thing that you're seeing is the nucleus. This thing is a nucleus. But this is a nucleus, right? And these are the dendrites to it. This one, this X1 and X2. This is the way of thinking how we are intimating, and this is the tail, axon tail, and it is again connected to again a neural network. So it's a chain of multiple neurons going on. Now if we go mathematically, what is happening inside this? It is nothing but a linear combination of all the inputs with a bias. I just went to the very human biological way and I just sent a sentence. It's doing nothing. What it's doing is that it collects the input. Let's say that you have two inputs. Let's say that you have two inputs, X1 and X2. These are your two inputs. Now to every input, you will give some weightage to it. Let's say our weightage is here. This weightage is called W1 for X1 and W2 for X2. Correct? Now what I said, it is trying to build a linear regression, right? So what it does, it multiplies the weight of the corresponding input to itself. So W1 X1 plus W2 X2 plus it adds a bias to it. Now you will ask, what is a bias? I'll say, imagine that there is another input called X0. There is another input called X0 and the value of X0 is equal to 1. The value of x naught is equal to 1, and there is this weight associated to it that is called w naught, right? So this bias is added to it, and then you add this. That's it. You plus all these values, multiply plus all these values, and you give this output to something called y. This is all a neuron does. Make sense? Any questions? Please ask. It's very important that you build the intuition that what is happening here. So this is the most basic. It's the smallest part of a neural network that you can pick. And the smallest part of a neural network is doing this. That it takes all the inputs that are coming to itself, give them some weightage, multiply the weightage to the corresponding input, and then sum all these, and then add a small bias to it also. That's it. Over.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
How is this weightage and bias being introduced? That who is, okay, x1 and x0, x2 and x1, I can say, okay, someone is giving to us the input that what is the temperature of the glass, let's say. It is coming from the outside environment. x1 and x2 is coming outside. But who is giving this w1 and w2? So, okay, so the answer is that in a artificial neural network environment, at the very first instance, they are randomly allocated to it. So see, you all guys have learned ML, right? So how does ML work? ML says that I know the output, and depending on the output, I have to give some weightage to these inputs so that they can give me the output. Now, you know that the output will be y. You know that the output is going to be y, right? Now, you want to make some equation where y is equal to x1 plus x2. Okay, and now this is not the correct answer, right? x1 and x2 will never give you y1. So what you do, you add some w1 here, some random w1, and then here random w2. What it will do, it will not give you the answer. W1 and W2 will not give you the answer. You will do some corrections again in W1, W2, and ultimately it will give you Y. So this is what is happening. At the very first instance, you will take W1 and W2 as random. First is that does the process is reverse? Yes, it also reverses itself. The model will not only go from x1 x2 to y, but it can also come back from y to x1 x2. And second, let's say that he's asking Shivam, does it process recursively? Recursively, just imagine that there are like thousands of, now I'll draw it again to show you. This is just a very basic one, right? Now imagine what is going on here is that this is the small that you saw, right? X1 x2, and it is giving some y. Now here it is again, there is a x1 x2, and then this is giving me y. Now this y and y1 will become an input for some other cell, and then it is giving here. So are you imagining how will it look like? This becomes this, and this will become again an input for some other. So these are like connected. These are like throwing information from one to another, one to another, one to another, right? But this is how it works. This is how a small network looks like. And this is if I write down the theory, it says that the basic unit of computation in a neural network is a neuron, or often called as a node, right? And came write it very right. This is called a node, or you can say it a unit also. So it receives input from some other node, from an external sources or external source, that I was saying, right? Also, right? The x1 and x2 might be an input from another neuron, or it might be given to you directly from the external environment, right? Computes the object. Each input has an associated weight to it, which is assigned on the basis of its relative importance to others. The node applies a function f to the weighted sum of this input, right?
We'll be having the students' data, so whatever the marks, based upon their marks, so we have to decide the grade. So we have to adjust whether the student is passed out or failed. So we will be adjusting the marks based upon the grade.
This is a very hard-coded problem, I think. But let me take an example that you're working on a machine learning problem where you are trying to find out the loan defaults, right? Right? In bank, you have multiple people who take the loan. Now the bank wants to know how will this person repay the loan or not, right? Now you already have a historical data with you. The bank will give the data to you. Okay, let's say that this is the data with you. So in that data, you already know that if this is the feature of a person, this is the credit history of the person. Based on that, they will also give you that, okay, he paid, he didn't paid, he paid, didn't paid, right? And based on that, you adjust your model, right? So there also you have a X and Y with you. You will have your X and Y with you at that particular instance also. Okay, so everybody gets this this function thing, right? That's how this function is working. This function f is called the affine. So the f function that you see, this is called the affine thing, and it's doing nothing, right? You saw that this is it's doing a linear thing here. We're just multiplying the weights to the corresponding x1, x2, and you might now consider x1, x2 as the importance feature. So the more important x1 is, the more higher the value of w1 will be, right? The more lower the value of w2 is, it means it doesn't make much sense to y. So everything that we will now talk will be with respect to y. So the x2 is not making much sense to y, so the value of w2 will be very less. Let's say y is dependent on x1, so this value of w1 will go more higher, right? And then your bias you already have, this is a static thing, right? Because the x naught associated to it is equal to 1, right? Let's now go back at what further happens here. Now you get the y out of here, right? Now this y thing is a little, you have got the answer, and this might be greater than 1 or less than 1 also, right? So there is no measure of this answer. It might happen that w1 w2 is very small. Let's say w1 w2 are very small, then the value of y might be almost equal to 0, right? Or let's say that w1 value is very high, like very high, so the value of y might also get very high, right? So now this might bring some bias, this might bring some ambiguity to our model. This y might be sometimes, next to infinite, it might be equal to infinite, or it might also be equal to 0, right? Depending on the variables. And we don't want that. We want our y to be in some particular range, right? We want our y to be in some bonded weights, right? Then comes next guys whose names are activation functions. Activation functions. Now we got to know that how this y is made, right? How this y is ultimately achieved. Now to adjust the value or squeeze the value of y, we need some other thing, right? We need something that can control the value of y, and these are called activation functions. Now what activation functions does is that they will take the value of y and they will squeeze the value of y in some certain range. What they will do, they will squeeze the value of y in some certain range. So we have multiple, let's say we have a step function, we have a 10h function.
Shivam, Sanjay said, can you please come again about this activation function? Not getting you properly.
So let's come back what this activation function is. So you understand that the value of y, how it is calculated, right? It is now totally dependent on w1 and w2. If the value of w1 and w2 is very less, I mean 0.0000, or let's say 10 to the power minus 23, then the y is going to be very less, right? Next to 0. Or let's say that the value of w1 and w2 is like 10 to the power positive 48 plus 48. So this might be very high. The value of y might be very high. There might be no standard to control this value of y, right? Mathematically, there is no, this value can go from negative infinite to positive infinite, right? And this is not a very good range to get about a particular output, right? So what we do is we introduce something that is called activation functions. Now what this activation function will do is activation function will make sure that your output that you have got y should be in some particular range. What it should be? It should be in some particular range. Now how do you decide that who is going to be in what range, and how is that range called? See, the activation function, if I ask you mathematically, the mathematical purpose of introducing an activation function is to squeeze the value of y between some variable called 0 to 1, right? Majority times. So the purpose of activation function is to bound the y in some range, right? And this range might be -1, say 1, 0 to 1, or sometimes 0 to infinite. It might be different things, right? I was at this thing that mathematically the value is to be squeezed between 0 to 1. But if I talk to you about statistically why I am doing this is, now imagine till here, till this particular range, your model is a linear model. Everybody agrees with me, right? This is a linear model. Nothing non-linear have been done till now, right? All the things that we have done till this step in this circle, everything is linear. There is no non-linear thing, right? Now, linear things are a little bad at classifying things if there are more than 3 classes, right? If I ask you, can you, if let's say there are 3 classes, one is like crosses, right? One is circles, right? And one is some triangles. Now, can you make a single line and can divide these 3 data? No, right? If it would have been 2 classes, you might have, drawn a single line and you might have divided the data into like 2 classes, right? But if it is a 3 class data, how will you divide this? You have to ultimately make a triangle kind of a shape or this kind of a shape, right? Then only you can divide the divide this thing, right? So I'll show you a photo also. Let's say, let me give you an example, then I'll show you how this works. Okay, can any one of you, let me hide it here. Now this is this thing in front of you. Everybody can see your data. There is this red dots and there is a blue triangle in the screen, right? Everybody can see this. Now, can you make a linear model that can separate these two things? This can only do in a 2 dimension, right? But if I say you that, okay, see a magic, anybody wants to try this thing? How will you do? No? Okay. What I'll do is, I'll remove this now. So what I did was, I introduced a 3rd dimension. And now I could easily separate by introducing a hyperplane here. And then I can say, okay, something that is above this hyperplane is red, something that is below this hyperplane is blue. Makes sense to everyone, right? So this is why we do activation function, to make sure that we want to classify things more better, to make things more clear. We do an activation function. So mathematically, why we are doing activation function? Because we want to squeeze the value of y somewhere. But if I talk statistically, what we are doing, we are introducing non-linearity in a linear model, because linear models are very much not capable of classifying things in when the number of classes increases. So now we saw that as soon as we increase the linearity, if we increase the dimension in the data, if we introduce non-linearity in the data, what it is doing? It increases the chances of making a linear separable model, right? Right. So if I say in three times, first mathematically squeezing the y. Second, if I say graphical thing, why we are doing this? Because we want to introduce a new dimension. And statistically saying why we are doing this, because we want to introduce non-linearity inside it. Now you might be asking what these functions do. It's a very good question. I have activation functions graphs. See, this is how a sigmoid looks like, a tanh looks like, a ReLU looks like. And see, everybody is bounding. So see, sigmoid is bounding between 0 to 1. Tanh is bounding between -1 say 1. ReLU is bounding from 0 to infinite. So it lets go everything that is going above. Yes, we have step function also. Step function says that you can go, if something can be only have 2 things, either 0 or 1. If something is negative, it goes 0. If something is positive, it goes 1. It's a step function, sigmoid, tanh, ReLU. So there are multiple things. These are doing the same thing that we want to do for a activation function. ReLU, you can understand that if something is negative, it says it's a 0. And if something is positive, it lets go whatever the value of this is, right? I write the variables in here. This is what brings in. Sigmoid is this, tanh is this, and ReLU is this, right? What is the maximum of 0 to 1? That ever value it will take, right? This is what activation functions is. Let's say that you have this thing called y1 and y2, right? And now the value of y1 and y2 is very large, right? So this y3 will become ultimately also very large, and this y4 will become also very large. And we know this is not the exact thing. We always expect our output to be in the form of 0 to 1 if it is a classification problem, and if it is regression problem, then it will always be in some range from 0 to 1, right? You all agree with me, right? In machine learning also, whenever you did a classification problem, you one hot encoded the problem. So you never said that the output is going to be a C80 cat or DOG dog, right? You always said that, okay, if 0 comes, this is cat, 1 comes, then it's a dog, right? You did the same thing, right? In machine learning also, or if it was a regression problem, then you always regress a value from 0 to 1 with a multiplicative factor, right? So this is what is happening here also. The y3 and y4 ka value can never go up beyond a limit. To control that limit, we have to squeeze the value. And see, when I'm saying squeezing the value, that is in mathematical format. But if you see in statistically, what we are doing is that we have to introduce non-linearity into the data, right? Because linear equations are not good in separating non-linear data, right? Right? This becomes separable. You see, now it is very much separable just by a simple hyperplane. Okay.
So, suppose you are a computer vision engineer and a client has approached you with a problem statement in which you have to detect the faces from a set of images that they will be providing, and you have taken up this project, and these are the following steps that you have to follow while building up this project. So, these are the images that they have provided to you. These are some of the images that have taken from their dataset, and here we'll be working on Python with OpenCV. In this project, we will be using the Har cascade classifier for detecting the faces from multiple images. So, firstly, you have to perform the downloading part for the Har cascade system. So, here I have written download Har cascade frontal face default.xml and this raw GitHub code. These are the raw datas for the Har cascade. You have to just simply save as, and you can save it as desktop, and you have the Har cascade classifier. So now next we will be just importing the CV2 and glob. So now we will be practicing it in the Jupyter notebook. So firstly, you have to import the CV2 library and glob. So I want to tell you that glob is the function which returns us the array of those file name which we will write in the next line. Like we just have to perform face detection on those images which have .jpg extension. So for that I will be writing gimage equals to glob. So here I am calling the object glob and with the function glob, and here inside the function I will be writing the star.jpg. So it will take up all the images that have extension .jpg. So after that we will detect after getting the glob images. Now we will create cascade classifier so that we can, so as it helps us in getting the face detection, it contains all the features of the images like nose, ears, face, object. These are some of the features of the image. So here we will be writing detect equals to cv2 dot cascade classifier. Then inside the braces we will be writing which classifier. We have downloaded the Har cascade frontal face default classifier, so we will be mentioning the same name, Har cascade. Okay, Har cascade frontal face default.xml. So now after creating the Har cascade frontal face default XML file, then what we will do, we will now traverse the glob images so that we can detect the faces. So for traversing, we will be creating a for loop for traverse, or you can also write t image for traversing the image, t image in g image, the glob image. Okay. So now it will take one image at a time. Now in the for loop, we will read the image, a particular image. So for just reading the image, we will write like I have taken image equals to cv2 dot I am read. And what is this reading? The T image. Okay, so after reading the particular image from the G image, now we will convert the images. These are the colored images. The image that it has read, it is the colored images. So in this phase detection, we will first have to convert the colored image into the grayscale image. So it is easier for the classifier to handle the image and detect the faces from it. So for converting the image from converting the colored image to grayscale image, we will write gray image. I have written this gray image equals to cv2 dot cvt color, and in the braces it will have this image that you have to convert it into grayscale. This image comma we will write cv2 dot color and underscore bgr to gray. Okay, so after converting it into grayscale, now we will detect the faces from the images. So for detecting the faces, I will be writing the face equals to detect. I am calling this object here and with the function detect multi-scale, and it has 3 parameters. So the first one is in which image you want to detect the face. So we will be writing this gray image here, and the next parameter is the scale factor. So we have to see the value of the scale factor, as the scale factor is that value which decreases the volume of the whole grayscale image by 5% until the face is detected. So it basically what does it decreases the value of the image so that it can find the face from the image. So I am writing 1.25. The smaller the value is, the greater will be the accuracy. So I am writing 1.25, and the next parameter is the minimum neighbor. So we don't have to bother this value. Now after that, after detecting the face, now we will be describing the rectangle shape for the face. So for that, create a for loop for. Now in this braces, we will be writing all the dimensions for the rectangle like x, y, w, h, length, breadth, height and width. Okay, so after the parameter, now in face, we are actually we have detected the face, but now we have to define that face with a rectangle shape. So for that, we will be using the dot rectangle function. So here I am writing cv2 dot rectangle. Okay, rectangle. Now in this we have 4 parameters. The first one is the image that you have to detect the face image, this image that we have read it here. Okay, the second parameter is the RGB value. RGB value means the colored value. So here I am writing the x, y, and then the other parameters for the rectangle. We are basically defining the parameters of the rectangle, how it will look on the image. So we will be writing x plus w, y plus h. Okay, so after defining the parameters of the rectangle, now we will be look at the color of the rectangle. So here I am just taking the green color. So this is the code for green color. Okay, 0, 0. Okay, so now after that the last parameter is the thickness of the rectangle. So I am giving 2. So now after defining the rectangle, now we will just show the image. So for displaying the image, cv2 dot imshow, in the parenthesis we will be writing detect any message you can write, like detect images. Okay, and comma, which image? This image. So image. Okay, so after displaying the images, now we will be defining the wait key function. What does wait key does is we will define some intervals between the images. It's just a time period that what will be the intervals between the images. So cv2 dot wait key, and how many I am taking 200 milliseconds, sorry 2000 milliseconds, and we will be writing cv2 dot destroy all windows. So destroy all windows will closes all the windows based on the wait for key parameter. So here I am writing the 2000 milliseconds, so it will destroy it for that. So here, okay, so I am running this code. So here you can see that all the faces have been detected.
So have you ever shopped online? Let's say you're searching for a mobile phone on Amazon. Now you would have noticed that the site recommends you mobile phones which are in the same price range or by the same brand. Now if you leave the site without purchasing the product, then you'd be getting ads recommending you to purchase the same product on almost all the websites that you visit. So how is this really happening? Well, all of this is possible because of machine learning. Now there are thousands of real-life applications of machine learning which you use on a daily basis, either knowingly or unknowingly. Confused? Well, let's go through some of the examples. So all of you would have a Gmail account. Now, how do you think Gmail is able to segregate your emails into different folders such as primary, promotions, social, spam, and so on? Or let's say you're sitting on your couch and happily browsing Netflix. So you get a list of movie recommendations which are very similar to your past watch history. So have you ever wondered how is this possible? Does the machine know you personally to suggest movies similar to your interest? And even while driving, Google Maps suggests you which route has more traffic, which route would be faster for you, and how long will it take to reach the destination if you continue on that route. So how do you think Google Maps does this? Well, all of these are just applications of machine learning. Well, all of which arises over here is, what exactly is machine learning? So it's not just about robots. Machine learning is a sub-branch of artificial intelligence which focuses mainly on machines learning from their experience. Let me explain this to you with an analogy. So consider a newly born child who initially knows nothing. So he goes to school to learn. Now, the teacher starts with the alphabets. The teacher shows picture of letter A to the child and tells him it's A. He repeats the process again and again till the student learns all the alphabets. So here the student is being trained. Once the training is complete, teacher conducts a test to verify how well the student has learned. Now, we'll use the same analogy to a machine. So initially we have a machine which knows absolutely nothing. So we start training the machine in a similar way. So the machine has no idea about what is A or what is B. So we start by showing our machine various pictures of the letter A and teaching it that it's A. Once the training is complete, we test the machine by showing it the letter A of different fonts and styles. And if the machine is able to identify the letters accurately, then it means that the machine was trained well. If not, then in order to increase the efficiency, we have to train a machine with more images of A of different fonts and styles and again test it and check its accuracy. So the more training we give, the more accurate our machine would become. So this is the concept of machine learning. Now machine learning can be broadly classified into three categories. So we have supervised learning, unsupervised learning, and reinforcement learning. So when it comes to supervised learning, we teach the machine using data which is labeled. Let's say we have a basket of fruits and each fruit is tagged with a label. Now the machine is trained on this label data. So once the training is done, it is given test data or new data to determine how well the training has been done. Now let's take another case where the training data doesn't have any labels associated with it. Here the machine understands the underlying structure of the data to identify similar patterns. And the data which is similar in nature is grouped together. So here the machine understands that all the apples are similar in nature and thus they are grouped together. Same is the case with bananas and mangoes. So this type of machine learning is known as unsupervised learning. And finally, we have reinforcement learning, where the algorithm learns through a system of rewards and punishment. Let's say if we feed the machine the image of apple and it labels it as an apple, then it will be rewarded. But on the other hand, if it labels the apple as pineapple, then it will be given negative points. So the greed of getting more and more reward points lets the machine make thousands of decisions, and this is how the machine is trained.
So let us now get started clustering. Certain terminologies which I am writing for your final carousel or takeaways, like I will be discussing something about the segmentation. We'll be discussing about the various algorithms into that clustering, I will also discussing something called targeting. K-means is the fundamental idea we are going to discuss, and so on and so forth. So these are all the terminologies which are there into the support of K-means clustering or the overall clustering as an idea. How and where these things falls into the picture, let us discuss that. So the overall perspective would be focused on three basic questions, my dear friend: why and how. That means our primary agenda would be focused on what is clustering, why clustering, how clustering. And in line with all of these concepts, we will be going through with these terminologies. Before I move forward, there is a fundamental question, what is very genuine to be known and understood: how this keyword of clustering is different and same as of segmentation. In industry, particularly into the data science and data analytics, there are two keywords called clustering and segmentation, which are being used interchangeably. But there is a significant difference in between them too.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Fundamentally or theoretically, there is a difference in between them too. But in the industry, formally, professionally, knowingly or unknowingly, these two keywords are being used interchangeably. How? When I talk about segmentation, segmentation is actually a mathematical, descriptive, conditional, basic cutoff and split in the data. Like if you have, I have a column of salary for all the bank account holders or the income of all the bank account holders. I can split that into 4 or 5 chunks. And based on that only, I can offer the titanium card, credit cards, like I am offered with the gold card many of the times or silver card. So when I say segmentation, segmentation is actually a conditional, mathematical conditional based descriptive cutoff or split in the data. When I say data, you guys must be realizing the fact that you are grouping the rows. And if you will connect the dots based on what we have been discussing earlier during the statistical classes, when I was explaining you the concept of deciles, percentiles, and quantiles, I hope you remember the concept of deciling. Yeah. So this actually is deciling. If you will see this diagram, you have been deciling all the salaries of the folk, maybe 1 lakh or 20 lakh or 10 lakh or millions of the records are there. All of those records are either marked in first decile, second decile, third decile, and 10th decile, 10th decile being the highest one. So if you will understand the sketch, needless to mention that this is the first top 20 or 30% customer group. So this is nothing but a simple Pareto rule, 80-20 rule. You remember that Pareto rule in your life? This is a basic simple rule, right? Would be coming from the top 10 or 20% customer. This is what the Pareto rule comes, which is being alternatively called as 80-20 rule. This is ideally the way out. 80% problems are being, they are responsible by the 20% causes. You should read about that actually. A recommendation from my side. So when you are talking about all of these things, so this is the top 30%. This is the another 30% or 40% group. This is the another remaining last 30% group. So this is a basic rule in the industry as well for the segmentation, my dear friends, by and large done by the concentration curves. So we used to put it like high potential customer, medium potential customer, or low potential customer. So it might be a possibility these 30% customers gives you 80% sales, and these last 30% customers gives you only 5% sales. Might be a possibility. So which 30% group I should be targeting precisely? Obviously this one, right? I should be focused on this group in a detailed, concerned fashion. So this is a global phenomena. This is what the segmentation is either what you are doing with the basic cutoff, like average salary is greater than this and that, or with the deciling even. Whatever you are doing, you are just grouping the rows appropriately. So the concept of segmentation is also grouping the rows, whereas the concept of clustering is also grouping the rows. But how clustering is different of segmentation is now what we are going to explore. So to conclude this conversation, segmentation is what? A mathematical, descriptive, conditional cut or split in the data, be it with the decile percentile or with the other checks. Now comes clustering. Clustering can be considered as grouping the rows, but how? This is nothing but algorithm-based approach or methodology. When I say algorithm-based, that means it is something which you are getting the data being grouped into several groups without any conditions being mentioned or deliberately passed on. And you are leaving the overall data with all the required variables to the statistical algorithm to understand the in and out overall characteristics and the properties. And when I say characteristics and the properties, this actually takes the count of or takes into the consideration of the behavioral aspects of the data. When I say behavioral aspects, like overall basic difference in the attributes collectively based on your age, income, location, or XYZ other thing. Whatever the variables you are passing on, this will take all of the columns into the consideration on a very common note altogether, and then will identify the groups, which is ideally being called as clusters. So what is clusters? Clusters are the groups being created by the statistical algorithm, considering all the demographics and the other columns into the consideration or the characteristics in such a way that each group is homogeneous internally and heterogeneous across. I'm repeating my statement once again. The clusters are being created in such a way that each group is homogeneous internally and heterogeneous across. Let me now revisit the entire episode and conversation so that you can have a decent, fair understanding and you can connect the dots in a moment. 3 or 4 examples I will be giving to you. I think I should be giving only 2. 2 are enough. To start with the concept, let us assume that I am now quitting my full-time MNC job, and in the beginning I have 100 soft leads. When I say 100 soft leads, so if you will understand that from the business perspective, from my perspective as a trainer, then ideally I should have teach each one of you individually on a one-on-one basis. If I will understand that, if you will understand that from my business perspective, from the business objective, ideally, in order to get the most satisfying results, outcome, and the services, to get the best feedback, bottom line, I should ideally be having a one-on-one sessions with you, teaching with you, so that you guys can continue with your own pace, learning curve, your IQ, your grasping skills, your aptitude, and so on. So he can get me continued or adjust the pace of the course accordingly. But this is not possible with the fact that all of you guys are into the same one single batch. Hence, long and short, if you'll understand that from business perspective, I should have 100 batches being started for each one of you. Isn't it so? But considering the point, I don't have really the time bandwidth to get 100 batches being started simultaneously. I can't really go for that. So hence, what I will then do is, I will split this data into 2 or more than 2 cluster or groups ideally. Either I call it like a group or a cluster, same thing. I will overall split those 100 students into or more than 2 groups in such a way that every group being created, be it red, orange, or green. So I will be distributing the overall folks, like 100 students are there. So let us assume 40 are there, 25 are there, and 35 are there. Just assume, okay? So this comes to a conclusion that all these 40 students there in the green cluster are very much similar to each other. That means the clusters are being created in a way that all the clients, folks, customers, patients, doctors, on whatsoever you are doing the analysis on, with the almost similar liking, choices, interest, behavior, characteristics, properties, expectations would be there in one batch or one group. That means this is going to be homogeneous internally. When I say internally, as an example, Akash in this batch would be overall expecting or having the same input properties expectation from the course what Aditya might be having. Not exactly, but to a certain extent or almost. Okay. That means people in this green cluster would be very much similar, not exactly, but very much or almost similar, and would be very much different from the folks in the another group. This is what clustering as a property, as an idea does. Now, the reason for me to do is that rather than getting the 100 batches being started at this point of time, because I know that all these 40 students are almost having the same aptitude, same interest, same type of background, academics background, all of them are actually fresher. They are all looking for the job to start with. So I will be then drafting a course content for them and will be putting them into a same one batch. Because I know that might be all of them are absolutely new to the entire data science industry with zero experience in the analytics world or data science world or the IT world altogether. So I will keep Microsoft Excel, SQL, then the basics of statistics I will keep. I will keep one BI tool like Power BI or Tableau, and then I will start with Python. So I will keep all of the Excels and the SQL content. When I say Excel and SQL content, this is by and large overall curriculum gets fit for this entire group. Might be a possibility Aditya can say that, Ankur, I know Excel, so I don't want to read Excel, but this is not a possibility for Aditya to get another batch. So he fits best into this cluster. So the point is, I can't really get started with the 100 batches, but yes, I can at least get started with 3 batches altogether, which is like one for green group, one for orange group, one for red group. And the important part, which I would like you to understand, my dear friend, that as far as the statistical operations and the processes are concerned, you would be just thrown with the clusters, in which cluster a particular row is falling in. Then it comes to you back into your code. The ball gets back into your code to identify the similarity of all the items into one group and how it is different from the another group. That means you need to somehow introspect, track the pattern of how this is homogeneous internally and how it is different or heterogeneous across. And that is only the basis how you can then plan how to reach out to these groups. That means another answer, why you are doing the clustering, to target the group, so that you can best possibly target the audience with the best of your possibilities with the available resources. So this is what the clustering is, and this is why you are doing the clustering. So if you're asking and having an answer of question of what is clustering and what is segmentation, I told you why clustering and why segmentation, even again for the same purpose, targeting. In your previous learnings, I remember I must have discussed one RFM segmentation with you. Do you guys remember that? Akash, Ankita, Arshad? RFM segmentation, did you discuss that? Transactional data, active customers, and so on. Yeah. So at that time also, when I say you have to target them with the cross-sell, upsell policies or the retention activities or the reactivation campaigning, that was nothing but a targeting approach. So if you will ask me why clustering, the answer goes like for targeting. And that is the reason in many of the organizations and companies, to be very true, in my company also, I have been a part of a COE, which is like Center of Excellency, which has been named as segmentation and target. We are actually targeting the customers and planning the strategies for them after doing the clustering and segmentation. In fact, in all the leading organizations, be it KPMG, PwC, and the core data science companies.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
We have the division like this. Clustering can be considered as a primary approach even before the classifications or defining the groups. As an example, I think I already discussed that example long way before, but I am still repeating that. After doing some clustering, I got some clusters which I'm now showing into the different colors, like orange, red, and so on. In this episode, let us suppose these are the clusters being given by the algorithm. Now the point is like how I should be targeting them. The way how you should see is like, let us assume these are all the folks who are currently using the two-wheeler. So I did some survey and the data is about the interest being shown by the various car users or car purchase interesting people, like potential customers who are interested to buy the four-wheelers or cars as a vehicle. So this is the group I could see, folks using currently the two-wheelers. They don't have very much high income and they are now looking to buy a car, not as a luxury, but for a family need or a family purpose. So obviously, I will be targeting them with the basic entry level hatchback cars like Santro in India, Alto K10, Quid or Baleno, so on. Whereas this red group seems, after understanding the internal properties, I could see that this group seems to all those folks who are decently earning well, already have the car with them. Now they want to upgrade that car as per their increased living standards and status. And they want to have a luxury car. So obviously I will be offering them the latest sedan car with the latest features. Then comes the another group. This group seems, as I'm seeing that you will be reading the homogeneity and heterogeneity. Now this group, after my investigation or studying the similarity and dissimilarity, this group seems all the folks in this batch are very much rich. All the family members are already having the car with them, but now they want to have an additional car in their family with the adventurous purpose. Because they are very good with the money, they are filthy rich people. So I will definitely be then offering them with the SUV cars, a luxury SUVs. But coming back to the last group, this one, I can see something like this group is having very high ambition and dreams of purchasing and taking the fun of the luxury SUV car. But one thing common in all the clients, customers in this group is that they don't have enough money or their budget is not appropriate to get into a comfortable SUV car currently into the market. So in order to satisfy their expectations or the requirements, company will think about how to target them. And in order to get into the gist of all of that idea, they can probably come up with the concept of some new products for the overall fitment of this group. And when I say they will draft a new product, that is the only reason you can think of something new into the market. As far as this example is concerned, something like compact SUV. This is a budget class SUV, which in Indian context was not there before 2010, right? So after that, there came Creta or Brezza. So Creta or Brezza is what? The compact middle class SUVs, right? So you are getting these products to target the group is what the objective of the clustering is. I hope this example tells you everything now. So to get some more constructive learning, I will be discussing few of the additional things with you, what I have. Just take an example. So this is actually a chart I got created on our data after clustering. And the clustering has been done primarily on two columns, the spending score and annual income. To get this idea being discussed, this is the first group, this is the second group, this has been the third group, and this has been the fourth group. From this group, you can take the insights directly that this is the group which is low on income and low on spending. This is the group which is high on income but low on spending. This is the group which is high on income and high on spending. This is the group which is high on spending and low on income. Considering in which particular cluster it falls and the homogeneity and heterogeneity, I can better plan to target them. Like as an example, for this green group, I can target them with the upsell strategies because I know they are the rich people but not spending that much. Whereas to this orange group, I can target them from the cross-sell strategies because I know they are good to spend the things. Their earning is also good and they are very much interested to spend the money without any pain. So considering in which particular group certain thing falls, you can target the groups accordingly. Hence, there is one single learning and keyword, my dear friends. Why you are doing the clustering? The answer will be targeting. That's all, full stop. So this is what the basic bottom line is and the idea. I will prove all of these points in a moment. Let us continue with this idea. There is a data set called IRIS. IRIS is a very commonly used data in the entire data science, data analytics space across the globe, globally, geographically, be it in India or in the other geographical locations, be it in R or Python even. In Python also you have this data set. I will show you right away. There are several data sets in every platform, be it R or Python, which are preloaded. These data sets are actually preloaded. Why preloaded? For your better learning experience, for training and development, for the demonstration, and for the better learning experience across the globe geographically. So a lot of things are there which you can look for. Not only this one, but you have so many other data sets as well. So you can clearly see in Python, we are getting this pulled from datasets.load_iris. So dataset is actually a preloaded library there in sklearn. Can you see that? And this contains the dataset called iris. So not only this, but you have a lot of other data sets as well, like Boston data set and so on. So at least 50, 60 different data sets are there, which you guys can use for the better learning, training, and development purpose. So yeah, this is what the idea. So whatever the data I am now using on R is also there available in Python. So nothing is absolutely going to be different here for you. There is a magic which I want to create here for you guys, and you would be surprised to see. First of all, let me show you how this data looks like. Iris, I got this triggered line number 1 and loads my data set in my system. Currently, this is the Iris data set having 150 records and 5 columns. Out of those 5 columns, 4 of them are numeric, which is sepal length, sepal width, petal length, petal width, and the 5th column is categorical, character in nature, having the species of the flower. This iris dataset is actually a dataset based on a flower or the various varieties of that flower of iris. Its overall dimension, the length of sepal width, petal length, petal width. Needless to mention that 4 of the variables are numeric. Last variable is categorical. If I will continue putting the cluster over this data set as a whole, what I am now doing, it has thrown me an error. That's the error. When k-mean is not the right name, and the correct keyword is k-means. K-means algorithm. S is important. When I triggered that, you can see this has shown me an error because of that same problem of categorical data. Hence, instead of passing all the 5 columns, I will now be getting continued with the first 4, which are numeric columns. And you can clearly see, I literally got the results being generated automatically without any trouble. So a couple of the interesting things for you now, which I am getting discussed. For your interest, my dear friends, you have literally done the clustering. So clustering is done. Congratulations. Thank you so much. Done with the exercise. Isn't it interesting now? As I told you, the major effort is not to get the clusters being created, which is just a quick way. What important is to understand why the rows are being there in group 1 or group 2 or group 3. Before I move forward, there are certain basic conceptual know-hows I would like to reiterate, which I am sure and I am remembering I got this discussed at the time of discussing that earlier as well. Now, what I literally want you to understand that, let us assume if I am increasing the number of clusters in my data from 3 to now 4, what will be the change in homogeneity and heterogeneity? When I say change, which one is gonna increase and which one is gonna decrease? What will be the impact overall if I will be increasing the number of clusters from 3 to 4 in the data? How the homogeneity will change, how the heterogeneity will change? Over to you guys. Correct? I hope everyone is convinced with what Arshad is saying. Every group will start getting more homogeneous, other way around, or synonymously or simultaneously. the groups will start getting dissolved further and further. That means they would be, so heterogeneity will decrease and homogeneity will increase. Isn't it so? Cool. You guys are brilliant actually. Thank you. Now, considering this idea, you have to really go into a very detailed input, which I'm now discussing with you. When I got this code being triggered, I actually got a model created in the form of my mod. So when I got this model being triggered, you are actually getting a lot of the components within that clustering model being created. So somewhere like 7 to 8 components are there. One of them is cluster, centers, dot ss, within ss, total within ss. But certain keywords are there like the split size of every cluster. So out of 150 records, so altogether you have 150 records. Those 150 records are being by and large split into 3 groups, whereas the group A is having 50 records, or not A, I would say 1, 2, and 3 here. So these are just the numeric sequence where 1 is not superior or inferior than 2 and so on. So there is no order, just 1, 2, and 3. So 50 elements are there in group 1, 38 elements are there in group 2, 62 elements are there in group 3. These are all the rows being allocated to every cluster. 150 records are there. That means 150th row is in third cluster, first row is in first cluster, and 30th row is in first cluster, and so on. In all such scenarios, there is one interesting thing which you would find called within SS. Let me get this explained. Within SS, full form of within SS is within the sum of squares. And this within the sum of square, if I will be getting the 3 clusters being created, turns out to be how much? 15 for the first cluster, 23 for the second cluster, and 39 for the last cluster. Within the sum of square is nothing but within the cluster distance, error, square of the error. That means, let's suppose this is one cluster in a round and I have 2 objects. What is the overall distance I have, largest distance in between the group? Ideally, this somehow tells you how homogeneity, what is the component of homogeneity I have in every cluster. So obviously, more the number of clusters are, homogeneity will be higher, and higher the homogeneity, the within the SS will decrease. I am writing that for you. Higher the homogeneity, lesser the within SS. This is like scatterness. This is scatterness. Within SS is scatterness within the cluster, and which translates into the fact that larger the number of clusters, okay, lesser will be, so larger number of clusters, more homogeneous they are. Yes, and that translates into the fact that lesser within SS you should have. Clear? Just read that line number 6 for me before I move forward, because this is the game changer. This line number 9, I am getting the sum as an overall homogeneity being identified. I am showing to you. This is coming out to be 78. This result of 78 is actually nothing but what you have the additional another component which you guys can see called tot within SS. Can you see that? So this tot within SS is nothing but the sum of the overall individual clusters, what you are getting individually from within SS. I will show you right away. So just try to take a look on what the results you are getting in line number 9 and 11. Both of them will be giving you same output as 78.8514. I'm running this and here you go. Can you see that? This is also 78.8514. This is also 78.8514. That means this is nothing but sum of the individual clusters and that's the overall sum. That's all. Now, this unit, what you are getting is actually telling you the overall scatterness when you are having 3 clusters as a whole. Now, I'm doing something for you and make sure that you are understanding what I'm doing. I'm running my piece of code with one cluster and then notifying how the scatterness looks like. With the one cluster, the overall scatterness is 681, which I'm keeping there for you to consider. With only one cluster into the picture, the overall scatterness is very high. Obviously, there would be very different elements if I just have one cluster only. Instead of one cluster, now I'm showing that on two clusters. And when I'm getting that executed with two clusters, now the scatterness comes out to be 152 instead of 681. Clearly, you can see it is decreasing a lot. We don't create that, Ankit. I'm actually getting this continued. I mean, this is overall data, in fact. One cluster is nothing but the overall data set, right? I'm just getting the demonstration on scatterness. The focus area is this scatterness is what the point of the conversation is. Yeah. So you can clearly see that after splitting the data from 1 to 2, you got a very much achievement into the scatterness. When I'm getting that continued from 2 to 3, you can see this comes out to be 78.81547, or whatever the number is, which I was actually having a couple of executions before.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Then again, if I will do that with 4 and so on, I can continue to n number of times, which is now getting 57 actually. So there are some inputs which I would like to get this shared with you or convinced that more the number of clusters I am having, I'm getting the scatterness being decreased, hence homogeneity is improving. Correct or not? You can clearly see from 681 that got reduced to 152, that further got reduced to 78, that got further reduced to 157. So if you are asking me what is the optimal number of cluster, this is what the basic question is, what Arshad is asking for. Okay, let me put that for you. How to determine the optimal number of clusters. Because too many clusters is also not good and too less clusters are also not good. Everyone convinced with this thought? Too many clusters is not good, too less clusters is also not good, because the clusters are too much, then they would start getting similar to each other and you will end up unnecessarily wasting your resources to tackle each one of them individually. And if the clusters are less than required optimally, then there would be disturbance, dissatisfaction among the clients and the customers, because I would not be able to tackle their requirements in a largest appropriate fashion. Correct, everyone? So I just have to find the optimal number of clusters. And in order to search for the optimal number of clusters, I will be then taking the help of the statistical inputs, what I am now trying to explain to you guys. In this demonstration, I have been running the model starting from one cluster, then two, then three, then four, for a potential reason to get you familiar with the results manually. But if I have to get this demonstrated in a decent fashion, there is something called elbow-like chart. This is the fundamental way for me to get to know what is the optimal number of clusters. To find the optimal relevant number of clusters, the answer lies is like elbow chart. What is elbow chart is what you are going to describe and determine. If you look into the code, instead of running the code manually, what I was doing, changing the cluster from 1, then 2, then 3, then 4, I have been simply getting a for loop. I hope everyone knows the relevance and the significance of having a loop based on the perspective I developed at the time I was discussing the loops with you. Do you remember that? When something needs to be done iteratively, repetitively, n number of times, then you would be using the range loop. And this time I am trying to get something being done 10 times starting from 1 to 10. And for that, what I'm doing is running the model with the clusters ranging from 1 to 10 and getting their scatterness being recorded into a bucket in R, which is called as vector. In Python, the very same thing is nothing but a list. So like the way in Python you have a list is what now you have a vector in R. Clear? So don't get lost. So for that reason now, I am now storing all of these scatterness one after the another in this empty bucket called cluster or class, and then plotting a chart, a line chart, with the index of 1 to 10 on x-axis and the values of scatterness on the y-axis. Simple. Let me get this triggered. Let's get an error. What that error is. This is fine. I don't think we have to have an additional one. Yeah, extra bracket was there. That is the reason it was showing me an error. Okay, let's execute it now. Now you can see I got something developed here. And this chart is actually a elbow looking chart, elbow like chart, just like the way you have an elbow in your body part. The way how we can conclude this elbow is, or interpret this chart is, wherever there is a sudden flatness, from this to this, you can see there is a sudden drop. But from this dot onwards, this is getting flattened. Yes or no? This concludes one thing, that if you relate the idea with the points I was discussing, creating the number of cluster or increasing the number of cluster from 1. You remember the first cluster was having the scattern of 681, guys? Do you remember that? So this is nothing but a dot is coming on 681 on the scale you can see. So 681 as a scatterners got reduced to just 152 when you got that increase from 1 to 2 cluster, and that further got reduced to 78 when you got increased from 2 to 3. But after the 3 cluster, even though you are increasing the cluster, you are somehow getting the flatness, and this flatness in the scatterness, this is nothing but scatterness, right? This flatness in the scatterness means and translates into the idea that, boss, even though you are increasing the number of clusters, but there is no improvement as such in the bifurcation, in the homogeneity aspect of the data. So there is no point for me to unnecessarily get the load being extended. So I should be now having the number of clusters being 3 here optimally. So this is what the idea is. Am I clear? So this comes to a fact that wherever the elbow turn comes into the picture, in my case it is 3. This tells me that was 3 is the optimal number of clusters. Statistically, business can say that was you have to get 4 clusters or 2 clusters only. That's a separate thing, because business always overrides the mathematical rules what you have. But at the end of the day, this is what the basic bottom line is. Am I clear now? Let me get this discuss how the k-means works. Okay. Let us now discuss how the k-means algorithm works. Though you are not required to get this manually done, but I am telling you how this works behind the curtains, back end. I'm dropping the 2-dimensional or n-dimensional chart just so. Let us now try to explore the idea how the k-means works. And to do so, I am getting some data points being generated and reflected on the n-dimensional space. It could have been any number, okay? Just as an assumption I'm sharing with you. Keeping it simple for you. The moment you will trigger the algorithm by passing any value of k, like in our case, I can consume it to be 3 as an example I am sharing. Let us suppose you are running the algorithm by value of k being 3. That means you wanted to have 3 clusters to be there for the data to be splitted. The moment you will trigger the algorithm with the k number of clusters, be it 2 or 3, that many same centroids or nucleus will be randomly dropped, like the way I am showing to you. Okay, randomly. It could have been at any place initially. So the moment you will run the algorithm, you will get 3 nucleus or centroids, which is actually the epicenter of the clusters getting started creating around them. Based on the homogeneity and heterogeneity, they will be then shifting onwards. How come? I will be explaining you. Just assume that you are somehow trying to get, this object to be identified in which cluster it should ideally fall or counted in. So what the process will start getting to continue is that the distance of this sample will be manually started after finding and doing the comparisons and everything. Whichever the closest distance this is somehow considering, like in my example, currently this falls very closer to green color. Hence, this will then be counted under the green cluster or green group as this. So this is how the clusters are getting generated, evolved, and shifted. How come? Now because this is a group, so a new centroid position will be redeveloped at a average value, mean position, mean distance. I'm showing you with the striped color. This is actually the new position which is at the mean value, mean distance value of these two clusters. And what does that means? When you are actually getting anything, any new object to be calculated, like if you are calculating this one, in which group it should fall. So the distance of this will be counted from this, obviously, from this, obviously. Okay, let me change the color using the orange one, okay? And now from this at an average mean value. Am I clear? Because it's a two-dimensional demonstration, complete pictorial flow. Reason being, this comes more reasonable and lucid when you are actually watching the videos. Reason what is interesting is that I would also like you to understand one aspect which I can't really explain it right now, considering the fact that we are going into a 2D description. The object which have been earlier, let us suppose, I'm talking about this, just by any reason, okay? Just assume that. Kindly don't feel like saying that, Ankur, this seems more closer to blue, why it is now in green. Don't say that, but just feel about that, okay? There might be a possibility if an object has been earlier allocated to a green cluster after the reshuffling of the group, this can be later on consumed to be into the blue group. So shuffling and the readjustment of the elements also happens because of the homogeneity and heterogeneity and the further fine-tuning and alignment of the cluster. And that is the reason every now and then, every time you are running the cluster, you would be getting the best cluster in a way that each cluster is homogeneous and heterogeneous based on the proximity. Am I clear now? Because their centroid is getting shifted. Is the reason you can have this, because this will keep on getting the changing, right? So based on that, earlier it might be there into the green color, but later on it could be there into the blue group as well. Sorry for that. Yeah. So I would strongly suggest you guys to kindly please take a look into the complete way and the pictorial flow of how this k-means work. But this is what the idea is. I think I very well explained you what that k and what that means in the data. Means average value. I hope this is clear now. What does that algorithm means? Because you are actually operating on the average distance of the value every time. So this is what the fundamental idea is behind the what, why, and how. I am getting started with Jupyter Notebook, and within that, I have a case study there with me with the name called K-means mall customer data. In this data, I have the details of the customers in my mall with their gender, age, annual spending, and income, spending scores. Like in India, we have the credit card score and so on, based on which you have the spending score. So on the scale of 1 to 100, higher the score is, better he is good in spending. Lesser the score is, poorer they are in their spending habits or traits. Considering this data, I am now doing some sort of clustering so that I can see how the data looks like after the clusters are being created. So for that sake, I got this exercise being generated. I will walk you through with each and every single piece and the line of the code there. This file has been properly documented for your further understanding and reference. Like k-means clustering only works with the numeric variables, which is actually a distance-based algorithm. Euclidean distance is the formula runs behind that. So categorical variables at least would not be working in a direct fashion when you are just using the k-means. For getting the categorical variable being enrolled, there are some different methodologies. K-mod is there as an approach. Rather than taking the mean, you are taking the mod. And in this case, because it is unsupervised learning, is a part of the umbrella of unsupervised learning, hence there is no such a targeted y variable to be achieved. Let us now get started. In starting and in the beginning, I am getting the required libraries being imported, that is NumPy, Pandas, and Matplotlib. K-means is the algorithm which comes from a module called cluster under the package of sklearn, which is what you are going to have into the place. Immediately after that, I am getting the mall customer CSV file data being imported into an object called dataset, which is my data frame here. For the sake of our easy understanding, I am just getting continued with only two columns, which is like income and spending scores, excluding rest of the other ones, just to make it more deliberate approach. I'm getting this name of an object called X. It could have been anything. You must also be getting lost and confused why it is X when there is no Y. So don't kindly feel that why it is X. So it is just a name of an object I have been given. Technically, there is no y, so there is no such a significance here with the name called x. But I'm subsetting my original data for these two only columns to be continued. In this case study, I have been properly aware with the complexity of the data, that there is no missing values, problem of outliers, and so on. Hence, I really need not to get into the trouble of EDA, cleaning, and preparing. But I have written a comment like, if it would have been a new data being exposed, you have to have a proper steps being taken up to understand the data and then to clean it accordingly as part of your usual game in any of the engagement. Then this is way how you are getting started with the game means clustering, because clustering, getting the clusters being created has never been a challenge. This is number of cluster being 3. You can down the line also be looking at the optimal number of clusters with the elbow like chart as well. So a couple of the interesting things for you. I got this model and fitting that on the X data. So this is where the model is literally getting built. Plus, after getting this model being built and trained on this data, or executed on this data, applied on this data, you are finding something called inertia in Python. My dear friends, this inertia as a keyword is actually the very same idea and the keyword corresponding to what you have within SS in R. Do you remember that? A measurement of scatterness. So in Python, the only difference is like you have a different keyword, which is like in inertia now, whereas in R, the same thing was being called as within SS. So hence, there is no difference in the concept, but the terminologies are only getting changed. Plus, if you will find and look into the details of this code, where I am finding the optimal number of clusters with the elbow-like chart once again, you will find very much similarities of this code, how it is getting worked there as compared to what you were getting or doing there in R. Similar, exactly similar, or almost similar. Let me show you. Here you are getting the empty vector in R being created so that you can store the various scatterness values, but in Python, you are now getting the empty list being created. Can you see that? So whatever exactly I'm doing that in line number 31 here of my R code is what literally I have that being done in this piece. Here also I'm getting started with the range for loop from 1 to 10 because last element is excluded. Running the k-means, and then this is nothing but getting that added into the list with the within SS inertia. What you were calling that as within SS is now being called as inertia. Simply plotting that and labeling that, which will end up giving you this piece of layout. When you will look into the code, in this piece, you have been getting this type of elbow-like chart, which is probably getting flattened from this point onwards. So I can assume that 5 are an optimal number of clusters. And based on that input, later on I started working that with the number of clusters being 5. So this is what the input is. First level due diligence being done. Let me show you what I'm trying to convey. So this is one thing. And when you will look into the k-means as a bottom, then k. So there would be one of the variables which is actually asking for the threads here, initial threads and so on and so forth. So try to read more about that and try to fix one of such variables which is handling the threads here. Thread means parallel computing. While getting the clusters being created, how many parallel computations are being taken up. This is all what it comes across. Am I clear? Threads. Can you see this? Put it -1 there. This has been deprecated actually. And jobs and will be removed. So try to fix this. So yes, that is also correct. I also missed that.
In today's session, we'll be talking about some common machine learning algorithms. Okay, so let's dive in. Okay, so we will be discussing some popular algorithms that are useful for machine learning purposes. So basically, as you can see here in machine learning, we are having two kinds of learning. Okay, the first one is the supervised learning, and the second one is the unsupervised learning. So what does supervised and unsupervised means? As the name suggests, supervised learning means that we are supervising our model. Okay, we are training our model on top of some data set. Okay, and after training our model, then we will try to predict, we will try to test our model. Okay, and we will see if our model is able to predict the future outcome or not. Okay, and if you talk about the unsupervised learning, so in unsupervised learning, we, as the name suggests, unsupervised means we will not supervise our model, we will not train our model. The model will get to know about the data set itself only. Okay, if you basically here we don't provide any learning to the model, to the machine. Okay, we will just provide a data set to the model, and after providing the data set, the machine, with the help of some algorithms, it can able to understand what the data set is trying to say. Okay, basically we will be analyzing the data. Okay, so let's discuss supervised and unsupervised in detail. So first, let's talk about the supervised algorithm. Okay, so in supervised algorithm, the first set of algorithm that we will talk about here is linear regression. Okay, so what is linear regression? See, basically in supervised algorithm, we are having two kinds of problem. The first problem is the regression problem. Okay, the second one is the classification problem. So what is regression and classification? If you talk about the regression problem, then regression basically deals with some kind of, you can say, continuous set of data. Okay, let's take an example here. If you're having some data set, okay, and in that data set, you are having some like a list of houses, okay, and then I want to predict what is the retail price of those houses. Okay, so the price, there will be a continuous set of numeric values only. Okay, so here we are talking about some regression problem, because we have to predict some numeric value, okay, of those houses. So that is why that problem come under the linear regression problem. Okay, so here we will talk about like we have to predict some value. Okay, some value that is not categorical. Okay, categorical means like if you're having some yes or no kind of value in your data set. Okay, let's suppose let's take an example. If you talk about some like if that particular customer is churning out of any company or not. Okay, so this is kind of a categorical set of values. Okay, but here in this linear regression problem, we will only deal with the uh, exact values. Okay, the salary of any person, or you can say the price of the houses. Okay, so this is what we talk about in linear regression. Only like they are having continuous set of values we have to predict. Okay, now if we talk about the other algorithm, that is the logistic regression. So as the name is have the logistic regression is having the name as regression, but in logistics we always work with classification data. Okay, the regression name is only present in the logistics part, but we always work with the classification problem. So what is classification here? Let's take same data set only. Okay, the data set that is having list of houses. So in logistic regression, we will try see, there will be some retailed price of that particular house. Okay, let's suppose there is a house and that house is having a retail price as $10,000. Okay, so if with the help of logistic regression, we can calculate, or you can say the model can predict that that particular value, that particular house has been sold at a higher price or the lower price. Okay, if you talk that particular house is there. Okay, let's say house number 1 is there. Okay, and in house number 1, you want to like I want to predict, okay, that particular house has been sold at a higher price or a lower price. Okay, so this is what a categorical value is there. Okay, if it is sold at a higher price or a lower price. If you take another example, let's take heart disease data set. Okay, we are having heart disease. So there are many set of customers, many set of patients, the values, the data sets that is having all the value of the customers. Okay, so uh, for that data set, for the heart disease data set, we have to predict, okay, if I'm having these kinds of symptoms, then that particular customer is having heart disease or not. So this is also a kind of classification problem. Okay, because we have to calculate that either that particular customer is having heart disease or not. So this is a categorical value. Okay, so this is what we talk about in logistic regression. We always talk about the classification problem. Okay, that is the categorical values. Then again, our next set of algorithm in supervised algorithm is decision tree. Okay, so if we talk about decision tree, so as you can say, the decision tree means we will be talking about some tree structure here. Okay, So basically, a decision tree is also a kind of, in decision tree, we can work with classification problem also and regression problem also. Okay, if we want to calculate exact value, or we have to calculate the categorical value, that either that particular customer is having heart disease or not. Okay, so these things we can calculate in decision tree. So let's take an example for explaining the decision tree. So let's suppose there is a bank, okay, and that bank, like I want to build a decision tree so that how my model can able to like there are some customers that want to have their loan approval. Okay, so I want to build a model so that my model can able to analyze, okay, if this particular customer is coming to me and that particular customer wants to have a loan, okay, so if I give loan or not to that particular customer. Okay, so it will build a decision tree. Okay, like it will see their past loan credentials. Okay, it will see, okay, that particular customer has paid the previous amount of loan or not. Okay, if he has paid, then okay, I will go to the yes part. Okay, I will go to the yes part, and then it will see, okay, if I'm having higher loan or lower loan. Okay, higher means like if that particular customer wants higher amount of loan or lower amount of loan. If yes, if that particular customer is having higher amount of loan, then it will not give the loan. If the particular customer is having lower amount of loan, then it will give the loan. Okay, so this is what decision tree is. It will make some decisions regarding the past history of the data. Okay, it will see the past data of those customers. Okay, so this is what our decision tree is. Then if we talk about our fourth algorithm, that is the random forest. So again, in the random forest, I'm having multiple sets of decision tree. Okay, so if we talk about the random forest, so basically random forest combines the output of multiple randomly generated decision trees. Okay, and it will give our final output. So basically, random forest is a group of decision trees. Okay, in decision tree, we will only build one tree only. But in random forest, we can make 100 trees or 300 trees or 400 trees. And with the help of all those trees, with the help of the combination of all those trees, we can able to predict, okay, if I want to give that particular customer a loan or not. Okay, so this is what our random forest is. If we talk about our naive Bayes, so basically guys, in naive Bayes, we will be dealing with some kind of like you can say data set that is having we can say okay, so if we talk about the naive Bayes, so in naive Bayes is also a kind of the classification problem. Okay, so naive Bayes basically deals with some probabilistic classifiers. Okay, so if I want to you can say talk about, basically in naive Bayes we deals with some text classifiers. Okay, we will deal with some text kind of data. Okay, here in the linear regression, logistic regression, if you talk about decision tree and random forest, we work with some kind of data frames. Okay, but in naive classifier we always work with some kind of text categorization. Okay, we are having some text kind of data. You can take all those texts in Excel format, and you can work with that data set, and you can able to predict your the whatever task you are having in your text data. Okay, so these are all kinds of common algorithms that we use in supervised learning. Okay,
the problem statement. So the problem statement is here. Your client is a large MNC and they have 9 broad verticals across the organization. So one of the problems your client is facing is around identifying the right people for promotion and prepare them in time. So it is only for manager position and below. So currently the process that they are following is, first one, they first identify a set of employees based on recommendations and past performance. Then the selected employees go through the separate training and evaluation program for each vertical. These programs are based on the required skill of each vertical. Then at the end of the program, based on various factors such as training performance, KPI completion, employees gets promotion. So talking about the KPI completion, so only employees with KPIs completed greater than 60% are considered. Now this is the actual problem statement. Now let us look at the scenario that is provided by the company. So the final promotions are only announced after the evaluation, and this leads to delay in transition to their new roles. Hence, the company needs your help in identifying the eligible candidates at a particular checkpoint so that they can expedite the entire promotion cycle and they can speed up the process actually. So the first thing is they have provided multiple attributes around employees' past and current performance along with demographics. Then they have provided multiple attributes around employees' past and current performance. Now the next and the second point is the task that we have is to predict whether a potential promote at checkpoint in the task set will be promoted or not after the evaluation process. Now this is what we have to do, and moving ahead, let's understand the data set and the parameters. So let me go to the training and the testing data set. Now this is our training set and this is our test set. So now let me go to the training set, and this is the employee ID. So we are not much concerned about the employee ID, so it will not actually help us in the prediction. This is the department section, including sales and marketing, operations, then technology, analytics, operations, sales and technology, again technology, then research and development, then there is finance, procurement, and so on. There is also a department called HR, and the next one is region. So this is region 7, region 22, region 19, and there are many regions. So region will actually not help us to predict the outcome of the model that we have to build. Then comes education. So education can be the factor for predicting the promotion. So the list of education that is provided over here is masters and above and bachelors. So also here the empty data is there, which means that there is no data provided over here. So we will deal with the missing values also. And then comes the gender. So the gender is male and female. After that comes the recruitment channel, that is sourcing and other.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. Just a quick info guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
Then comes the number of trainings. So that is 1, 2, and we'll scroll down. It includes 3, the number of training that are provided to the individuals or the employee. Then the next thing is the age. So this is the age of the employee. Then comes the previous year rating. So this can be one of the most important factor in the promotion. So the previous year rating is 5, 3, 1, 3, and so on. And this position or this, so this is 3-star, 4-star, and this is empty. So it denotes that the employee is not at all having a rating. So it can be because the employee may be a fresher. So let's check out the length of service. So here the length of service is 1. So that is why the previous year rating is not shown over here. So we'll sort out this thing also for making the model more accurate. Then comes KPI metrics, that is key performance indicator. So it denotes and it indicates the metrics for the performance of the employee. So 0 over here denotes that the performance is not at all good for giving them promotion, and 1 indicates that the performance is decent enough to give the promotion. Then comes awards 1. So this is 0, 0, 0, and here it is 1. So award 1 is 1 over here for a particular employee whose ID is 77981. And now average training score. So this is the training score of an employee while pursuing a training for the company. Here it is 85, 73, starting from 49, 60, 50, and so on. So it can be a major factor for predicting the promotion for the employees, that is how well they perform in the training and what is their score in the training. Then comes is promoted. So 0 means that they are not promoted and 1 means that they are promoted. So in this data where the promoted thing is 1, so this is the average training score, and here this shows the KPI metrics, that is also 1. Then the next one is the length of service, that is 6 years, and so on. So these are the parameters and the data set on which we'll be working on for making an AI model to resolve the business problem. Now let me go to the training set. So this is the training set, and it consists of, let me go to this part. Okay, so this also consists of employee ID, then department, region, education, gender, recruitment, number of trainings, age, previous year rating, then comes length of service, KPI metrics, awards won, and then average training score. So these are the parameters over here. So we have divided the data set into train and test set so that we can train the model using the train set, and we can test the model using a separate data set, that is HR_test. Now the reason for using the test and the train data for the model is that we do not want our model to overfit the data. So in future it may get different sets of data and it may face issues in giving accurate results because the model is overfitting the data set that it is having. That is why we are using a separate data for training the model and a separate test data for testing the model. Now we have understood the data, that is trained data and the test data. Now let us move on to the steps that we'll see further. So the next step that we'll be going through is pre-processing and feature engineering. So in this we'll pre-process the data with using the different types of pre-processing. That is, we will manipulate the data, we will remove the null values and the missing values from the data set, and before that we'll use various and we will import various types of packages that are required for the implementation, and we'll see the info of the train and the test data set as well as the description such as the standard deviation, the mean and the average of the values. Then we'll perform feature engineering for the model and for the dataset values. Then we'll build the model using various algorithms that are used to build AI based applications, and we'll apply feature scaling so that all the values comes in the common slot and the prediction becomes more. And finally we'll evaluate the model that is created using various parameters and metrics of model evaluation, and then we'll visualize it using models visualization. So further, let's go to Google Colab for the implementation part. Now this is our Google Colab. So first thing you have to do is just go to this folder option, click on this upload session storage button and upload the training and the testing dataset. So I have already uploaded it, so I'll just show you. So I'll scroll down and here is the data, that is train and test data that I'll be using. So whenever you open Google Colab, so the first thing you have to do is you have to load the dataset. Otherwise you cannot work with Google Colab and create algorithms and AI based applications. So also one thing more, if you load the dataset now, so it is for this instance on which you are working. If you will close the tab, then the dataset will be deleted. So again and again you have to load the dataset. Now I have written the code over here, the entire code. So I'll implement and I'll explain every code, what it is actually built for and how it is working. So first I'll import warnings and use this warnings.filter warnings ignore. So this is used to ignore the warnings that are displayed by the interface or by the Python library while implementing the program. So I'll run this, and now you can see it has been successfully executed. Now the next thing is the scientific and data manipulation libraries. So I have imported pandas, I have imported numpy, then import math, gc, os, and the sklearn package. So we use pandas basically for data analysis and data manipulation, and it provides various features for the analysis of data. Then comes numpy, so we can work with multi-dimensional data and matrix arrays using the numpy library. Then comes importing of maths that help us to implement various mathematical operations. After that, import gc for the garbage collection, and then importing os so that the packages and libraries are imported so that the application which we are building using the various modules and libraries of Python, so it gets added according to the operating system. Then importing scikit-learn, that is sklearn. So scikit-learn basically help us to implement classification, regression, dimensionality reduction, and many other machine learning algorithms we can implement using the sklearn or scikit-learn library. So I'll run this, and now the installation of the scikit-learn is done. So I have already done. It may take a while for you to get this. So I'll run this pip install scikit-learn to install the scikit-learn library. So it will take a while and it will get loaded. So these are the basic steps that you need to implement before data pre-processing. So these libraries and packages are the first thing that you have to load and install or download for working further with the data pre-processing task or creating algorithms. Then comes more libraries. So in sklearn, we have pre-processing, model selection, tree, ensemble, and metrics. So from sklearn library, we import the packages for pre-processing and model selection, tree, ensemble, and metrics. So why we do that? Because we have to use label encoder, one hot encoder. We want to use min max scaler, normalizer, robust scaler. Then comes max absolute scaler, and then we use model selection thing for using k-fold, stratified k-fold, train test split, then cross validation score. After that comes the tree package, for which we have to use decision tree classifier, random forest classifier, and then voting classifier using the ensemble package of sklearn library. Then comes the metrics package of the scikit-learn library, using which we'll evaluate, or first we'll load F1 score, then confusion matrix and classification reports that help us to implement the functions for F1 score, calculating confusion matrix for accuracy, and the classification report. So we'll use this from sklearn.preprocessing, import standard scaler, min-max scaler, normalizer, robust scaler, and for loading all these modules from the library, we'll use these commands. So let me run this. So it shows that it is successfully executed. So before moving ahead, let me explain you the standard scaler, min max scaler, so all these, why we are actually using it. So starting with standard scaler, it actually removes the mean and scales each feature or variable to unit variance, and this operation is performed feature wise in an independent way. So standard scaler can be influenced by outliers, so the values lying beyond the common slot of area where the actual values are lying, so it can be influenced by the outliers, and it involves the estimation of the empirical mean and the standard deviation of each feature. So it scales it, so it helps the model to predict in a better way. Then comes min max scaler. So min max scaler rescales the data set such that all the feature values are in the same range from 0 to 1. So actually there are too many values and it can have different values from 1 to any of the value. So we need to rescale the value in a common slot such that we can create a plot out of it and gets a better visualization. So min-max scaler helps in this way. After that comes the normalizer. So the normalizer rescales the vector for each samples to have unit norm independently of the distribution of the samples. Now then comes the robust scaler. So unlike all the other scalars, the centering and scaling statistics of this scalar are based on percentiles, and therefore they are not influenced by a few number of very large marginal outliers. Then consequently the resulting range of the transformed feature values is larger than for the previous scalars, and one of the most important thing to note is that they are approximately similar, and for both features and for most of the transformed values they actually lie in a range of -2 to 3. Now coming to max ABS scalar, so it differs from other scalars and such that the absolute values that are mapped, they are in the range of 0 to 1. So they are the absolute values, and on the positive data the scalar behaves similar to min-max scalar, and therefore it can suffer from the presence of large outliers. Then comes the voting classifier. So the logic behind the voting classifier is creating a separate dedicated model and finding the accuracy for each one of them. So we actually create a single model that is trained by the other models and predicts the output based on their combined majority of voting for each output class. So that is the logic behind the voting classifier, and we'll use this voting classifier for our project. So I hope the importing of the libraries and packages is clear. Now we'll move ahead and we'll import class and we'll install the cat boost. So I'll click on it. So you have to use this command pip3 install cat boost, as we'll be using the boosting algorithms such as xgboost, lightgbm and cat boost for preparing our model. So it will just take a while to load, and I have already loaded this and I have downloaded the packages related to cat boost. That is why it is showing requirement already satisfied. Then I'll import the xgboost and use an attribute that is xgb for it. Then lightgbm and then cat boost. So I'll click on it and it is successfully executed. So why do we actually use XGBoost, LightGBM and CatBoost? So XGBoost is a scalable and accurate implementation of gradient boosting machines, and it has proven to push the limits of computing power for boosted trees that are used for implementing the algorithms for the sole purpose of checking the model's performance and improving the model's performance and the computational speed. So that is why we use XGBoost. So also XGBoost is used for supervised learning problems where we use the training data to predict a target variable. So that is why XGBoost is used for building the AI models. Then coming to LightGBM, that is a gradient boosting framework that uses tree-based algorithms, and it is designed to be distributed and efficient with the following advantages, that is faster training speed and higher efficiency. Also, it has support of parallel and GPU learning capable of handling large-scale data. So that is why LightGBM is used as a classifier. Then coming to cat boost algorithm, so it is an algorithm for gradient boosting on decision trees. So it is basically used for search, recommendation systems, personal assistant, self-driving cars, weather prediction, and many other such tasks. So one of the major benefit of using cat boost is it can handle missing values internally. Also, by default, cat boost uses one hot encoding for categorical features with a small amount of different values in most of the modes that we use. And so coming to one hot encoding, we use it for all the categorical features with a number of different values less than or equal to the given parameter value in a specific range. So we'll use all these algorithms for our AI project for building our model, and I hope you are clear with the algorithms that we are using. So let me run this and you can see it is being successfully executed. Now I'll run this. That is from XGBoost we are importing XGBoost classifier. So it is also successfully loaded. Now comes the data visualization libraries. So we will use matplotlib, seaborn and plotly package for the data visualization. So I'll run this. Okay. Now comes the randomness of the data that is being selected. So we'll use np.random.seed. So it is actually used to save the state of a random function so that it can generate same random numbers on multiple execution of the code on the same machine, or it can be on different machine. So the seed value is the previous value number generated by the generator. So that is why we'll use this np.random.seed. After that, we have to set the location path from where we'll use the dataset. So we have already loaded the dataset, and you have to do it again and again for the Google Colab if you are using Google Colab. So now I have already imported OS. So it is just written over here from Google Colab, import files, then train pd.read.csv is used to load the dataset. I'll run this and let us see. Okay, so it is being successfully executed. Now we'll display the dataset of train and test. So we use this display function to display the values. So I'll run this and it will display the training values and the testing values. So let me scroll down. So the first one is training value and the second one is the test values. The second one are the test values. So this shows the index. Now employee ID, department, region, education, gender, recruitment channel, then number of trainings, age, previous year training, length of service, KPI metrics that is greater than 80, and awards 1, average training score, and is promoted. So as we have already discussed the training dataset, and the KPI metrics should be greater than 80% to get the promotion. So here it is. Now let us check out the test dataset. So again, these are the index, employee ID, department, region, education, and it will not have the is promoted column because this is the testing dataset. That is, these are the independent variables using which we have to predict whether the person has to be promoted or not. That is the variable is promoted. Now further, let me go to the exploratory data analysis that we have to perform. So for this, first we have to look into the information of the training set. So for this, we'll use train.info to display the information of the trained data. So let me implement this. And now we get the training data, along with it includes the non-null count and the data type. Also the count of the types of data type, that is float 64 is 1 time for the corresponding column, and it is previous year rating, and integer is 8 times and the object is 5 times. Also it shows the memory usage, that is over here it is 5.9 plus MB. So this shows the information related to train set, and then let me display the information related to the test data. So here it shows that there are 23,490 entries starting from 0 to 23489, and data columns total there are 13 columns, and non-null count along with data type and the count of data type over here, and the memory usage is 2.3 plus MB. So this is the information regarding the test and the training data. Then comes displaying the descriptive statistics of train data. So just talking about exploratory data analysis, so it is a part of the data pre-processing where we actually gather the information related to the data. So we check the info, we check the description of the data such as the average, the maximum and the minimum values, along with the mean or the standard deviation, the type of data, memory usage, and the non-null count, and many other factors. So we look into that in this data pre-processing step, or you can say the EDA, that is exploratory data analysis. So let me run this. train.describe. So it shows more information related to the training dataset. So it shows the count, it shows the mean for all of these columns. Then comes the minimum value, maximum value, and the interquartile range. Now let me check the description about the test data. So I'll run this, that is test.describe. Again, it shows the count, the mean, the standard deviation, minimum and the maximum value, and the IQR, that is interquartile range. So this shows us the description of the train and the test data.
Okay guys, a quick info: if you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below. Let's continue with this session.
Now further we'll display the number of unique values and the actual values. So we have to first define a function, def for defining the function, that is display unique, and it will take the argument as data. So here we have passed the argument of train data. So display unique, we have called the function. Now what does this function do? So for column in data dot column, that access the columns present in the data set. So we have to print the number of unique values in the column, that is the column corresponding to the trained data set that we are accessing to. Then the columns are then using the str function data, then column dot n unique. It will fetch the unique values from the data set or from the column. Then the actual unique values in column. So again, now further to get the actual values, so here we use again the str function and then the sort values function that sorts the data in the ascending order, because the ascending is set true over here. So for getting the actual values, we have to use this sort underscore values function, and this na underscore position takes two strings, input last or first, to set the position of null values, and accessing this unique function gives the unique values from the data set. So it shows the number of unique values simply, and using the sort values function we can access the actual values in the column. So let me execute this, and now here we get the output. So number of unique values in employee ID are 54,808. So starting from 1 and it goes till this index. So these are the actual values, and then comes the number of values or unique values in department column, that are 9. But the actual unique values in the department column are analytics, finance, HR, legal, operation, procurement, R&D, sales and marketing, and technology. So the actual values are shown over here. So these are the actual values. So this is how we actually access the actual values using the sort underscore values, and we can keep descending also over here, but we have kept ascending order. So these are the actual and the unique values for all of the columns of the train data set. So we can check it for test, but we'll leave it for now. And now we'll move on to displaying how each feature is related to the target variable in a flow. So for this we will use a plot using the parallel categories diagram. So the parallel categories diagram actually it is also known as parallel sets, and it is a diagram, or you can say a visualization of multidimensional categorical data sets, and each variable in the data set is represented by the column of rectangles, where each rectangle corresponds to discrete value taken by that variable. So here we pass in the columns. So the columns are department, education, gender, previous year rating, KPI, metrics, then recruitment channel, and is promoted, and color is based on the is promoted column. Then we use the continuous color scale. So using this sequential.agrenil, so we plot the figure using multiple colors. So this figure.show help us to show the figure. Now let me implement this and let us have a glance at the figure that we get. So it will just take a while to load. Till then you can just wait. Okay, this is the figure that we had. So this figure is very descriptive and it shows you the data. So let me show you how you can actually read this figure and how actually you can understand the various dependent or independent variables from this figure. So there are columns named department, then education, gender, previous year rating, KPI metrics, recruitment channel, is promoted. So is promoted is shown over here. So it consists of the value as 0 to 1. So hence its scale is from 0 to 1. And then comes the individual categories of the columns. So in department, there are multiple departments such as sales and marketing, operations. So this section is the operations one. So you can see when I have kept my pointer over here, so it shows the relation, actually the data relation from other columns such as education, gender, previous year rating, KPI metrics, recruitment channel, and is promoted.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
So the count it shows is 11,348. That is, there are 11,348 employees for the operations department. When I kept my mouse pointer for sales and marketing, it shows the count as 16,840. And then comes the count of this sales and marketing, and then technology. So the count is, let me click on this. So the count is, you can see over here. So this shows the count as 7138. Then comes analytics, that is 5352, R&D, which is the least, and then procurement, finance, HR, and legal. Now coming to education. So when I kept the pointer over here, so it shows the count for the masters and above degree as 14,925. So here the category is written over here. Then when I came to this bachelor's, it shows the count as 36,669. Then coming to below secondary, it is 2409. And then the final one is the below secondary one, and this, so this last one is the below secondary one, that is 805. Now coming to gender, then the count is 16,312, and the count for the male employees is 38,496. Now previous year rating starting from 5. So the employee who are having the rating as 5 are 11,741. Then 3, rating of 3 is 18,618 employees are having a rating of 3. Then 1, it is 6223. Then rating of 4 is of 9877 employees. After that, the rating of 2 is 4225. Now the KPI metrics greater than 80. So for 1, that is the metric, KPI metrics is greater than 80, the count is 19,291. And for the employees for whom the KPI metric is less than 80% are 35,517. Now again, the recruitment channel is sourcing, other, and referred. So for sourcing, it is, the count is 23,220. Then for others, the count is 30,446. Then for the referred one, it is 1142. That is the least. Now I'll come to the is underscore promoted column. So the count it gave it gives is 50,140 people are not promoted, that is the value is 0, and the promoted people's count is 4668. So you can see over here the structure of the figure. Now for the next one we will have a heat map. So we will display the correlation between the features through heat map, and lighter color higher correlation, and if close to 1. So lighter color shows the high correlation. So for this we use sns.heatmap, and as we are making the heat map for the train dataset, so we'll use this train.corr for correlation, and this annotation or annotate is true. So I'll run this and we'll get the heat map. So here are the employee ID. So these are the columns: employee ID, number of training, age, previous year rating, length of service, KPI metrics greater than 80%, awards won, and then average training score is promoted. And this scale shows the is promoted thing starting from 0 and 1. So the values are only 0 and 1. Now the x-axis of the figure, so it is not actually x-axis, but it is the other side of this figure. So it has again employee ID, number of trainings, age, and previous year rating, length of service, KPI metrics, then awards won, and average training score, and is promoted. So a heat map is a two-dimensional graphical representation of data where the individual values that are contained in a matrix are represented as colors. And the Seaborn library, we have imported it for this purpose, and the Seaborn Python package allows the creation of annotated heat maps, and which can be tweaked using the matplotlib tool as per the creator's requirement.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
So we are creating this for the correlation, finding the correlation. So this color shows us the correlation between all these parameters that we are evaluating. So this is the heat map that shows the people who are promoted, or not the people who are promoted, but the correlation between these columns. Now let me go to the next part, which is finding the duplicate rows from the trained data if it is present. So we have to check for duplicate rows to remove them. So we will create a method that is remove duplicates that will have an argument of data. So in this we'll print before moving or before removing duplicates the number of rows, comma data dot shape. We'll give the argument as data dot shape. Then we have to implement the logic or the action, that is data dot drop duplicates. To drop the duplicates, keep equal to first in place equal to true, and then again we have to print after removing duplicates the number of rows. So again the argument is data dot shape. So actually this data dot shape returns the data in the form of array, and then we'll return the check duplicates. And now I'll just implement this, run this, and now I'll call the remove underscore duplicate and give the data or the argument as train. And now I'll click on this. Further, after the successful execution of the code, we'll get this: before removing duplicates the number of rows are 54,808, and after removing the duplicates the number of rows are again 54,808. Now it will return the checked duplicates. After that we'll handle the missing values. So remember that still we are in the data pre-processing or the manipulation part. So we have to deal with the missing values. So missing values are present in the previous year rating and education columns in both train and the test data. So here I have just written for the reference why is data missing in column previous year rating. So data was not entered because those employees were fresher. So as I have already told you when we were discussing and when I explained you about the data set, so data was not entered because those employees were freshers, that is length of service is 1 is equal to 1 and they did not have the previous year rating. So the no data would have been there in the data source itself for these employees. So logically we are imputing with 0 as freshers with 1 year experience and may not have previous year rating at all. So filling the missing values in train and test data. So what we'll do is we'll use this train data set and the test data set, and in this bracket we'll give the column name, that is previous year rating, and what we'll do is again to access the previous year rating, so we are actually accessing the previous year rating and then we'll use this dot fill na with 0, so it will fill those values with the 0. So the next thing is we'll access the column of fresher for the train data set and then we'll use this previous year rating and apply function, and then we'll use this lambda. So here we'll put the condition, so if x is equal to 0 is equal to 0, then the employee will be a fresher, otherwise the employee is an experienced professional. After that we'll display the fresher column with the value counts and again the previous year rating, length of service and this fresher tag that we have used using the condition that is applied over here for marking the tag as a fresher. Again we'll use this display function to display this previous year rating, length of service, then fresher for the first 25 values and for this we'll use this head function. Now I'll run this and here we get the output. So these are the columns and they are replaced by values as 0, 1 fresher. So this is the fresher column and this is the fresher tag that we have displayed using the display function and putting the condition over here. So the experienced professionals are 50,684 and the freshers are 4,124 and the data type is integer again. So we have used the previous year rating, length of service and the fresher column for displaying the data. Now again we have displayed the data for previous year rating, length of service, and this tag I should have changed it to experienced. So okay, so I have put a condition over here, so let me go to that one. Okay, so here if x is equal to 0 then it will be a fresher, otherwise experienced. So that is why it is showing data over here for experienced as well as for fresher, and the length of service, previous year rating. So this is actually about the removal of the missing values and sorting out the missing values that were there in the data set. So we actually saw some empty blocks in the data set, so we filled in with the values as 0. So for that we used fill na and filled with 0. So this is done. Now next what we'll do is we'll display the missing values in the train and test data. So to display that we'll use this display function and this will give the text as train corresponding to the missing values in train set. So we'll use this train dot isNull dot sum. So isNull for counting the for getting the null values and sum function to sum all those, and to display it we'll use this display function. Same for the test. So I'll run this.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So for training set, so this is employee ID, department, region, education, gender, recruitment channel. So for all other columns, the null values, so there are no null values, there are 0 null values, but for education, there are 2409 null values present. And for the test column, the employee ID, department, region, and all other columns are not having any null values. The count is, or the sum of those null values is 0. The count is 0. And for the education, it is 1034. So as the test dataset is less than the training dataset, so it is showing less. So we have counted the null values over here. So now after executing this, let us handle the null values. So for this we'll use ffill, bfill. So I've written this for reference, so you can read this. So talking about ffill, so this is forward fill, that fills the missing values with previous row value. And if previous row value is null, then it moves to the next element without filling. That is why we use ffill and bfill both. So what does bfill do is, so it is backward fill that fills the missing values with next row value. And if the next row value is null, so it moves to the next element without filling. So what actually happens is, for example, for just explaining you, if the system goes to 4th and 5th row and the 4th one is empty, then it iterates to the 5th row and fills the data of the 5th row into the 4th row. So this is actually the backward fill. And in forward fill, what happens is it fills the missing value with the previous row value. For example, if 4th row is having a data and 5th row is empty, the data is not present, then the value present in the 4th row will be added for the 5th row data. So we use both forward fill and the backward fill to fill in the data. Also, filling with mode and new category called others are most commonly used technique which didn't work here, so we are not using that. So we can assume that while collecting data relevant members, data were collected close to one another, so it is not too fluctuating, that means. So talking about the training, now we'll fill in the values for the education column. So here we have used this train, inside it we have given the argument inside the square brackets as education. Then we'll use this dot ffill for forward fill, and we give the argument in this way, that is access is equal to 0 for all of the train and the test data. And finally we display the data and we try to actually calculate the sum of all the null values that are present in the training data set and the test data set using the isNull and sum function. So I'll run this and let us see the output. So it will just take a while to load. So here we get the output for the train and the test data set. So employee ID, department, region, education, gender. So you can see over here, so we have implemented it on the education column by using the forward fill and backward fill. So the count has come down to 0 for the education column. Now after this we'll work on feature engineering. So based on the age distribution, most of the employees are in the range 20 to 40 who will be also waiting for a promotion. And so we have created 2 bins, 20 to 29, 29 to 39, and remaining 1 bin for 39 to 49. So we have used dist plot, so plot a univariate distribution for the observations. So I have written this for the reference so that you can refer it in future if you have any doubt and all. So you can see the description of this. Okay, so moving ahead, we'll use this sns.distplot and we'll give the train as the data and this age column And after that, we'll use this train, and inside this square brackets, we'll give the age. We'll use this pd.cut and give in the argument as train and the age column. So the train data set along with the age column, or for the age column, and bins will be 20, 29, 39, 49, and labels that would be given to these bins are 20, 30, 40. Same for the test one. For age column, pd.cut, bins will be 20, 29, 39, 49, and the labels will be given as 20, 30, and 40. So let me run this, and now we'll get the plot like this. So feature engineering is nothing but extracting the feature or the properties from the dataset and the expertise and the knowledge that we have. So this is the plot that we have after plotting the age column. Now after this, we'll split the train data into predictors and the target, that is independent and dependent variables. So this is the step that we have to do before creating our model. So here we'll split train into x underscore train, that is features, and y underscore train, that is target. So in x train, we'll select all of the columns, that is department, region, education, gender, recruitment channel, number of trainings, age, previous year rating, length of service, KPIs, metric that is greater than 80%, awards won, and average training score. And in this Y train, we'll select the is promoted column, that is the separate column that we have to predict using the test dataset. So we will add this in the Y train section, and then we'll convert the Y train into a frame using 2 underscore frame, because it is a single parameter and the output is expected to be in data frame. So we'll use this to convert it to a frame. Now comes the X test. So we'll use this X underscore test, and inside it we'll give the argument or the number of columns, that is department, region, education, gender, till average training score. So now we have successfully splitted the train and the test data. So after running it, so it has no error, that is it has been successfully executed. Now as we have splitted our data set into train and test, now we'll perform the data encoding using the label encoding and the one hot encoding. So what does it actually mean to perform these operations? So actually label encoding refers to the converting of the labels into numeric form, so that to convert it into the machine readable form, and the machine learning algorithms or the AI algorithms that we are using for building our AI based application can then decide in a better way on how those labels must be operated. And using one hot encoding allows the representation of categorical data to be more expressive, and many or the various machine learning algorithms cannot work with categorical data directly. So the categories must be converted into numbers. So this is required for both input and output variables that are categorical. So we use one hot encoding for that. So we'll define a function that is data encoding, and given the parameters or the arguments, that is encoding strategy, encoding data, and encoding columns. So let me go down and check where I have called this. Okay, encoding data encoding. So I'll check where I have called this function. So this is data encoding I've called over here, then encoding strategy, and then the data, then the columns that we have to give. Now I'll go back over here. Now what does this function do? So if encoding strategy is label encoding, then we have to print if label encoding, and the encoder we have to put in the label encoder because we are using label encoder. And then we will put a for loop over here. So for column in the encoding columns, we have to print column, then encoding data, and in this encoding data the column will be inserted, and then this function has to be executed. So encoder.fit transform, and then the argument must be given. So tuple encoding data, again we'll use the column as the argument. After that, if this is not true, then we put in elif condition where encoding strategy is equal to one hot encoding. So if this is the scenario, then we have to print elif one hot encoding, and then encoding data we'll use pd.getDummies for encoding data. So this PD is the instance of the pandas library, and this getDummies will give us the categorical values, the dummy categorical values. And after that comes the dtype list that we have to define for float 64, float 32, int 64, int 32 for the data type. So this is the data types list. Then encoding data as type will use, and then data types list, and then we'll access the data types. So after implementing if elif, these two lines of code will be implemented which shows the data type, and then return encoding data. So using these condition will implement the data encoding technique. So here for description I have added this quote and many points related to it. So let me read it for you. So applied one hot encoding, it will be applied to object categorical columns only, and it's most common to one hot encode these objects columns since they can't be plugged directly into most models. Then pandas offers a convenient function called getDummies to get one hot encodings. So using this getDummies we get a dummy variable or a dummy value for the categorical or for the encoded values. So get this using getDummies. And many machine learning algorithms cannot operate on labeled data directly. Then they require all the input variables and output variables to be numeric. This means that categorical data must be converted to a numerical form, and a one hot encoding can be applied to the integer representation. Finally, this is where the integer encoded variable is removed and a new binary variable is added for each unique integer value. So you can go through this description for the reference. So I'll run this. So it has been successfully executed, and you will get the result in the next code when we'll implement it. So just for reference or example, I have added the data encoding for this color, that is red, blue, green, red, blue, green. And I have created this df as the data frame, and then pd.data frame. I have given the data over here columns as color. Then I'll print before one hot encoding and call the function as display df, and then I'll print after one hot encoding and display pd.getDummies. So for the first one, so we get the result as before one hot encoding, it is displaying the data frame, and in the second one we get the result after one hot encoding. So I'll run this in one go. So let me explain this one also. So encoding columns, encoding strategy. So I'll go in this code. So we have created a function data encoding, and the parameters are encoding strategy, encoding data, encoding columns. So over here are encoding columns, encoding strategy. So encoding strategy is label encoding, one hot encoding, and the encoding columns are region, age, department, education, gender, and recruitment channel that we have to encode. So while implementing this, we have to just give in the index. So here I have called the data encoding function that we have defined earlier. So xtrain encode, xtest encode, and we have called data encoding and data encoding strategy. So index is 1 and the data is xtrain and encoding columns. So it will take the entire column, so all of the columns, and then the second one is encoding strategy xtest on xtest and encoding columns. So it will take all the columns. Then for displaying the encoded train and test features, we'll use the display function and we'll display the first a few values using the head function. So xtrain encode, xtest encode. So let me run this, and the first one gives the color data frame, that is red, blue, green, red, blue, blue. So these are encoded in 0, 1, 2, 3, 4, 5. So we have performed one hot encoding, and after performing one hot encoding we get the following results, that is color blue, color green, color red. So these three are the colors, red, blue, green, and these are the indexes, and the encoding that is done is, so this is the data frame. So we have converted it into a data frame, that is why it is showing a data frame over here. So color blue, color green, color red. So this is these are the encoded values for it. Now let me go up and let me check. So this was the color part, and then we defined the encoding strategy. Then we have called data encoding 2 times for train and test, and it is showing one hot encoding, one hot encoding. So it has performed one hot encoding. So why it has performed? Because the index that we have given over here is 1. So here it is 0, label encoding is 0, having an index of 0, and one hot encoding is at the index position 1. So one hot encoding will be performed. So for performing one hot encoding, first it will print elif one hot encoding, that shows that it is performing this type of encoding, and then it has performed the one hot encoding using the pd.getDummies. So it is displayed over here. So these are the result for the encoded rows, the columns that are over here. So you can check it out, the encoded values. So we have encoded it for region, and then it shows various region and the values, then for gender, recruitment channel, and so on. After that, after the encoding has been performed, so our data is encoded, and now we have to perform scaling. So we have already discussed about the scaling types, that is robust scaler, standard scaler, min-max scaler, and max ABS scaler. So I have told you about these type of scalars. So we will directly create a function, so using this data underscore scaling, and we'll give the argument name as scaling strategy, scaling data, scaling columns, and we'll give in the condition as if scaling strategy is robust scaler, then the scaling data will be, and inside this square brackets we'll give the scaling columns that we need to scale, and then we'll use the robust scaler dot fit transform to scale the values using the robust scaler, and then the scaling data which we have used and we have passed in the argument, and the scaling columns that we need to scale. Same with the standard scaler. So we'll give in the condition as elif, so scaling strategy, if scaling strategy is equal to standard scaler, then we have to use this standard scaler dot fit transform, and again the scaling data along with the scaling columns, or you can say the corresponding scaling columns.
Just a quick info, guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
That we have to put in over here. After that, again elif scaling strategy is equal to min-max scaler. Now same with the min-max scaler and max ABS scaler. So scaling data, then scaling columns, then again using the fit underscore transform method and given in the parameter as scaling data with the corresponding scaling columns that we need to scale. And final else condition consists of the robust scaler. So if any other scaling sent by mistake, it still performs the robust scaler. So we'll use the same line of code that we used for robust scalar, that is scaling data corresponding columns, and then robust scalar function dot fit underscore transform, and finally we'll return the scaling data. So I'll run this and let's check. Okay, so it has been successfully executed. Now the next one is where we will call the data scaling function or the method. So this is the data scaling method that we have created over here. So this is the description that I have given for reference. So let me read for you. So robust scalar is better in handling outliers. So standardization of a dataset is a common requirement for many machine learning estimators, and typically this is done by removing the mean and the scaling to unit variance, and the outliers can often influence the sample mean variance in a negative way. So in such cases, robust scalar, which uses the median and the interquartile range, often give better results. So here we have defined the scaling strategy. So that is robust scalar, standard scalar, min-max scalar, and max ABS scalar. Now we'll use this x train scale and x test scale as the variable or the instance, and we'll store the values after calling this method, that is data scaling. We'll pass the argument as scaling strategy, that will be 0 in the first one and 0 in the second one. So 0 indicates that it is calling the robust scalar. So we have created the scaling strategy and we can call any one of this. So we have called the robust scalar. Then here we have given the x train encode and then x train encode columns. So what it actually shows is we are scaling the encoded values of train and the test dataset that we have encoded in the previous steps. Okay, then we'll display this x train scaled value and first few values of it for the train and for the test. So it should be test over here. Now let me run this and let us see what we get as the output. So this is the number of training previous year, length of service, KPI, metrics, award won, average training, department. So now we have successfully scaled the values using the robust scalar. So what actually is robust scalar doing over here? So you already know. So it is handling the outliers and it is making the model more accurate and helping us to create such a model to give more precise results. So this is done. Now comes the most important step, that is creating baseline ML model for binary classification problem. So we will use some machine learning algorithms, and you can also say that AI algorithms. So we have already looked around it earlier, that is XGB classifier, then cat boost, light GBM. So here we will create a dictionary, that is key value pairs for ML model name, and then ML model functions with hyperparameters. So these are the hyperparameters. So we'll given the name as classifier, and at the 0th index we'll give the XGBoost. First will be cat boost, second will be light GBM. So using this XGB classifier, we'll define the hyperparameters, that is learning rate, n estimators, max depth, subsample, verbosity, scale, position weight, updater, base score. So the learning rate over here is 0.1. The number of estimators are 494. Maximum depth is 5. Subsample is 0.7, that is 70%. Then verbosity is 0. So what actually verbosity is? So verbosity in keyword, it arguments, and it usually means that showing more wordy information for the task. So actually giving the more description. Then the scale position weight, that is 2.5. Updater is grow hist maker, then base score is 0.2. So we'll see the plot which will be plotted. Then it will be same for the cat boost classifier, learning rate, number of estimators, subsample, max depth, Then for light GBM, the importance type come in for extra. Then verbosity is -1. So you can see over here the verbosity is -1. Here it is 1 or 0. Sorry. So here it is 0. Here it is 1. So the more is the verbosity, the more wordy or the descriptive is the model, or you can see it is more adaptive and it shows the more information. So here it is -1, so it is low. Then maximum number of bin is 60, number of leaves 300, boosting type is Dart, learning rate is 0.15, number of estimators are again 494, max depth and other things are same as the cat boost and xg boost.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Now, after creating a dictionary, after creating baseline ML model for the binary classification, we'll print. So we have to use this list, then classifiers.keys and classifiers.values for it. So after implementing it, let us see what we get as the result. So XGBoost, Cat Boost, Light GBM, and this is what we get. Now our model is created and there are so many parameters to evaluate it. So base score, booster, column sample by level and so many others, but we need to improve our model as no model is perfect in AI or machine learning. So what we'll do is we have to improve the machine learning or the AI model. So as we have used this machine learning algorithms, so it is same for AI also. So I have written over here the ML model. So to improve the ML model with voting classifier, with model evaluation metric, we'll use this F1 and predict target for S promoted. So we'll evaluate the F1 score. So actually what voting classifier is, we have already discussed in the previous section while importing the libraries, modules and packages for the voting classifier. So we'll use the instance or the variable as voting model, and then we'll use the keyword that is reserved by the library or the package, that is voting classifier, and the estimators will given as the XGBoost, and then the second argument will be then list classifiers dot value to fetch the values, and for 0th index is the 1 for XGBoost and the 1 or the first index is for Cat Boost, then Light GBM. Then we have given over here as soft voting and the weights are given over here 5, 5.2, 5, 5 and 5.2. So actually in soft voting the output class is the prediction based on the average of the probability given to that class. And you can consider an example. Suppose you are given with some input for the 3 models and the prediction probability for class 1 and class 2. So if the probabilities are 0.1, 0.2, 0.3 and for the next one it is 0.2, 0.3, 0.4. So obviously the average of the second class is greater. So the winner is the second one. So this is the soft voting that we call in machine learning. So it is given over here. So then we'll use this voting model that we have created and use this fit method, and inside it we'll give the parameters as xtrain scale for the scaled values that we have created in the data engineering process, and we'll give in the y train for training the model. Then we'll evaluate the predictions of the voting using the voting model that we have just now created dot predict probability, and we'll give the x test scale for checking the performance of the model on the basis of test dataset. So we'll take the entire test dataset. So let me run this, and it will just take a while to get executed. So now get the output. So you can see over here, so the learning rate and the total time, remaining time. So you can see it is still executing. Now again it will take time, so let me tell you the next part that we'll implement. So next we'll work on the result, we'll see the result and try to improve the F1 score. So for this okay, it is completely executed. We see the values. So it took a total of 10.4 seconds to predict the outcome or to learn the features of it. Then the next part that I was talking about is the result and the improving of F1 score. So for this we have to round off the probability results, and for this we'll simply use an instance as prediction, and we'll give in the round function, and before it we'll use the integer that converts it to the integer, and then we'll have a for loop. So for value in predictions of voting that we have just now implemented for the voting model or the voting classifier, so predictions of voting will be counted over here, and then we'll create a data frame table for this result, and we'll store it in the result promoted section. So we'll use this pd.dataframe, and we'll give in the employee ID and is promoted, and it will have the predictions and the test set of the employee ID. Then this thing you need not to take care of. These are again the classifiers, and then you have to print list classifiers keys over here. So this will be same as previously we have used the classifiers over here. So this is the same thing. Now let me implement it and let us see the results. So list of classifiers, so XGBoost, CATBoost and Light GBM. Now next we'll print result promoted. So I'll type in print, then result, and now I'll run this, and you can see employee ID and is promoted. So these are all the IDs of the employees who are being promoted. So here you can see that the ID number 5973, so employee corresponding to this ID has been promoted. So this is how we implement it and get the result using the round of probability. Now next we have used the classifiers, that is classifier 1, classifier 2, classifier 3 for XGBoost, then Light GBM and CATBoost. So we are fetching the values and the index as same. We have used 0, 1, 2, and then we have used the array from the NumPy library and given the index over here, and then finally use the voting classifiers, and we have given the estimators as XGBoost, CATBoost and then LGBM for classifier 1, classifier 2 and classifier 3 represented by CLF 1, 2 and 3. Then voting again is soft. Then we will predict the class probabilities for all the classifiers using the predict underscore prob function and giving in the argument as X, and using the classifiers for the XGBoost, CATBoost and Light GBM along with the voting classifier that we have built over here. So all this we are using for predicting the probability. Now to get the class probabilities for the first sample in the dataset, we'll create two classes and then we'll create a 2D array and put a for loop where we'll use the probus instance that we have used for predicting the probability for the model using various classifiers. So these two has been created, and now we'll plot what we have created or what model we have created. So we'll plot. So we'll use n equal to 4, that is number of groups, then ind instance for np.arrange, so arranging these groups, and these are the group positions, and width will be 0.35, that is bar width. Then we'll use figure and ax as the instance for the subplots. So we'll use the plotly package. So plt.subplots is the function that we have to use. And then bars for classifiers 1 to 3 and bars for voting classifiers. So for classifiers 1 to 3, we'll use the instance of p1 and p2 and use this ax.bar function, where ax is the instance and bar is the function taking the parameter as ind, that is the group's position, np.hstack that takes the class probabilities that we have created, and the index -1 shows that it is taking all the values. Then the width is 0.35, then color h color, and same for the second one, that is p2, where we'll use the second class that we have created. And for the bars for voting classifier, we'll use the p3 p4 instance, we'll create it, and ax.bar, where bar is the function that we are using and ax is again the instance, and here the parameters are quite different, that is ind is same, but here we are giving 0 0 0. So instead of h stacks, that is np.hstack, we just given the values as 000 because it is a voting classifier and we cannot use hstag in it for this scenario. So the color is quite different, and now we'll set the plot annotations using the axv line. So it takes the argument as the value 2.8, color equal to k, line style equal to dashed, and then ax dot set underscore x ticks with ind plus width. So it is a matplotlib function that ticks when the values are true and a minor tick when the values are false. Then set the x tick labels for xgboost, catboost, light gbm voting classifier, and the rotation will be 40. And now we'll give the y limit, that is 0 to 1, plot title, that is class probabilities for sample 1 by different classifiers, then plt.legend, that creates a legend for any plot, so for p1 and p2, and the values given over here is promoted no and is promoted yes, then location is upper right, then plt.tight layout, that helps to automatically adjust the subplot parameters according to the padding. Then finally we'll use this plt.show to show the plot. Now let me run this. So this is the final step of building our AI model and optimizing it using various feature engineering processes, classifiers and encoders. So this is the class probabilities for sample 1 by different classifiers. So here the dark green color shows the people who are not promoted and the light green color shows the people who are being promoted. And this is the voting classifier and its average probabilities. So this is the visualization of the probabilities for the employees who are being promoted and who are not promoted, but the actual values we already saw using these classifiers over here. So there are 23,490 records of 2 columns consisting of employee ID as it is unique. So it shows the corresponding ID and the promotion status of the employees. So I'll just go up. So here we have created the model, and we saw that the model took 10.4 seconds, and this is the learning of the model we have created. The model using the voting classifiers and XGBoost, CATBoost, Light GBM, gradient boosting, or extreme gradient boosting instead of that. And after that, we have the results, and we worked on improving it. Then we get the result of promoted, and finally we have visualized using the plot our results. So this visualization of the data is just for our understanding, but how actually is the code implemented using the algorithms in real time is by integrating it using other softwares. So company will not use this code directly. So what they will do is they will create the model using the code that we have built, and then what they will do is they might have another application that shows the information of the employees and their various parameters such as age and other things that we saw. Let me go to that section where we have looked around the data. So employee ID, number of training, age, previous year rating. So they might have an application that show the data. So there they can add a feature that predicting the promotion, and whenever they click on that, so this code is added in the backend. So before it shows the prediction of the employees, or before it shows the list of the employees, this code is being implemented and the results are shown on the interface. So this is how artificial intelligence or machine learning algorithms helps the company to resolve the issue for their various business problems. So here it is the status of the promotion, whether the employee has to be promoted or not. So it is not about this problem. There are many real life business problems that can be resolved using artificial intelligence and machine learning. So these algorithms and these methods are added in the pipeline of a static software or an application, and it gives the output and the result that is the best prediction according to the analysis using the algorithm, along with using the data set that is being provided by the organization, and it makes that software or the application as AI based application. So this is how we implement various scenarios using artificial intelligence.
Okay guys, a quick info. If you're looking for an end-to-end training in artificial intelligence, Intellipaat provides a master's in artificial intelligence in collaboration with IBM, which covers everything you need to know about AI. So the details are available in the description box below. Let's continue with this session.
Just a quick info guys. Test your knowledge of AI by answering this question. In which of the following application does AI has its expansion? A. Planning and scheduling. B. Game playing. C. Robotics. D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
And then we need to understand why we require artificial intelligence. Guys, again, head to the comment section and let me know your top reasons of why you think we require artificial intelligence around us. I mean, human beings are the most intelligent species out there as of now. I mean, sure, that's debatable, but as of now, that's how it stands. Well, so why do we need artificial intelligence then? Well, let me tell you, humans are the most intelligent beings, but then there is only so much that we can do. For example, consider handling a huge amount of data, right? So in this world we live in, basically we live in a world which is a big data problem. So we have terabytes, we have hexabytes, we have petabytes worth of data coming in from each and every Fortune 500 firm, pretty much every single day, every single hour of every single day, in fact. So this
data is growing exponentially, and then when the data is growing at this rate, you cannot expect a human being to be on the other side all the time to handle it. So this exponential growth of data is handled by machines very easily. And then when we talk about the variety of data as well, let's say you need to go on to merge some data, split some data, basically bifurcate some data. There are varieties of data. There's unstructured data, semi-structured data, structured data. So it might not be possible for one human or a team of human beings to basically go on to do this with the amount of data I just told you, right? So when you think about it practically, the variety of sources through which the data comes in is again unlimited almost. So having a machine on the other end of it to take the brutality of the variety of sources, the types of data, the amount of data is going to make life more efficient for the employer as well as the employee. And then when we come to processing speed,
if you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Yes, again, I'm going to restate the same thing. Human beings might be the most intelligent beings out there, but then we do have machines which can be exponentially faster than humans when it comes to certain basic things, let it be mathematical calculations or anything as such. So this will provide unparalleled performance when we have to compare a human being's work directly to an artificial intelligent being's work. If we have to go on to directly juxtapose them. This brings us to artificial intelligence developers. Who are these guys and what do they do? Well, you need to know this. Again, AI developers are basically computer science based people, and these people have to do a lot with coding. Programming languages such as Python, languages such as R, and many other programming concepts. So why do they need all this programming? Well, this is basically to ensure that they can design, maintain, test, evaluate all the artificial intelligence solutions that certain organizations need. So let's say again, the AI technology which has gone into building Siri at Apple might be extremely different, is definitely very different than the technology which went into Tesla's autopilot, right? So these developers need to understand what the problem is, make sure they can formulate the problem and then formulate a solution for that problem as well, right? So designing a solution for an artificial intelligence requirement, and in fact maintaining that product after it's been designed and evaluating to make sure that it is performing right where it should is again very important aspects of an artificial intelligence developer. And I have a quick question for you guys on that note. So I'm pretty sure most of you guys use social media, right? It might be Facebook, it might be Instagram, it might be Twitter, and it might be all the other fancy social media apps out there. Coming to Facebook, let's see how AI developers pretty much work out here, right? So AI developers are pretty much responsible again to handle about 350 million photos a day which has been uploaded to Facebook, and they do a lot with face detection and image recognition as well. So let's say you and your friends decided to go on a vacation. Let's say there were 10 people of you and you clicked about 300 pictures. Now imagine tagging 10 of these people in all the 60 pictures, right? So again, 600 tags you have to do manually, and this is going to take many hours if you have to do this. But then Facebook already would understand who the person that is in the picture, where the picture was clicked, and much more. That is what geotagging means, and location options too. So this is told to you very subtle. It says, hey, was the picture clicked here? Is this person that? I mean, it'll show you the name of the person and it'll show you the location as well, and you might be like, yes. So at that point of time, you might not recognize and realize the power that's working behind it to get you all the details, right? Again, and another important thing is automatic friend suggestions, right? So let's say you added someone on any of their other applications. Now Facebook owns WhatsApp and Instagram. So let's say you're in touch with someone on WhatsApp where you've saved their number or something. Facebook will tell you, it'll give you a friend recommendation saying, hey, why don't you add that person on Facebook as well? So imagine all the processing that goes behind this particular thing. I mean, it's so subtle, as I mentioned on the first slide, that we don't even know it's there anymore. And then when you talk about Instagram, see, there are 95 million photos which get uploaded to Instagram, and handling that is definitely a task, right? And the best thing that Instagram is known for these days is customized advertisement. So you go to Amazon Amazon, you're searching for the latest mobile phone, or you're searching for a mobile cover, tempered glass, whatever it is, as soon as you come back to Instagram, it's going to show you one advertisement which is beautifully put together. You'll feel like clicking on the advertisement. Basically, that's how customized these advertisements are. And again, face detection and object recognition as well. So that plays a very important role in Instagram. Location recommendation systems, again, it'll just tell you where the photo was clicked, what time the photo was clicked, and much more. Friend recommendation, again, so let's say again you added someone on Facebook, or you guys just let's say there are two people who use Instagram. You guys have talked on another social media, but then you guys decided to meet for breakfast or dinner or whatever, and as soon as you come back to Instagram, it's going to give you a friend recommendation saying, why don't you add this person on Instagram? Again, how does this work? Artificial intelligence is at play, my dear viewers. And then coming to Twitter handles pretty much 6,000 tweets per second. Again, there has to be some form of pretty much a pipeline, a channel for the data to flow through in and out of the Twitter's storage area, where pretty much they need to understand, they need to work with this data, because it's not all about storing the data when it comes to Twitter, right? Because they perform sentiment analysis of every single tweet. They check if the tweet has a positive sentiment, a neutral sentiment, a negative sentiment, and what pretty much they can check to the depths of what person in which area liked or disliked this tweet on the face of the globe, basically. So this will add power to their organization. This will make sure that marketing can be done using Twitter, and in fact, at the end of the day, you're bringing more sessions to Twitter, and they are happy. Coming to outreach analytics and customized marketing, again, pretty much it'll tell you who your audience is, when they're watching your tweets, when they're reading it, and why as well, right? So coming to data analytics, again, you can pull out any number of statistics you want with respect to sentiment analysis of any tweet that's present on Twitter, guys. So think about it. We never knew a simple tweet can have this much of a complex circumstance in the back end when we talk about data and artificial intelligence, right? So this brings us to the most important aspect of this video, guys, which is the skills needed to become an AI developer. And let me tell you about 3 important skills that I think you should have. And the first one is all about mathematics and all about algorithms, guys. Because at the end of the day, you need to understand how numbers can in fact be used to achieve artificial intelligence. There is so much that you might not know, and to the intermediate level viewers, pretty much you will know how much of importance mathematics and statistics play a role. And then coming to algorithms, all the machine learning algorithms are again one step closer to making the machines intelligent. All concepts such as machine learning, deep learning, neural networks, all these work under the same umbrella of artificial intelligence. All of these terms that I told you, all of their goals is to achieve artificial intelligence at the end of the day. So having very good mathematical skills and being well versed with the top algorithms which works with, again, based on statistics, is very vital. And second of the 3 most important skills is probability and statistics, guys. Why did I mention statistics again? Well, it is that important. You need to understand all the concepts, everything from the basics of correlation, all the way till how you can basically churn through data and make sure the data will give you insights that the naked eye might not tell you at all. So that is one of the reasons why statistics is extremely important. Coming to the world of probability, again, we need to sometimes understand that the values can be continuous, the values can be discrete. We need to find out what a possibility of occurrence of something is, right? So that, again, pretty much an artificial intelligence algorithm of today will not give you 100% accuracy all the time. It will give you an accuracy of 80, 90, 95, 98%. Again, this 98% is 9 on 10 probability. So it says that there are chances that it might fail 2 times out of 100 times. Again, probability, right? So this is a very important second skill to have. Coming to the third most important skill is having the knowledge of a programming language, guys, because again, there are languages like Python and R which form a very strong requirement when you have to learn about artificial intelligence and to help you become an AI developer. And you can either go on to learn Python, you can go on to learn R, but then beginners do prefer Python because R actually has a steep learning curve which some of the beginners might find difficult. But then do not worry, you can pick up either Python or R and you can be on your way to become an AI developer. And then coming to what R is majorly used for, well, R is actually used to do a lot of data plotting, a lot of statistics, and it involves a lot of bringing mathematics and programming together, is what I want to tell you guys. And then Inagist, again, most of the companies which basically has open positions for AI developers has these roles always present. So you need R and or Python, you're going to need statistics, you're going to need to work with algorithms, machine learning, and so much more. And on that note, here is a step-by-step guide on how you can become an artificial intelligence developer. Let us begin with step 1. Step 1 is pretty much, again, you understanding data structures in detail. You might be wondering why you need the data structures, right? Again, if you understand how your data is stored, how your data is talking to the other entity that is present next to it, then you will understand how you can increase the performance of an algorithm by making it improve itself by drastically changing its understanding of its neighboring data. So understanding the right data structure, understanding when to use what data structure is extremely important. And this is step number 1. Guys, I urge you guys to pretty much whip out your pen and paper or make notes of these, as this will help you a lot in case if you guys are considering to becoming an AI developer. Coming to step number 2, again, as I mentioned, programming. So Python and R are the biggest names when it comes to a programming language to help achieve artificial intelligence. And programming knowledge is vital, guys. It is necessary. There is no work around this. And in fact, it is so much fun to work with, and I've been working on this for a couple of years and I absolutely love it. So working on Python, working in R, there are libraries for machine learning. There is TensorFlow, there's scikit-learn, there's PyTorch for neural networks, there's CNTK, that's the Microsoft's cognitive toolkit, and there are much more. There is Staffy, pretty much, guys. If I have to go on to naming the frameworks, I can keep on going. So when you think about this, there are so many things out there that you need to know, and this already forms the step number 2. So what comes after this? Well, step 3 is understanding a little bit of mathematics, guys. You need to have some sort of clarity on how numbers can actually be used to drive a data-driven entity into making it self-sustain. Because at the end of the day, statistics will play an extremely vital role in making sure your machine understands what's going on in it and derive some sort of continuous or differential inferences based on that. And then this brings us to step number 4. Step number 4 is the most important part, ladies and gentlemen, because here again you will be finding a problem. This is how you have to go by with step number 4. Find a problem which needs a solution. Let's say it might be a new startup that your friend is starting, or you just spotted a common problem across your daily life. So find that problem and make sure that you can formulate the problem and understand what the actual problem is. Now find a solution to that problem, and after you found a solution to that problem in a general human way, try to see if you can get the machine to do it. If you can implement artificial intelligence to do it almost as good as you, if not better, then your job is done. But then you need to understand that at the end of it, you becoming an artificial intelligence developer. So telling the world about it is again very important as well. So there is this website called as Kaggle, where pretty much it's an amazing community where people pretty much come together, give out their problems, give out solutions. There are challenges that you can take place in, and basically it's like a GitHub for programmers. Again, GitHub is the same thing, but when we talk about it, Kaggle is a little different, and I'm sure you guys will know how when you go on to explore Kaggle, which is your step number 4. So coming to step number 5. Step number 5 involves you to understand a little bit of cloud computing, because again, in today's world, half of the organizations we see around us are already scaled to the clouds. So everything from Amazon Web Services, we have GCP, which is Google Cloud Platform, we have Microsoft Azure, and much more. So taking artificial intelligence and scaling it right up in the sky through the clouds is now booming. And as my dear viewers, I have to tell you that having a good certification which will train you on all of these concepts is extremely vital. Working on AWS, working on GCP or Azure or any of these, so having cloud computing knowledge and bringing it together with artificial intelligence are very vital. And coming to step number 6. Step number 6 is again an important aspect for an AI developer, because not only you'll have to work with one single computer at point of time, you'll have to work with multiple entities, multiple computers, because at the end of the day, you're going to use this to exponentially increase your computing power. And this is basically done to understand how you can gain some sort of systematic knowledge onto scaling this artificial intelligence entity that you're developing onto a modern infrastructure. This is very vital, guys. So to revisit all the steps, here's a recap. Your step 1 will begin by understanding data structures. Step 2 with a programming language and some libraries. Step 3 is mathematics and statistics. Step 4 is finding a problem, analyzing it, and solving it. Again, the next step involves scaling artificial intelligence to the clouds, and the last step is to understand how you can make use of artificial intelligence on multiple machines at the same time, which is basically distributed computing. And to basically strengthen everything that I've said, here are some of the sample job descriptions that we can check out. So here's a job description for an artificial intelligence developer from the Penn State University in the United States of America. Their requirement is this. They say proficiency in Python is needed, experience with machine learning library TensorFlow, Infinite Cafe is needed, and pretty much they say proficiency in mathematics is needed, as we discussed, linear algebra, multivariate calculus, and much more. Skill is required in JavaScript or R, as we discussed, data structures, and ability to communicate technical topics to the people who might be non-technical audiences. And then cloud computing, AWS, as I told you, right? So we discussed all the 6-7 points, and again, you can see just in one job description, we can see all those 6 points reflecting onto us, right? And then in fact, coming to a researcher's jobs, we just checked out the artificial intelligence developer role. Let's check out the artificial intelligence researcher's role. Again, this comes from the Massachusetts Institute of Technology. It's called Lincoln Laboratory. These guys as well, they require you to have experience in machine learning software, PyTorch, TensorFlow, MixNet, Scikit-learn, and much more. They would appreciate if you guys had experiences in working with large computer vision data sets, experience with big data, Hadoop, Spark, Elasticsearch, Cassandra. You'll be able to work in a multidisciplinary team environment. You have to have very good communication skills, oral skills, and sometimes you might have to travel as well. So guys, when we think about these two job descriptions of an AI developer and an AI researcher, again, when you come to think about it, we have validated all the points that we pretty much just discussed, right? And this brings us to the most important part of our live session, which is pretty much to tell you what the average salary is. So here is the average salary, guys. So pretty much again, when you think about it, the average salary of a junior AI developer is somewhere around $80,000 in the USA, 7 lakhs per annum in India, 45,000 pounds in the UK, and then a senior AI developer has somewhere around $115,000 in the US, 15 lakhs per annum in India, and 60,000 pounds in the UK, guys. So these are some of the very big numbers that you can see when we talk about AI developers, AI researchers. And then, as I told you, this is a very lucrative career that you can pretty much jump onto, guys.
Coming to the first question on these top deep learning interview questions set, the first question is, what are the differences between machine learning and deep learning? This is a very common question that's asked, and it is very important that you know the basic differences that lie between machine learning and deep learning. One very good commonality is that both of these are actually subsets of artificial intelligence, and deep learning itself is actually a part of machine learning. So when we talk about machine learning, we're making sure that we find a way where we're training machines with a lot of data. We give it some data and we hide some data from it, in fact. And we use the hidden data later, which we also call as the testing data, to make sure that the machine learns something, and to verify if it has actually learned from its experience. When it comes to deep learning, we try to find methodologies and ways where we can sort of trick the machine into making it think like a human being, making it use the human brain structure in terms of working. In the concepts of neural networks, the entire concept is named after neurons and the use of neurons as well, just because how very similar to how it works in the human brain. So this forms to be the basic difference between machine learning and deep learning. Moving on to the second question, it says, what is perceptron? Perceptron is a very important concept in deep learning because it actually matches what we see in an actual neuron in a human brain. So coming to how it works in deep learning, a perceptron actually receives inputs from a variety of entities, and then later it takes these entities, applies some transformations on it, what we call as functions. It applies functions on this, and then it becomes the output. So input, perceptron, applying function,
output. That is how the order goes. So if you have to talk about when perceptron is mainly used, it is actually used when we go on to perform binary classification, where we use an input, we try to see if we can classify something based on the output. There's so many factors when we talk about the functions as well. There is weights, there is biases, and there's a lot of things in a neural network in deep learning that has a lot of impact. And in this system itself, perceptrons play a very important role to take an input and transform it and work on it to give you a valid output in the case of classifiers as well. Now, coming to question number 3, it states, how is deep learning better than machine learning? Both deep learning and machine learning are very powerful in their own ways. To solve most of the complex problem in a very simple way, machine learning has got it covered. But then when you talk about deep learning will overpower machine learning, especially when it comes to working with data that has huge number of dimensions. Think about an Excel sheet which has about, let's say, 100 columns with 35,000 entries each, something like that. So when there's a lot of data in your data set and the dimensions are very large, deep learning will be exponentially efficient at working with things than compared to machine learning. So if your data is large, then a deep learning model will work very efficiently to actually solve it, handle it, and it'll make it easier for you to program and work with it at the same time as well. So this is how deep learning is having the upper hand over machine learning in a very simple and a concise way. Now, moving on to the fourth question, it states, what are some of the most used applications of deep learning? Again, this is a very common question that can be asked in your deep learning interviews. So at least make sure you mention at least 3 or 4 fields, and in fact I've put up around 6 fields on the screen right now. Everything from sentiment analysis, mostly Twitter, and all of that. Then we have computer vision to analyze graphics. Then we have automatic text generation, we have object detection, we have NLP, natural language processing, and image recognition. There are more fields. You can name about 10 to 12 offhand if you have worked a little bit on deep learning, but then it doesn't it doesn't really add a lot of value if you just list 10 to 12. So rather just tell 5 or 6 and just explain 1 or 2 lines about what each of them mean. That way the interviewer has an idea that you are concrete with respect to all the concepts there as well. Now with this we can come to question number 5 that states, what is the meaning of overfitting? Overfitting and underfitting are actually 2 very common issues that have to be dealt with whenever you're working with data sets and whenever you're working with deep learning. Overfitting, as the name suggests, is a scenario where you have a deep learning algorithm and your deep learning algorithm is looking very hard into your data and it is trying to hunt for meaning. It is trying to find some meaningful correlations in between the data in the data set. Now, in a way, what happens in overfitting is that it will start vigorously hunting for the data, and this makes it pick up noise, what we call as noise, rather than any sort of useful data. So with this noise, it hurts the efficiency, it hurts the detection capacity of the model. So rather than picking up any useful valid information, your model will start picking up noise, and that is not a good thing. So what happens is, at the end of the day, you'll have a very high variance in your data and a very low bias. This way, of course, you would already know that your model will be very, very inaccurate in terms of detection and very inefficient at detecting new things, even if it has a good level of accuracy as well. So when you think about it, overfitting needs to be fixed, and underfitting is just the reverse of this. Anyway, coming on to the 6th question, it says, what are activation functions? Activation functions are very important entities in deep learning because these are the actual functions that will take your input and make sure that you have something usable on it. So the transformations that happen, right, it is all because of the activation function. So what an activation function is basically is that it has the capability to decide if a neuron actually needs activation or not in that particular array, in that particular set of neurons, to see if there has to be anything modeled from that particular neuron in the chain in the neural network, or if it adds a value to the next set of neurons as well. So this is actually done by calculating the weighted sum of it and then taking the bias as well. So at the end of the day, whenever you're making use of an activation function, the model output will be non-linear. And if you have to talk about the types of activation functions as well, So there's rectified linear unit, or ReLU for short. You have softmax, sigmoid, linear, tanh, and many others as well. So it adds value that you answer it in a way where you tell what activation functions are, how they're calculated, what the output will look like, and what are the types of activation functions as well. With this, we come to the seventh question that states, what is Fourier transforms that is used in deep learning? Fourier transform is very vital to deep learning because it is one of these packages that is used to manage and work with a lot of data when we work with deep learning. As you already know, in deep learning we will be working with huge data sets, so we need methods and tools and techniques where we can process these in real time, and we can make sure that we can handle it and work with it easily and quickly as well. So Fourier transforms is one of these packages that will make sure that you have high efficiency whenever you're working with data. And with Fourier transforms, your model is now open to a lot of signals where you can have the data processed from multiple entities, and to just make sure that you're opening up a dimension when you're working with the data as well. So Fourier transforms are a very vital part of deep learning. Now with this, we can come to question number 8 that states, what are the steps involved in training a perceptron in deep learning? There are about 5 to 6 steps whenever we have to talk about the perceptron learning, or training a perceptron as it's also called as, and these are the 5 steps. Firstly, the first step is always to initialize all the thresholds and the weights of the network. Then of course we'll be providing the actual inputs. The outputs are calculated based on a lot of things, and we have back propagation, all the algorithms that run in the back end, and after which we'll have the steps where we'll be upgrading the weights in every single step. So after the weights are upgraded, then we'll again provide another set of inputs. We'll be calculating the weights again, and this goes on from the starting initial node all the way till the last node of the output neural network. And this is how simple it is to actually train a perceptron in deep learning. Now with this, we can move on to the 9th question that states, what is the use of the loss function? Whenever we talk about neural networks and deep learning, we need a methodology, we need a number, we need a numeric where we have the ability to see if the model is working towards its goal or not, right? So the loss function is a measure of accuracy here as well, because we're trying to see if the neural network actually learned something useful from the data or not. And a loss function is a negative metric where if the loss function's value is less, then it's good for the model. If the loss function value is high, it means that the model is not performing well. So at all times, it is very vital that you mention that the loss function has to be kept to a minimal extent. Now with this, we can come to the 10th question that states, what are some of the deep learning frameworks or tools that you have used in the past? Now this is a very common question that's asked in the interviews, because the interviewers want to find out about the experience that you have with all of these tools. So just make sure to mention of all the frameworks, tools and techniques that you might have used in your projects or your certification programs, or whatever it is that you have used, the methodologies that you have used to learn. Of course, there are many top deep learning frameworks out there. We have an entire video on that on the channel as well, so make sure to check that out after this video. Among the top deep learning frameworks, we have TensorFlow, we have Keras, we have PyTorch, we have Caffe2, we have CNTK, that's Microsoft's cognitive toolkit. Then we have MXNet, we have Theanon, we have many others. In fact, you can list about 12 to 15 very good top deep learning frameworks out there. But then just make sure to mention 3 or 4. But then if you of course used more than that, then do make sure you mention that as well. But then make sure that you are very honest about it, and do not I would suggest that you do not state a deep learning framework that you might have not used, as that might lead to you being asked questions on that, and you not being able to answer as well. So make sure to take care about that. Now with this, we can come to the 11th question that states, what is the use of the swish function? So the swish function is nothing but an activation function, as we discussed a while ago. So it's something called as a self-gated activation function, and it is developed by the people at Google. So one thing to note about the swish function is that it is extremely popular because Google has put up a very good claim that it outperforms all of the other activation functions that exists today in terms of efficiency. So we discussed the different types of activation functions as well, right? tanh, ReLU, and all of these. So then Google came about, they devised an algorithm, the activation function algorithm, and they put up saying that this will outperform everything else that already exists. So that is one of the reasons why this particular activation function has seen so much limelight as well.
Just a quick info, guys. Test your knowledge of AI by answering this question. What is artificial intelligence? A. Putting your intelligence into computer. B. Programming with your own intelligence. C. Making a machine intelligent. D. Putting more memory into computer. Comment down your answers in the comment section below. Whoever gets the correct answers will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Now with this, we can come to the 12th question that states, what are autoencoders? Autoencoders itself are artificial neural networks, and this is something which is very important that you know. And of course, they do not have any supervision, as they have the ability to automatically try and map inputs and to find out outputs and work with it on their own. So it's a very interesting concept to work with autoencoders, and these are very efficient as well. But then when we talk about autoencoders, it is very vital that we talk about two important things. One is the encoder and one is the decoder. These two are the very important entities that we have to discuss about. An encoder will make sure that the input is taken and it is converted into a format which is understood by the neural network into an internal computation state, of course. And then we have the decoder, which does the exact opposite of this. It will take the computational state data and it will make sure to convert it back into the output. So encoders, even though the name only has encoders, there are two operations that's going on. One is the encoder operation and the other one is the decoder operation. Now with this, we can check out the 13th question that states, what are the steps that have to be taken whenever you make use of a gradient descent algorithm? There are actually 5 to 6 steps that have to be discussed whenever we talk about initializing and making use of the gradient descent algorithm. The first step is always, you have to initialize all the biases and weights for the network as well. And after you have initialized all the biases, you have to send the input data throughout the network, which forms to be, of course, the input layer, the first layer of your neural network. And then we'll actually calculate the loss function, right? So you'll have an expected value that you're expecting at that point of time, and there will be a value which is predicted by the model as well. So calculating the difference between this will give you the error of how far away the neural network is from the actual goal. Now, after that, you will actually change all the values in the neurons to make sure to find ways where you can minimize this loss function, this difference that we just found out in step 3. And after which, of course, this entire process is an iterative process. You'll be looping it and doing across multiple iterations to find out what biases, what weights, and how best you can do to keep the loss function at its minimum. So these are some of the steps that have to be followed whenever you're working with gradient descent algorithm as well. So with this, we can come to the 14th question that states, differentiate between a single layer perceptron and a multi-layer perceptron. We already discussed that, if we're talking about a perceptron, in case if it's a single layer perceptron, it will not have the ability to classify non-linear data for us, but then a multi-layer perceptron completely can, classify non-linear data. And a single layer perceptron is a bit limited in one aspect where, the number of parameter that it takes in is very less when you compare to a multi-layer perceptron. And this in big deep learning models can have a very, very, disastrous effect as well for efficiency, for effective working and whatnot. So again, for the second point, I think multi-layer perceptron wins. And when you talk about the third difference, of course, a single layer perceptron has many things that it can do well. But if we are talking about efficiency when making use of large data, well, again, a multi-layer perceptron of course takes the higher end because it is extremely efficient to work with in the case of large data sets. Now with this, we can come to the next question that states, what is data normalization in deep learning? So data normalization is a very, very important step. It is actually a pre-processing step where we try to make sure, we can move around the data, rearrange the data, and we can make sure to refit and pack this data into one particular range. This is the entire process of normalization. Why we do this is to make sure that if your data is in one particular range, it means that your network has the ability to learn very effectively and be very efficient as well. So when you're performing steps like backpropagation, having a data in a very structured range, a specific range, will make sure that your network can learn that much faster as well. So these are one or two reasons why this pre-processing step that we take, called as data normalization, is very important. Now with this, we can come to the 16th question that states, what is forward propagation? So backward propagation is the scenario where we work from the output layer to the input layer, and here in forward propagation it is the exact reverse. We follow in the order of the neural network. So we go from the input layers to the hidden layers and then the output layer. So when you're talking about a complex neural network, there'll be more than one hidden layer. So for every hidden layer, the output of the activation function is actually calculated, and this is done until the next layer can actually be processed. The reason they call it forward propagation, as I just mentioned, is to make sure we work from the input and towards the output, and this is the exact opposite of the backward propagation algorithm as well. So to make sure that we use the output of the activation function and to calculate it for the next layers, forward propagation is very, very important. Now with this, we can check out the 17th question. Again, coming back to the very main important question, your interview could start with this question itself. What is backpropagation? So backpropagation, instead of talking about what, the first thing you have to always discuss is why backpropagation is even important, right? So it is to make sure that we keep the loss function or the cost function less, and to see how the values changes whenever we, work with a variety of biases, a variety of weights. Whenever we change all of these, even a slight change can have a very big impact on your model. To understand how these work, we require the backpropagation. It's called backpropagation, of course, because it starts from the output layer, works backwards towards the input layer direction. So how is backpropagation calculated? Well, it is very easily calculated whenever you work by understanding the gradient that is calculated at every single hidden layer itself. So it's as easy and straightforward as that. Now with this, we can check out the 18th question that states, what are hyperparameters in deep learning? So when you talk about hyperparameters, even though the term is very complex, they're nothing but variables that are actually used in deep learning to actually determine the structure of a neural network. So these variables are put into place to make sure that we have an easy way of understanding so many different factors and parameters in the deep learning model, be it the number of hidden layers that are present, or the learning rate of the model, and much more. So hyperparameters are very important variables that will give us a lot of insight into how the model or the neural network is functioning as well. So moving on to the next question, it states, how can hyperparameters be trained in neural networks? So training a hyperparameter is very important, and understanding how you can convey this to the interviewer is also very important, because these are long procedures and your ability to concisely answer it is very important. So, to train a hyperparameter, we'll require 4 very important components. It's the batch size, the number of epochs, and there's something called as the momentum, and there's a metric called as the learning rate. So what happens in batch size is that we'll take the input, we'll split it into batches. Batch size can be varied depending on however it is required based on the efficiency and a lot of other things. These batches can be cut into further sub batches as well, if that is the requirement. So instead of pushing all the input into a concurrent pipeline, we just make sure to dig it up into batches and then vary it across. Now, when you talk about epoch, an epoch is basically a denotion of how many times the training data is run through the neural networks where it can train. So the number of epochs is the number of iterations at which the model, the neural network trains as well. So it's an iterative process. The number will depend on so many different factors. Doesn't mean that if you have a large number of epochs that your model will be very, very accurate with every single iteration. It will go up to a point, and then of course your model will work, in fact, in the opposite direction. Now, when you talk about momentum is actually put into place where we have an idea to check out what happens in the next consecutive steps. Whenever data is being moved around in a neural network, it is vital to understand what happens next, right? So, there is no point if your model is very inefficient where it's passing around data and not driving any momentum from it. So momentum is this particular track where we make sure we understand what's happening next as well. Now, coming to the last component, it's a very important component. It's the learning rate. Learning rate is what we're all after when you work with deep learning, because this is used as a very important parameter where we're trying to denote what is the time that's required to actually update all the parameters when your model learns and when your neural network is ready to take in certain inputs and give you meaningful outputs as well. So these 4 form to be very, very vital, very important components in the world of deep learning whenever we go on to train hyperparameters. Now with this, we can come to the 20th question that states, what is the meaning of a dropout in deep learning? Now, dropout might seem like a very common term, but it is actually a technique in the world of deep learning. Dropouts are a very important technique, in fact, because these are used to avoid overfitting. Overfitting and underfitting are common problems, as we discussed a couple of questions ago. So, to avoid overfitting, to make sure that your model doesn't hunt for noise, what we actually do is, we purposefully remove a bit of data which might not be useful for the model to learn as well. So, if you have a dropout value to be very low, it will have a minimal effect on learning because you're not removing enough data and your model can still go towards overfitting. But then if you remove a lot of data, then what will happen is the model will not have enough data to learn. So it will underlearn and then cause inefficiency as well. So this value, right, this drop off value should be very, very vital, because if you have it too low, it will not have an impact. If you have it too high, then your model will not learn effectively anymore. So understanding this is a key concept. Now, coming on to the 21st question, it states, what are tensors? Tensors, you might have heard of these. These are another name of arrays, guys. So tensors are actually multi-dimensional arrays that are mostly used in deep learning, where we have to represent data across either one dimension or in fact multiple dimensions as well. So why can't we just call them arrays and not tensors, right? So tensors have the specialty of a name because they have been very famous. They have been very vital whenever we work with data of higher dimensions. So one very big advantage when we talk about tensors is that whenever we make use of it in any of the programming languages, right, the syntax is very readable. It's a very high level syntax. So what that does is it gives us a clear picture of tensors, even though if we do not have very high amount of training in terms of making use of tensors or its terminology. As soon as we look at the programs, we'll have a keen idea about what tensors are and what they might be doing in the program as well. So this is one very good advantage when it comes to working with these multidimensional arrays called as tensors. Now we can move on to the 22nd question that states, what is the meaning of model capacity in deep learning? Model capacity is again a very important metric that we have to discuss about, because model capacity deals with the capacity of the model to actually take in a variety of mapping functions. So how many mapping functions can your model handle? How many can it concurrently work with as well? One thing we drive out of this metric is that higher the model capacity, it literally means that there is a large amount of information that can be stored and worked with in the network. If the model capacity is low, as the name suggests, it means it cannot handle and effectively a large amount of information at a time as well. So model capacity is something which is very straightforward, but yet it forms to be a very important concept in deep learning. Now with this, we can come to the 23rd question that states, what is the Boltzmann machine? Boltzmann machine sounds very complex, but it is actually a type of a neural network, that we call as an RNN, or a recurrent neural network, where we make use of binary decisions, biases, and to do a lot of functioning and working for us as well. So Boltzmann machines are, like as I mentioned, RNNs. They are hooked together to create something that we call as DBNs, or deep belief networks. So these deep belief networks are extremely sophisticated. They have multiple number of hidden layers, and they're put into place because we have complex problems that require effective solving. So the entire goal of deep learning, in fact, is that we have extremely complicated problems and we need to find ways to make use of the power of computing to simplify that to a good extent for us, and a Boltzmann machine will do exactly that. Now, after understanding this, we need to check out what are the advantages of making use of one of the top deep learning frameworks out there called TensorFlow. So, of course, this could be a very important question in case if you work with TensorFlow, because understanding the advantages of it is very vital. So TensorFlow has many advantages, and to me the most important advantage is where it will give you a lot of flexibility and platform independence whenever you're working with it. The platform independence is very vital because we all have multiple operating systems, multiple platforms that we work on, and of course, so it has the ability to power through and train on both CPU and your graphical processing unit as well. And with new technologies with GPUs, it just makes it very efficient to work with tensors too. And then when we talk about auto differentiation and the features it brings with it, is again a huge impact. When we talk about threads and its ability to handle asynchronous computation, this is where TensorFlow wins over many other deep learning frameworks as well. The second most important advantage to me is that it's open source. It has a beautifully large community, so you don't have to pay for it, but then at the end of the day, there are so many things that are being added in terms of features, technologies, fixes, and so much more more. And this entire community of open source is just a beautiful thing. And I'm sure you can relate to this if you work with TensorFlow as well. So with this, we come to the 25th question that states, what is a computational graph in deep learning? So a computational graph, as the name suggests, is a scenario or is a graph itself where we try to take inputs, arrange them into meaningful entities called as nodes, and later create a graph structure out of it. So these are done to simplify certain mathematical calculations and to visualize them better. So in terms of deep learning and in terms of backend functionality, it helps a lot whenever we're working with parallel processing, as it provides a huge performance boost over a single threaded performance in terms of making use of actual computational graphs, as your processing power is now 2, 3, 4, 5 or 10 times 10 folds better than how it was before as well. So computational graphs are very, very important units when it comes to working with deep learning. Now, we can come to the 26th question that states, what are CNNs? CNNs and RNNs.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Are very different types of neural networks. A CNN stands for convolutional neural network, while an RNN stands for recurrent neural networks. Now, coming to the talk of CNNs, CNNs are mostly used to perform visual analysis or working with a lot of images and classification as well. You can have multiple images of many channels as well. So when we talk about images and channels, mostly we talk about colored images and black and white images. Colored images will have like 3 channels: red, green, and blue, RGB structure, and so much more as well, right? So a CNN has the ability to easily work with, classify, and give you meaningful outputs on all of these images and visual data. Now, if we talk about a little bit more about CNNs, the next question can be saying, what are the various layers that are present in a convolutional neural network? So when the talk is of this, understand that there are 4 important layers in a convolutional neural network. One is the convolution layer, we have the ReLU layer or the activation function layer as it's also called. Then we have the pooling layer and the connectedness layer. So when we talk about the convolutional layer, this is where we apply things and entities called as filters across the main data to have them as parameters to teach and train the network. So after the convolution step is done, we'll use the activation function to squish it and bring it into a range which is workable and understandable by the neural network. After the activation function is done, then there's something called as pooling. Pooling is where again we shrink the data to make sure we are not losing any of the existing data, and what happens after convolution is we lose certain data as well. So we do stuffing in the pooling layer as well to make sure that we add certain bits, dummy bits, to make sure that the size of the image is actually maintained after every single iteration. So with every iteration the image shrinks a little, and with padding we make sure that we are not letting it shrink out of context as well. And then when we're talking about the 4th important layer of the convolutional neural network, it's connectedness. Here we're just making sure that all of the activation functions are applied correctly by making use of the bias and generally checking that the entire neural network is connected thoroughly and it's working as expected as well. So as the name suggests, this is a very important layer to verify the understanding of the neural network. So these are the 4 very, very important layers that you have to know about in this particular order itself. Whenever you're mentioning the working of it, the questions can be like, what is the working of a CNN, or what are the layers that are present as well. So this will develop as both of those questions. Now, when you talk about RNN, as I just mentioned, next question can be, what is an RNN in deep learning? So RNN, as I discussed, it stands for recurrent neural networks, and unlike CNNs, the working here is very different. The use of it is very different because RNNs or recurrent neural networks are very, very efficient at working with a lot of string data, textual data, genome data, handwriting data, and much more. So if you have already worked with any basic use cases where you're performing, let's say, handwriting prediction or detection of handwritten letters or whatnot, then there's a good chance that you've made use of an RNN. RNN uses the technique called as backpropagation that we've already discussed for all its training requirements, and it is very, very effective at doing this as well. Just like how CNN is very effective for working with images, it shows similar girth whenever you're working with textual data as well. So this is again a very important aspect in deep learning. Now with this we can come to the 29th question that says, what is a vanishing gradient whenever you make use of recurrent neural networks? A vanishing gradient, to be honest, can be considered as a scenario, because we already saw in the last answer that RNNs make use of back propagation, right? So if there is back propagation, then there's the calculation of the gradients at every single step. And whenever we work with back propagation, whenever we calculate gradients, they tend to get smaller and smaller as the data works backwards from the output layer to the input layer. So since the value becomes extremely smaller towards the end as we approach the input layer, it causes a problem. So, this basically means that your model will learn very slowly and it cannot be efficient. It will underlearn sometimes and it will cause a lot of problems. So this is a scenario of occurrence where your gradient values are becoming very low, and that scenario is what we call as the vanishing gradient. Now, I hope this is clear. So with this, we can move on to the 30th question, which states, what is exploding gradient descent in deep learning? Just like vanishing gradient, exploding gradients are another issue which work in a very different way, because here is a scenario where we're clumping up all of the gradients. Means what it does is it will create a large number of updates for all of the weights in the model whenever it's training. So your model weights are being updated constantly more than required, and and we already know the working of gradient descent, right? So it's based on the condition to keep all of these updates small to make sure that your upgrades are controlled, and only then can your gradient descent have some meaningful impact on your deep learning model. So with this, we have to understand that whenever you control these updates that happen to the weights of the model, right, this will have a huge impact, in fact direct impact on the efficiency of the model as well. So this is another scenario, what we call as the exploding gradient descent, where we have large number of updates that happen to the weights, which make it very, very inefficient at the end of the day too. Now with this, we can move on to the 31st question. So the 31st question states, what is the use of LSTM? LSTM is again a very important type of recurring neural network that we use to perform a variety of operations whenever we work with textual data and string data, as I just mentioned a couple of slides ago. So it stands for long short-term memory, and the working of it is slightly different because it makes use of something called as feedback chains, where it gives the network the ability to perform like another general purpose computing entity as well. So when it comes to that, it is very efficient at working working with a lot of data, especially when we're talking about genome data and genomic sciences. LSTMs are very efficient at working with that as well. So again, just being a type of another RNN, it sort of trickles down to having all of the features and the general working of RNNs too. Now with this, we can come to the 32nd question that states, where are autoencoders used? So we checked out autoencoders before, but then there might be a follow-up question to that stating where they are actually used, right? So you have to understand that autoencoders again have a lot of usage in the real world. So whenever we talk about it, you can have about 10 to 15 uses that of course that you might know already, but then it is vital that you at least mention 3 or 4 very popular applications of it as well. So let's say in the real world, if you have a black and white image and you want to have it colored out to what it actually was in its real life, then adding color to black and white images are very important use cases. And if you have any other old images where you have to remove noise, autoencoders are used here too. And then when you talk about dimensionality reduction and feature removal or feature variation as well, autoencoders seem to be very popular. And in fact, more than popular, they're popular for a reason, that is because they're efficient at handling all of these tasks. So make sure you mention all of these real life applications which are very popularly used as well. So with this, we can come to the 33rd question that states, what are the type of autoencoders? So, there's actually 4 types of autoencoders that you have to mention. One is the deep autoencoders, we have convolutional autoencoders, we have sparse autoencoders, and of course we have the contractive autoencoders as well. So you really don't have to explain when you're asked for the types, but then it might add value if you can just state 1 or 2 sentences about each. But then it is very important that you mention all the 4 types that exist for autoencoders as well. So moving on, we come to the 34th question that states, what is a restricted Boltzmann machine, or an RBM for short? An RBM is actually a graph, if you have to talk about it in general. It's a graphical based model that we make use of in deep learning today, and it does a lot of things and can do a lot of things efficiently as well. So when you have to talk about performing operations such as classifications, or let's say regression, dimensionality reduction, be it collaborative filtering, topic modeling, or all of these operations that need to be performed that require an algorithm to do it, an RBM can do it very effectively in today's world of deep learning, where it can make use of the computation power of today and work with it effectively as well. So an RBM is again a very important, a very again I know there's a lot of efficient being used in the case of deep learning, but then of course an RBM is very tricky to work with at the same time, but then the output that it provides is worth the effort. Coming to the 35th question, it states, what are some of the limitations of deep learning? We've been talking about advantages for, say, 34 questions now. So it is very vital that you know what some of the limitations or the disadvantages are. There are not many disadvantages, but then there are, a few disadvantages as well. The first one is, whenever you expect very good, very accurate output, you need large amounts of data, and your network has to have the capability to work with large amounts of data effectively as well. So that is one disadvantage. To gathering all the data might not be the case in all the factors. And then when we talk about how complex it is to implement, for example, an RBM is pretty complex for a beginner to work with and to get it working efficiently as well. So in a couple of cases, not just RBMs, RBMs might be easy to you, but then there are many concepts where it can be a little convolutional, it can be a little confusing, and it can be a bit complex to work with as well. So that is one of the disadvantages. And just like any other deep learning concept, your main focus always will be to make sure that your models are very efficient. So you'll be hunting on keeping that loss function down. You'll be hunting on making sure that your goal parameter is being met, and it is being met in a way where your model is very accurate. It is not overfitting a lot, it is not underfitting a lot, and it is performing as it should at its best. So hunting for these can take a lot of time, and it is not as simple as it's put out as well. So in case if you have had first-hand experiences working with deep learning, you will know what I mean with this. Now, we can come to the 26th question that states, what are the varieties of gradient descent that are available, or what are the variants of gradient descent? There are actually three very important distinctions whenever we talk about gradient descent. One is the SGD, or the stochastic gradient descent, then we have the BGD, or the batch gradient descent, and then we have the mini batch gradient descent. And whenever the talk is about stochastic gradient descent, the first important thing is that we only make use of one training example, and we calculate gradients based upon that. We update all the parameters based upon this single entity, this single example that we have. But then this is not the case when we talk about batch gradient descent, because once we calculate a gradient for batch descent, as the name suggests, we'll take the entire data set and calculate the gradient for all of the entities that are present in that data set, and then of course we update all the parameters one after the other in every iteration as well. And mini batch is again very similar to batch gradient descent, but then the batches itself are broken down into digestible pieces, or small sized chunks, or small sized batches as it's also called, and then work with it just like how if it was a stochastic gradient descent, where we again take a simple training example and we make sure that we calculate gradient, update all the parameters, and perform the same operations for different values across a variety of iteration as well. So these are some of the three important gradient descent, stochastic gradient descent, batch gradient descent, and mini batch gradient descent, that you have to mention when you ask this question. So with this, we can check out the next question that states, why is mini batch gradient descent so popular? So why is mini batch so popular, right? So this is again a question that's asked a lot. In fact, it's a very frequent question if you talk about the previous question or a follow-up to that as well. So one reason why it is popular is, of course, because it is very efficient when you directly compare it against stochastic gradient descent. And when we talk about avoiding the concept of local minima, mini batch gradient descent will help, because we'll be approximating all of the gradient values for the entire data set, and this is done because we use a concept called as generalization, rather than hunting for specific values every single time by doing this concept where we're finding the flat minima and working with it. So what this does is make sure that we can avoid the local minima, we can approximate the gradient for the entire data set by the process of generalization, and it can be done very easily as well. So it packs a punch without having much effort into it. So that's one advantage of mini batch gradient descent. Now with this, we can check out the 38th question that states, what are deep autoencoders, right? So we checked out regular autoencoders. So what are deep autoencoders? Deep autoencoders are actually an extension of the regular autoencoders that we just checked out before. So here the difference lies where the first layer is actually responsible for what we call as the first order function of the input, and if you have a second layer, then the second layer will take care of what we call as second ordered functions, third layer will have a third order function, fourth layer will have fourth order functions, and so on. So it goes on like that. So when we talk about a deep autoencoder, it is basically a combination of making use of two or more symmetrical DBNs that we discussed, right? So DBN is a deep belief network. So here in an autoencoder, we combine two or more of these deep belief networks, where let's say the first 5 layers is considered as the shallow layers, which will take care of the encoding aspect of it, and the last 5 layers, or in fact all of the other layers, can handle the decoding part as well. We checked out that encoding and decoding are two very vital aspects of autoencoders, and this is where deep autoencoders shine, and how they are complementary to the regular autoencoder as well. So with this, we can come to the 39th question that states, why is the leaky ReLU function used in deep learning? So ReLU stands for rectified linear unit. So leaky ReLU is also called as LREL. In case if you asked about LREL, make sure to understand that it is the same as leaky ReLU. So, we use leaky ReLU in a concept, let's say, where we have the input values, and if they, if the input values are all less than 0, right? So what we try to do is we allow the passage of, small sized negative values to the function, where we use it to actually manage the function, work with it, and then, to drive the activation based upon that as well. So whatever neurons require activation, if the values are less than 0, leaky ReLU is very popular there, which will allow the usage of small negative values and drive meaning out of that at the end of the day. So after understanding leaky ReLU, it becomes very vital that you check out some of the examples of supervised learning algorithms. So, this is a machine learning question, but then we've seen this has been asked a lot in deep learning interviews as well. So what are some of the examples of supervised learning algorithms in deep learning is the question. You have to understand that there are 3 main supervised learning algorithms in deep learning. One is ANN's artificial neural networks, then you have CNN and RNN, convolutional neural networks, and recurrent neural networks respectively. So you have to mention the 3 types or the 3 main supervised learning algorithms usages in the field of deep learning as well, and these will cover all of the subfields that come under them. CNN has a lot under it as well. RNN has a lot of types, as we just checked out in the previous set of questions, but then mentioning these 3 should be more than sufficient. Now, there can be a follow-up question to this stating, okay, what about unsupervised learning algorithms? Can you state examples of that in deep learning? Well, yes, there are 3 very main important unsupervised learning algorithms in deep learning. We've checked all of these out. One is the autoencoders, then we have the Boltzmann machine, and of course we have something called as self-organizing maps as well. So these 3 form to be very, very important unsupervised learning algorithms that find a lot of usage in the real world when we make use of deep learning and its concept too. Coming to the 42nd question, it states, can we initialize the weights of a network to start from 0? Can the weight be 0? The answer is very tricky. You might be, leaning to say no, but then understand that the answer is yes. It is actually possible to start with 0 initialization. But then, of course, it is not recommended to use, because setting it up to 0 will make sure that your neurons will be giving the same output and the same descent and the same gradients whenever we go on to make use of back propagation. So the learning is almost next to 0 or next to nothing here. What this means is that your network cannot learn at all if we start with 0, because there is no asymmetry, right? So each of the neurons have to be unique from each other, and they have to do a unique task that is assigned to them. So if everything is set to 0, then when we work with back propagation, there is no way to tell apart from one neuron to the other. So the learning rate is 0, as I just mentioned, and it really doesn't work. But then yes, it is of course possible where you can have 0 initialization done to the weights before working with the network as well. So after understanding this, it becomes very vital that you understand something called as same padding and valid padding in CNN. So you remember CNN is used for image classification as well, and padding is done as a part of working with images. So whenever we perform iterations, with every iteration the images are being shrunken in size. To make sure that they're not shrunken beyond usage, we do padding, where we apply more dimension to the existing matrix, right? So there are 2 types of it. One is valid padding and we have same padding. Valid padding is where it is used where it is where there is no requirement for padding actually. So the output matrix will have the dimension n minus f plus 1 multiplied with n minus f plus 1, which happens after the convolutional state. And with case of same padding, padding elements are common padding elements in fact are added across all of the output matrix as well. So same padding is a situation where we try to match the dimension of the input matrix as well, but then valid padding might not be matched because it can have its dimension on its own, which is calculated by the formula given there as well. So same padding will try to match all of the elements after padding to make sure that your output matrix will have the same dimension as the input matrix. So that is the basic difference that lies between valid padding and same padding. Now, it is very important that you might be asked this question, so make sure to concentrate on this as well. So what are some of the applications of transfer learning in the case of deep learning? Transfer learning is a very popular scenario where we take a large model, we train it with a huge data set, yes, of course, and then we make sure to use this model, which has learnt on very complex data, large amounts of data, to work on simpler data set. So what this does is its efficiency is boosted to a very high extent because it has actually trained on complex data, but it is now working on simple data. So this way it is very efficient, it is very accurate, and in fact transfer learning is being implemented in our daily lives very well as well. But then if you have to talk about the complex use cases of it, we have BERT, we have ResNet, we have GPT-2, we have VGG16, and many other popular examples of where transfer learning are made use of and how efficient and effective they are as well. But then understand the basic working of it. So you train your model on something very complex, but then you actually show simpler data to it at the end of the day where it can work with it effectively and be more efficient too. It's as simple as that. Now with this we can check out the 45th question that states how is the transformer architecture better than recurrent neural networks in deep learning? So, whenever we make use of something called as sequential programming, there are two important things you have to be concerned with. One is how much of processing power you're making use of at every single point of time. And so what is the difficulty that you're facing whenever you have to work with parallel execution, right? So sequential processing will raise these two red flags. And what this does is this actually gave away these two concerns with the primary reasons why we have something called as a transformer architecture now. So in a transformer architecture, we have something called as the attention mechanism. The attention mechanism will take all of the dependencies that are available and it will map in between each of the sentences whenever things have to be processed as well. So when we talk about concepts such as NLP, right, natural language processing, here since the data is mostly sequential, it'll of course bring up the two concerns as mentioned above. But then by making use of these attention mechanism, by mapping all of the dependencies, by making sure your model can recognize these entities faster and map it across to a dictionary faster, let's say, then transformer architecture is very effective as you can think about it. So with this we can check out the 46th question that says what are the steps that are involved in working with an LSTM network, long short-term networks, as we discussed in a couple of questions before. So whenever you're working with LSTM, there is three important steps that you have to think about. The first step is concerned with the network actually picking up all of the information where it has to remember certain things, it has to identify what it has to not remember and what it has to process as well. So that is the first step, where your network has the capability to know what it has to remember and what it has to forget. And then when we come to step number two is where we actually update all of the cell state values, but then updating all of these will depend directly on the outputs of the step one, because depending on what information needs to be remembered or not, the cell state values are updated based on that. The third step in fact also depends on step number two, because here what we're trying to do is getting the network to calculate and analyze what is the current state and which part of the current state should in fact make it to the output and which should not as well. So the most important step is step 3, but then without step 1 and step 2 it is very difficult to directly move on to 3, because you will need what is vital and what is not. Then you have to update the cell state values based on that, and lastly you have to make sure your network analyzes and calculates which part of the current state should make it to the output and which part should not as well. So these are the 3 steps that are very vital in the working of an LSTM network. Now we can come to the 47th question that states what are the elements in TensorFlow that are programmable. So what are the programmable elements whenever you're working with TensorFlow as a deep learning framework? So the answer is very simple. It is very straightforward. In TensorFlow, all the users have the ability to program three main elements. One are the constants, one are variables, and one are placeholder entities. So these three entities are very important that you state out explicitly, because these are the entities that you can program explicitly, program manually, and work with them, depending on whatever model it is that you're working with as well. So after understanding this, we have to check out one more small concept called as bagging and boosting in deep learning. So the question can be, what is the meaning of bagging and what is the meaning of boosting in deep learning? So what happens in bagging is that, we actually take a data set, we split the data set, and we randomly shuffle around, move the data into multiple batches, or in fact, we call it as bags since the term bagging is used, and we use it to train the model as well. And then boosting is a different scenario where we take incorrect data points and we force a model to actually produce a wrong output. We give it a wrong input, we make sure it gives the wrong output. So this way the model has the capability to understand that, okay, this is wrong, and then it can retrain itself and increase accuracy as well. So this is a negative way of teaching the model, but then it works very, very well. If your model can understand what is wrong, that means that it knows what is right. So this way, making use of bagging where we're splitting the data set, or making use of boosting where we are giving it the wrong input and the wrong output derived from it to teach it better, both of these are helping very effectively in the case of working with deep learning as well. Now with this, we can come to the 49th question that states, what are GANs or generative adversarial networks as well? So GANs are again very, very widely used. They are used to achieve this concept called as generative modeling in deep learning. What it is that it is an unsupervised task that basically is involved in a lot of pattern detection and pattern hunting in the data. So whenever we have an input data, we try to see if we can find out any patterns in it and make sense of it and convert it into a meaningful output. So GANs are very, very useful for this. So the generative part of it comes from the generator, where it is used to generate more than one example at a time, while we have another entity called as the discriminator. A discriminator will classify the examples which get generated by the generator. So the two entities, generator and discriminator, and it would add some value to your candidature if you actually mention these explicitly to the interviewer as well. So GANs are again they're very widely used, because whenever you think about it, everything is pattern detection in today's world, right? So GANs have a lot of implementation and a lot of requirement by us as well. Now with this, we come to the last question that states, have you earned any sort of certification to improve your learning and implementation process? Well, the answer to this is very important, because as you might already know, a certification program can give you a lot of advantages. Structured method of learning, a lot of use cases, real-time projects, expert guidance, live classes, and to you this is fine, but then to the interviewer, what they are trying to understand from your certification program is with the certification program, you are trying to show that you want to exceed in your career, that you want to build something, that you want to advance in your career. That is the first important point. The second important point is that, let's say if you're a fresher, if you learned it all on your own without having to learn it in college or something, that shows grit, that shows aspiration. And if you're a person who's moved from another programming language to come into the field of deep learning as well, that again shows very strong aspiration, that you are willing to put some time and effort, and that you've already put time, effort and money into learning all of these as well. And at the end of the day, that adds up to a concept where you're proving yourself to the interviewer that you are effective at what you do and you want to do this. So one very important thing that you have to know whenever you're talking about certification programs, right? So yes, you can list all the certification programs that you have had, but then what will add the most value is to tell the interviewer what you learned and how you used your learning to implement something new. See, because not just certification, any IT concept in the world, right? So we're trying to solve a complex problem using a simpler thing. So we're trying to make the complex problem very simple. So how have you taken a complex problem, how have you worked on it, and how have you simplified it by making use of your certification program is very important to the interviewer, and that is what you should talk about. Explain what you learned from it, explain how you learned and what you took away as well. And here is a small bonus for you guys. Apart from this, what would add a little more value is to make sure that you mention that that you're planning to use your learning in this particular way for that particular company that you're applying for, right? So you would have learned a lot of things. If you put it out in a way where you're telling the interviewer that, hey, I learned all of these and I think I can use it this way to help your company, that will impress the interviewer as well. So that is one very important way on how certifications will help you rapidly increase your career's dimensionality, basically. Well, with that, you have reached the end of this top deep learning interview questions. I take this opportunity to wish you all the best for all the interviews ahead. So you make sure to use this guide to understand how you can approach the questions effectively and how you can answer them precisely and with as much content and quality as possible. Coming to the comparison between artificial intelligence and machine learning, let's break it down into a couple of simple points. The first thing has to be definition. We've already looked at this, so let's quickly glance over it again. Well, basically, in the world of artificial intelligence, the intelligence part of it is actually defined when we talk about, the machines gaining knowledge and, the ability to actually learn something and pretty much apply what it has learned. This particular stored knowledge, that is where the word intelligence comes in. Coming to machine learning, again, machine learning basically involves the process very similar to artificial intelligence, where it's acquiring information, but then it's doing it in a very different way. There's something called repeated learning, where it actually learns on one particular concept again and again to master it and then understand what the concept actually is. Then coming to the second point, which is the technological aim of artificial intelligence and machine learning. Again, when it comes to AI, pretty much AI is concerned about, increasing chances of success in actually mimicking human intelligence. So it at a couple of stages, artificial intelligence is not concerned with how accurate it is, but it's a very different story when you come to machine learning, because when it comes to machine learning strives to increase the accuracy and it would actually sideline the amount of success that it sees, because achieving accuracy in a mathematical model in terms of machine learning is actually a very good priority, and it is actually built for what it's supposed to do, and it does it very well. Coming to the third point, it is basically the goal of artificial intelligence and machine learning. When we talk about the goal of AI, it is to, again, as I've already told you, to simulate natural intelligence, to prove to humans that machines can be as good as humans, and this is done by solving complex problems and whatnot. Coming to machine learning, again, machine learning, the primary goal of machine learning is to actually learn from the data that it actually sees, understand what the data is, then perform certain tasks using the data. Since it does it repetitively, it understands it better and better every time it does it, and this increases the performance of that particular machine. And then the fourth point is how simpleton it actually is. Well, artificial intelligence, put in very simple terms, is basically that it is decision making on steroids, because to a computer what feels like a very complex convoluted entity, it is actually a very simple dumb machine which has been coded by the humankind, right? So artificial super intelligence claims to, if it has ever been founded, or if a machine chooses to start coding another machine, the decision making skills of an artificial intelligence entity will be equal to that of human intelligence or better than that as well. Coming to machine learning, again, machine learning basically allows a system or a computer to learn things from the data it sees, does it repetitively, as you already know it. And coming to decision making, again, as we already talked about it, artificial intelligence is actually concerned with finding the optimal solution to an existing problem, but machine learning is used to see if the problem is actually pretty much optimal to work on or not. So it'll actually try to see if the solution, whatever it's obtained, is actually optimal, it's not optimal, it'll work, it'll not work, and much more. So here's a very subtle difference that you can see on your screen right now when it comes to artificial intelligence and machine learning. And then number 6 on this list is the outcome. So artificial intelligence, again, leads to developing system which basically will mimic human activities in certain circumstances. But then at this point of time, it can mimic everything apart from emotions and much more. In fact, it can detect emotions. That is how good it is. But for it to mimic human level emotion is impossible at this point of time. But then let's not say it's impossible in the future as well, because we do not know what the future holds. And then coming to machine learning involves this entire procedure where you will be creating algorithms which learn on their own. And here's the best part about the comparison: machine learning will help achieve artificial intelligence at the end of the day. So the outcome of artificial intelligence is to equal human intelligence, guys. So this brings us to the 7th point, again, which is a very important point for all of you guys as learners. Because here's the average developer salary of an artificial intelligence developer and a machine learning engineer. An AI developer gets somewhere over 120,000 USD per year, and then an average salary of a machine learning engineer is over $100,000 per year as well. Well, this number is an average number for an associate to a junior or a middle intermediate level programmer. But do know that there are companies out there in the world which will actually pay 3 times, 4 times the number you see on your screens right now throughout the world. So they don't mind where you are, they don't mind what amount they're paying out if you're actually good with the skills and you have the right certification when it comes to especially artificial intelligence, machine learning, and concepts of data science, guys. And then coming to my final thoughts about this particular comparison, well, if it has to be put into one sentence, then know this: artificial intelligence will lead to intelligence at the end of the day, or some sort of wisdom. But if you're talking about machine learning, again, it's all about acquiring knowledge, and this knowledge again is put into use when we talk about artificial intelligence in general. So to summarize the entire thing, guys, artificial intelligence will actually use all of the experience to acquire knowledge, to acquire skills, to learn it and understand how it has to apply all that knowledge. And machine learning will basically use all the experience it has from learning again and again and again to basically look for some pattern, understand what's going on there, to amplify the amount of knowledge it has gained, to see where it's like picking a needle in a haystack. So machine learning is where it's the process of picking the needle in a haystack. Where we're talking about artificial intelligence, it finds the fastest way, it finds the most important way where a human is not required to pick out that needle from the haystack, guys. So coming to when you have to use artificial intelligence, when to use machine learning, here is when you'll be using artificial intelligence. Artificial intelligence is required in situations where there is a requirement of precision, where there is a higher degree of precision is a very important requirement. And then you will use AI when you have faster decision making, logical decision handling, which does not require any human interference, guys. Because at the end of the day, emotions do come into place at a place of work, which might affect at the end of the day the work that the person is doing. But then if a machine does this, again, it cannot understand emotions. So your work will again remain very efficient because of the fact that it cannot have any emotional interference. And then coming to handling repetitive tasks, humans might get bored of doing the same thing again and again, but the machine does not. And then the next point is the reason why AI replaced a lot of jobs in the last year. It is that it can work 24/7, 365 days of the year without taking any single break, unless there's, of course, a breakdown in whatever it's doing. But then without a break, because humans again are very, very limited when it comes to working when you directly compare it to a machine, because machines can go years and years without a single break, but a human cannot, obviously, right? And then coming to risk analysis and risk taking, the machines can actually take a very good calculated decision based on so many things, so much mathematics, so much programming, and much more. Coming to machine learning is actually used where it can see the data and see a trend or a pattern that it can find. And another important reason is that there should be no human intervention here as well. The basic idea is to make the model self-sufficient enough so that it can understand the patterns and trends. And then, if there is a requirement for machine learning, then there'll definitely be some sort of requirement for continuous improvements, continuous learning, and hunting for more knowledge. So this brings us to the point which says that, improvement needed is actually linear. It does not have to be, learn, wait, forget, and no. It has to be learn, and keep going like that. That's what the point basically means. And then coming to the next point, it does not require any human intervention when it comes to adaptation as well. So humans take a lot of time to adapt, so let's say to a new climate, to a new technology they're learning on, everything in general, right? So humans need some time to go about doing that. Machines, well, if there is a requirement where you have to change certain programming language to something else, and nowadays there are tools which can do it automatically for you as well. And then industrial requirement are there, guys. So basically what we're trying to do is we're trying to perform predictive analytics in the world of manufacturing as well, like what product is doing good in what part of the world, why is this car selling so much more. So you have machines which can tell you all of this. You don't need any more humans to look at the numbers, plot graphs, and go about taking a judgment call, which might be a little inaccurate at the same time as well.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Machine learning is the heart of artificial intelligence, and it consists of techniques that lay out the basic structure for constructing algorithms. These algorithms are used to build machine learning models that predict some outcome based on the input. So let's look at the first question. So the first question is, what are the types of machine learning? So there are three types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. So let's see them in detail. So the first is supervised machine learning. In this type of machine learning technique, machine learns under the supervision of labeled data. There is a training data set on which the machine is trained, and it gives the output according to its training. So for example, if a patient is diagnosed for a disease of cancer, so the machine will predict the outcome based on the input or the symptoms as positive or negative. Now the next is unsupervised learning. Unlike supervised learning, it has unlabeled data. So there is no supervision under which it works on the data. Basically, unsupervised learning tries to identify the patterns in the data and make clusters of similar entities. After that, when a new input data is fed into the model, it does not identify the entity, rather it puts the entity in a cluster of similar objects. So you can see over here, the robot tries to identify the object and makes the clusters of similar objects. And whenever a new data is fed into the machine, it tries to identify it according to the cluster identified by it. Now the next is reinforcement learning. So reinforcement learning includes model that learn and traverse to find the best possible move. The algorithm for reinforcement learning are constructed in a way that they try to find the best possible suit of action on the basis of the reward and punishment theory. So you can see in the example, the agent tries to learn from the environment, observes the environment, select action using policy, and it gets a reward or penalty according to its suitable action. So whenever it gets the reward or penalty, it tries to learn the right suitable action according to the environment. Now let's see the next question. So differentiate between classification and regression in machine learning. So in machine learning, there are various types of prediction problems based on supervised and unsupervised learning. There are classification, regression, clustering, and association problems. So here we'll discuss about classification and regression. So in classification, we try to create a machine learning model that assists us in differentiating data into separate categories. So the data is labeled and categorized based on the input parameters. For example, imagine that if we want to make predictions on the churning out of customers for a particular product based on some data recorded. So either the customer will churn out or they'll not. So the labels for this would be yes and no. So this lies under classification problem. Now the next is regression. So it is the process of creating a model for distinguishing data into continuous real values instead of using classes or discrete values. It can also identify the distribution movement depending on the historical data. So it is used for predicting the occurrence of an event depending on the degree of association of variables. For example, the prediction of weather condition depends on factors such as temperature, air pressure, solar radiation, elevation of the area, and distance from the sea. So the relation between these factors assist us in predicting the weather condition. So this was about classification and regression. So the next question is, what is linear regression? So linear regression is a supervised machine learning algorithm. It is used to find the linear relationship between the dependent and the independent variables for a predictive analysis. So you can see the equation over here, that is y equal to a plus bx, where x is the input or the independent variable, y is the output or the dependent variable, and a is the intercept and b is the coefficient of x. So let us see the graph for it. So this is the graph where it is having a best fit line that shows the data of weight that is y or the dependent variable, and height, that is the independent variable, of 21 years old candidates scattered over the plot. So this straight line shows the best linear relationship that would help in predicting the weight of the candidates according to their height. So to this best fit line, we'll try to find the best values of A and B, and by adjusting the values of A and B, we try to reduce errors in the prediction of Y. So this is how linear regression helps in finding the linear relationship and predicting the output. Now let's head on to the next question. The question is, how will you determine the machine learning algorithm that is suitable for your problem? So for identifying the machine learning algorithm for our problem, we should follow these steps. So first is problem classification, second is checking the algorithm, and third is implementing the algorithm. So classification of the problem depends on the classification of input and output. So for classification of input, it depends on whether we have data labeled, that is supervised learning, or unlabeled, that is unsupervised learning, or whether we have to create a model that interacts with the environment and improves itself. For classifying the output, if we want the output of our model as a class, then we need to use some classification techniques. If it gives the output as a number, then we must use regression techniques, and if the output is a different cluster of inputs, then we should use clustering techniques. Now checking the algorithms in hand. After classifying the problem, we have to look for the available algorithms that can be deployed for solving the classified problems. Finally, we'll be implementing the algorithms. If there are multiple algorithms available, then we will implement each one of them one by one, and we'll check for the accuracy. And finally, we would select the algorithms that gives the best performance. Now the next question is, what are bias and variance? So bias is the difference between the average prediction of our model and the correct value. So if the bias value is high, then the prediction of the model is not accurate. Hence the bias value should be as low as possible to make the desired prediction. And the variance is the number that gives the difference of prediction over a training set and the anticipated value of other training sets. So high variance may lead to large fluctuation in the output. Therefore, the model's output should have low variance. Let's see the diagram for it. You can see in the diagram, the desired result is the blue circle at the center. And if we get off from the blue section, then the prediction goes wrong. So the model should have low bias and low variance. And if the model is having low bias, high variance, then very few of the points are lying close to the desired result. And if the model is having high bias and high variance, then the points are not lying close to the desired result. So the model should have low bias and low variance. Now the next question is, what is variance inflation factor? So the VIF is the estimate of the volume of multicollinearity in a collection of many regression variables. So it is calculated as variance of the model divided by variance of the model with a single independent variable. So the VIF quantifies the extent of correlation between one predictor and the other predictor in a model. It is used for diagnosing collinearity and multicollinearity. So higher value signifies that it is difficult and impossible to access accurately the contribution of predictors to a model. Now let's head on to the next question. So we have to explain false negative, false positive, true negative, and true positive. So let's start with true positive. When the machine learning model correctly predicts the condition, it is said to have a true positive value. Then true negative, when the machine learning model correctly predicts the negative condition or class, it is said to have a true negative value. Next is false positive. So when the machine learning model incorrectly predicts a negative class or condition, it is said to have a false positive value. Finally, when the machine learning model incorrectly predicts a positive class or condition, it is said to have a false negative value. Let's understand this with the help of an example. So if an alarm goes on in case of a fire, it is true positive in the sense that there is a fire. That is, the fire is positive and the prediction made by the system is true. Next is, if the alarm goes on and there is no fire, then system predicted fire to be positive, but it made a wrong prediction, hence the prediction is false and the condition is false positive. Next is, if the alarm does not go on but there was a fire, system predicts fire to be negative, which was false since there was a fire. So it is a false negative condition. Finally, if the alarm does not go on and there was no fire, the fire is negative and this prediction was true. So the condition is true negative. Now let's head on to the next question. So what is a confusion matrix? So confusion matrix is used to explain a model's performance and gives the summary of the prediction on the classification problems. So it assists us in identifying the uncertainty between classes. So this is the formula for calculating the accuracy from a confusion matrix. So it consists of true positive, true negative, false positive, and false negative values. So the accuracy is calculated as the sum of the true positive and true negative values divided by all the outcomes. So the accuracy is calculated as the sum of true positive and true negative values divided by true positive, true negative, false positive, and false negative. For example, consider this confusion matrix and it consists of values as true positive, true negative, false positive, and false negative for a classification model. Now the accuracy of the model can be calculated as below. So it is the sum of true positive and true negative value divided by the sum of true positive, false negative, true negative, and false positive values. So the accuracy comes to be 0.78. So the accuracy of the model is 78%. Now let's head on to the next question. So what do we understand by type 1 and type 2 error? So type 1 error is also called as false positive, and it is an error where the outcome of a test shows the non-acceptance of a true condition. For example, a cricket match is going on, and when a batsman is not out and the umpire declares that he is out, this is a false positive condition. So here the test does not accept the true condition that the batsman is not out. Now type 2 error. So type 2 error is also called as false negative, and it is an error where the outcome of a test shows the acceptance of a false condition. For example, the CT scan of a person shows that he is not having a disease, but in reality he is having it. Here the test accepts the false condition that the person is not having the disease. So when should you use classification over regression? So both classification and regression are associated with prediction. So classification involves the identification of values that lie in a specific group, whereas the regression method entails a predicting a response from a consecutive set of outcomes. So the classification method is chosen over regression when the output of the model needs to yield the belongingness of the data points in a dataset to a particular category. We have some names of bikes and cars. We would not be interested in finding how these names are correlated to bikes and cars. We would check whether each name belongs to the bike category or the car category. So that is why we use classification over regression. Now let's head on to the next question. So we have to explain logistic regression. So logistic regression is the proper regression analysis used when the dependent variable is categorical. Like all the regression analysis, logistic regression is a technique for predictive analysis. It gives the output as binary. So logistic regression is used to explain the data and the relationship between one dependent binary variable and the one or more independent variables. Also, it is employed to predict the probability of a categorical dependent variable. For example, if we have to predict whether a citizen is a senior or not, so the output will be in 0 or 1. So there are three types of logistic regression, that is binary logistic regression. So in this, there are only two outcomes possible. For example, to predict whether it will rain or not, it will give the values as 1 or 0. The next is multinomial logistic regression. So in this type of regression, the output consists of three or more unordered categories. For example, prediction on the regional languages like Marathi, Telugu. The next is ordinal logistic regression. So in ordinal logistic regression, the output consists of three or more ordered categories. So rating an Android application from 1 to 5 star, it comes in ordinal logistic regression. Now the next question is, imagine you are given a data set consisting of variables having more than 30% missing values. Let's say out of 50 variables, 8 variables have missing values which is higher than 30%. So how will you deal with them? So to deal with the missing values, we need to first identify the values, and for that we'll specify a different class for the missing values. After that, we'll check the distribution of values over the data set, and we would hold those missing values that are defining a pattern. Finally, we'll change these into yet another class while eliminating the others with the help of eliminating functions available in Python or R. Now, the next question is, how do we handle the missing or corrupted data in a data set? So in Python, there are two methods that are very useful. So we can use these two methods to locate the lost or corrupted data and discard those values. So the first is isNull method. So we can detect the missing values using isNull method. And after that, we can use drop_NA for removing the columns and rows with null values. Also, we can use fill_NA to fill the void values with a placeholder value. Now, let's head on to the next question. So we have to explain principal component analysis. Firstly, this is one of the most important machine learning interview question. So in the real world, we deal with multi-dimensional data. Thus, the data visualization and computation becomes more challenging with the increase in dimensions. So in such a scenario, we might have to reduce the dimension to analyze and visualize the data easily. So we do this by removing the irrelevant dimensions, keeping only the most relevant dimensions. So this is where we use principal component analysis. So finding a fresh collection of uncorrelated dimensions and ranking them on the basis of variance are the goals of PCA. So here is the mechanism of PCA. So we have to compute the covariance matrix for data objects. Then we have to compute the eigenvectors and eigenvalues in a descending order. Next is to get the new dimensions and select the initial n eigenvectors. Finally, we'll change the initial n-dimensional data objects onto n dimensions. So here is an example for it. Here, the two graphs shows the data points and the two directions. One is green and the other is yellow. So we got the graph 2 by rotating the graph 1 so that the x-axis and y-axis represent the green and the yellow directions. So after the rotation of the data points, we can infer that the green direction gives us the line that best fits the data points. So here we are representing two-dimensional data, but in real life, the data would be multi-dimensional and complex. So after recognizing the importance of each direction, we can reduce the area of dimensional analysis by cutting off the less significant directions. Now we'll look into another important machine learning interview question. So why rotation is required in PCA? So what will happen if you don't rotate the components? So rotation is a significant step in PCA as it maximizes the separation between the variance obtained by the components. Due to this, the interpretation of the components become easier. So the motive behind doing PCA is to choose fewer components that can explain the greatest variance in a data set. So when rotation is performed, the original coordinates of the points gets changed. So there is no change in the relative position of the components. So if the components are not rotated, then we need more extended components to describe the variance. Then the visualization and prediction becomes more difficult. So you can see over this graph, the data points, these blue dots represents the data points. And if we rotate the axis to these dimensions, then all the points will lie in this x-axis. So the previous one is x-axis and the new dimension is x-axis where all the data points lies. Now let's head on to the next question. So we know that one hot encoding increases the dimensionality of a dataset, but label encoding doesn't. So how? So when we use one hot encoding, there is an increase in the dimensionality of a dataset. So the reason for the increase in dimensionality is that for every class in the categorical variable, it forms a different variable. Suppose there is a variable called color. It has three sub-levels as yellow, purple, and orange. You can see over here. So one hot encoding color will create three different variable as color.yellow, color.purple, and color.orange. Now in label hot encoding, the subclasses of the certain variables get the values as 0 and 1. So we use label encoding only for binary variables. So this is the reason that one hot encoding increases the dimensionality of data and label encoding doesn't. So you can see over here that in this label encoding, the categorical variables or categorical values are given to the name of the food, and in one hot encoding the 0 and 1 values are given and the separate variables will be created for it. So it increases the complexity of the data. Now let's head on to the next question. How can you avoid overfitting? So overfitting happens when a machine has an inadequate data set and it tries to learn from it. So overfitting is inversely proportional to the amount of data. So for small database, we can bypass overfitting by the cross validation method. So in this approach, we'll divide the data set into two sections. So these two sections will comprise testing and training sets. So to train the model, we'll use the training dataset, and for testing the model, for new inputs, we'll use the testing dataset. This is how we can avoid overfitting. Now let's head on to the next question. Why do we need a validation set and a test set? So this question is similar to the previous one. So we split the data into three different categories while creating a model. The first is training set, the second is validation dataset, and the third is testing dataset. So let's see training dataset. So we use the training set for building the model and adjusting the model's variables. But we cannot rely on the correctness of the model built on top of the training set. The model might give incorrect output on feeding new data. So we use validation set. So we use a validation set to look into the model's response on top of the sample that doesn't exist in the training dataset. Then we will tune hyperparameters on the basis of the estimated benchmark of the validation data. When we are evaluating the model's response using the validation set, we are indirectly training the model with the validation set. So this may lead to the overfitting of the model to the specific data. So this model won't be strong enough to give the desired response to the real world data. So for this, we use the test dataset. The test dataset is the subset of the actual dataset, which is not yet used to train the model. So the model is unaware of this dataset. By using the test dataset, we can compute the response of the created model on hidden data. So we evaluate the model's performance on the basis of test dataset. So we do not always expose the model to test dataset after tuning the hyperparameters on top of the validation set. As we know, the evaluation of the model on the basis of the validation set would not be enough. Thus, we use a test set for computing the efficiency of the model. Now, let's head on to the next question. So what is a decision tree? So a decision tree is used to explain the sequence of action that must be performed to get the desired output. So it is a hierarchical diagram that shows the actions. So you can see the diagram over here. So we can create an algorithm for a decision tree on the basis of the hierarchy of actions that we have set. So over here, you can see we are checking whether a person is fit or not. So the parameters are, the first one is, we'll check whether the person's age is greater than or less than 30. So if it is yes, then we check for eats a lot of pizzas. So if this condition is true, then the person is unfit. And similarly for this, if the person is greater than 30, it checks for exercises in the morning. And if it is yes, the person is fit. So this is the working mechanism of a decision tree. So let's head on to the next question. So we have to explain the difference between KNN and K-means clustering. So K nearest neighbor or KNN, it is a supervised machine learning algorithm. And in KNN, we give the identified or labeled data to the model. Then the model matches the points based on the distance from the closest point. So you can see over here, these are the matched points according to the centers. And for K-means clustering, it is an unsupervised machine learning algorithm. So in this, we give the unidentified or unlabeled data to the model. Then the algorithm tries to create the batches of points based on the average of the distances between the distinct points. So you can see over here, these clusters are formed. So this is the difference between KNN and K-means clustering. Now the next question is, what is dimensionality reduction? So in the real world, we build machine learning models on top of features and parameters. So these features can be multi-dimensional and large in number. Sometimes the features may be irrelevant and it becomes a difficult task to visualize them. So here we use the dimensionality reduction to cut down the irrelevant and redundant features with the help of principal variables. So these principal variables are the subgroup of the parent variable and it conserves the feature of the parent variable. Now let's move on to the next question.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
Both being tree-based algorithms, how is random forest different from gradient boosting algorithm? So the main difference between a random forest and GBM is the use of techniques. They both use different techniques for implementing. So random forest advances prediction using a technique called bagging, and GBM uses boosting to advance the predictions. So let's check each one of them. So in bagging, we apply arbitrary sampling and we divide the data set into n samples. After that, we build the model by employing a single training algorithm. Further, we combine the final predictions by pooling. So bagging helps to increase the efficiency of the model by decreasing the variance for overfitting. Now let's see boosting. So in boosting, the algorithm try to review and correct the inadmissible predictions at the initial iteration. After that, the algorithm's sequence of iteration for correction continues until we get the desired prediction. So boosting assists in reducing bias and variance both for making the weak learners as strong learners. Now let's move on to the next question. Suppose you found that your model is suffering from high variance. So which algorithm do you think you could handle this situation and why? So for handling the issues of high variance, we should use bagging algorithm. So what it does is it splits the data into subgroups with replicated sampling of random data. And when the data is splitted into subgroups, we create rules using particular training algorithms. And finally, we use pooling for combining the predictions of the model. So you can see the diagram. the data is divided into subgroups as bootstrap 1, 2 till n, and the models are created as model 1, 2 according to the training algorithms, and finally they vote for the final prediction. Now the next question is, what is ROC curve and what does it represent? So ROC stands for receiver operating characteristic. So we use ROC curve to represent the trade-off between true and false positive rates. So in ROC, the area under curve gives us an idea about the accuracy of the model. So you can see the graph. So this graph shows an ROC curve. So the greater the area under the curve, better the performance of the model. So let's move on to the next question. So what is rescaling of data and how is it done? So in real world scenarios, the attributes present in the data will be in a varying pattern. So rescaling of the characteristic to a common scale gives benefit to algorithms to process the data efficiently. For example, if a student is gaining marks out of 100 as 60 in subject 1, out of 150, 120 in subject 2, and 180 out of 200 in subject 3. So after rescaling, the marks will be out of 10. So in subject 1, he'll get 6 out of 10. In subject 2, he'll get 8 out of 10. And in subject 3, he'll get 9 out of 10. So this is how rescaling gives us the benefit to rescale the data in a common scale. Now let's move on to the next question. So what is binarizing of data? So in most of the machine learning interviews, so this question is asked. So I'll give you an example. So first of all, converting data into binary values on the basis of threshold values is known as the binarizing of data. So the values that are less than the threshold are set to 0 and the values that are greater than the threshold are set to 1. So this process is useful when we have to perform feature engineering, and we can also use it for adding unique features. So here, if a student A in subject 1 gets 60 out of 100, in subject 2 he gets 20 out of 100, and in subject 3 he gets 70 out of 100. So if the threshold is set to 40, so if the marks are greater than 40, then the student is passed, or if it is less than 40, then the student is failed. So after binarizing, we'll get the output as 1 and 0, from which we can decide whether the student is failed or not. Now let's move on to the next question. So how to standardize data? So standardization is the method that is used for rescaling data attributes, and the attributes would likely to have a value of mean as 0 and the value of standard deviation as 1. So the main objective of standardization is to prompt the mean and standard deviation for the attributes. So we'll implement standardization using Python. So let's move on to our Jupyter notebook. So this is our Python code for standardization. So we have imported the NumPy library and matplotlib.pyplot and pandas. So we'll be using the pre-processing in Python. So we'll be importing it from sklearn package. So basically pre-processing is used. It is a package that provides several common utility functions and transformer classes to change raw feature vectors into a representation, and that will be more suitable for downstream estimators. So in general, learning algorithm benefit from the standardization of the data set. So this is the use of pre-processing. Then we'll load the data set. So I have loaded the data set using pd.readcsv. After that, we'll have a look at the original data. So the original data is over here. So it denotes the scientific values. So we have to do min-max scaling, or it is called rescaling of the data. So for this, we'll use min max scalar. So we'll be storing it in min underscore max underscore scalar. So pre-processing dot min max scalar, and the range of the feature will be from 0 to 1. So values will be stuffed in between 0 and 1. After that, we'll use this fit underscore transform to fit the value of the data and transform it into a format. So let's have a look at the values after min-max scaling. So you can see the values are between 0 and 1. So these are rescaled. Now we'll look at standardization. So we'll use standardization, and we'll use this object of standardization and store this standard scalar in it so that we can use it afterward in standardization. After that, for scaled feature, we'll use this object as x underscore after standardization to store the values that are standardized. So after printing the values after standardization, the output would look like this. So the negative values are the values that are less than mean, and the values which are positive are greater than the mean. Now let's move on to the next question. So executing a binary classification tree algorithm is a simple task, but how does a tree splitting takes place? How does tree determine which variable to break at the root node and which at its child nodes? So Gini index and node entropy assist the binary classification tree to take decisions. So basically the tree algorithm determines the feasible feature that is used to distribute the data into the most genuine child nodes. And according to Gini index, if we arbitrarily pick a pair of objects from a group, then they should be of identical class and the possibility for this event should be 1. So to compute the Gini index, we should do the following. So we should compute the Gini for subnodes with the formula as the sum of the square of the probability for the success and failure. So that is p square plus q square. Then we have to compute Gini for split by weighted Gini rate of every node of the split. Now we'll see entropy. So entropy is the degree of indency that is given by the following. So this is the formula for entropy, where A and B are the possibilities of success and failure of the node. So when entropy is equal to 0, the node is homogeneous. And when the entropy is high, both groups are present at 50-50% in the node. Finally, to determine the suitability of the node as the root node, the entropy should be very low. Now, let's move on to the next question. So, what is support vector machines? So, support vector machine is a machine learning algorithm that is majorly used for classification. So, it is used on top of the high dimensionality of the characteristic vector. So, we'll implement SVM using Python. So, let's move on to our Jupyter notebook. So I've written this code. So first we'll import datasets from the sklearn package, then confusion matrix, as we will be calculating the accuracy of the model, and train test split from sklearn.model selection, because we'll be splitting the dataset into train and test set. So we'll use the iris dataset for this. So I'll load the dataset and I'll store it in iris.data and iris.target. Then we'll be splitting the data set into train and test set. So we have separated the data into data and target and stored it in A and B. So we'll be creating separate test and train data set for it. So we'll be using train test split function for this, and we'll give the argument as A, B, and random state will be 0. After that, we'll import svc from sklearn.svm to implement the model. So we'll build the SVM linear model by using the SVC function and store it in SVM underscore model underscore linear, where kernel will be linear and will give the data as trained data set. After that, we'll predict the model's outcome using the predict function and give the argument as test. Finally, to calculate the accuracy, we'll be using the score function. So we'll be using this SVM model linear dot score and give the argument as A underscore test and B underscore test. So after that, we'll get the confusion matrix. So we'll be using the confusion matrix function. So this will be our output. So this is our output that we get. And using this confusion matrix, we can calculate the accuracy of the model. Now, let's move on to the last question of this machine learning interview questions tutorial. So we have to implement KNN classification algorithm. So the problem statement is classify the iris flower based on sepal and petal length and widths using KNN. So we already know that it is a supervised machine learning algorithm, and in it we give the identified or labeled data to the models, and then the model matches the points based on the distance from the closest point. So let's move on to our Jupyter notebook for implementing this. So this is our code for implementing the KNN classification algorithm. So we'll load the iris dataset from sklearn.datasets. Then we'll be importing kneighbors classifier, which will help us in implementing the KNN classification algorithm. We'll import NumPy and then train test split so that we can split the dataset into train and test dataset. Then we'll load the iris dataset and store it in iris underscore dataset. After that, we'll be splitting the dataset into train and test using the function of train underscore test underscore split. After that, we'll use kneighbors classifier and we'll store it in kn object. Then we'll fit the model on top of training dataset, that is A underscore train and B underscore train. After that, we'll be creating a new array and store the values of the characteristics of the flower in A underscore new. Then for predicting, we'll use this predict function to predict the outcome using the A underscore new dataset. After that, we'll be printing the predicted target value, predicted feature name, and the test score, which will give us the accuracy of the model. So the model has predicted that the feature name is Satosa and the test score is 0.97. That means the accuracy of the model is 97%.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.